Hi guys, I welcome you all to the live session on top 3 programming languages by Intellipaat. So today we have with us my colleague who is a tech enthusiast and would answer to few of the questions before taking up programming languages. Hi Cody, I welcome you to the session.
Hi.
So, which is the most used programming languages?
Okay. So that depends because everybody uses a different programming language for what they need. So it's basically what the person needs and they choose the programming language according to it. But according to the survey conducted by Stack Overflow last year, so it was JavaScript which was the most used or the most popular programming language among developers, because when you try to create a web application, you somehow use JavaScript in some place. But again, Python is overtaking all other languages because Python is basically aids in data science, machine learning and artificial intelligence, and those fields are taking up, and because of that Python is coming up every single day. But again, JavaScript is currently the most popular language.
So, as a beginner, how would you suggest on taking up a programming language?
Okay, so first of all, you can take up any programming language. No programming language is obviously bad. You can take up C programming language, or you can take C++, Java, Python, or any language. But I would suggest you to take up Python if you want to get into any field or multiple fields. If you want to get into data science, machine learning, artificial intelligence, or something like that, I would suggest you to take up Python because Python is the trending language currently. And if you learn Python, obviously you will get chances even in web development because of the Django framework. And Python can aid in so many different areas in the IT sector. So Python would be the programming language I would suggest you to start off with.
So my next question for you is, why is Java still so popular?
Okay, so first of all, Java is a platform independent programming language. That basically means Java can run on literally any platform you have. So Java is on your mobile phones, Java is on your laptops and your operating system. It's in every single possible way. You can use Java to build websites. You can use Java to build Android applications. So now, if you consider it that way, Java is everywhere, and that's why Java is still popular. Java developer jobs are still available in every single company because Java is somehow used in one way or another in most of the applications. So that's why Java is still popular, and that's why people prefer to take up Java instead of other languages as well.
So before moving on with the session, please subscribe to our channel.
And also, if you want our upcoming videos, please press the bell icon. And also, if you enjoy our content, leave a like. So before we start off with this session, let's look at the top 3 programming languages we're going to learn. So first we'll start off with Python, and then Java, and finally JavaScript. So now, it's not in any particular chronological order, but as far as we know, Python is currently the trending language, and people are using Python for so many different things, from data science and artificial intelligence, machine learning, and in so many different places. Even Java is still popular. Then even JavaScript is currently used in all aspects of web development. You cannot build a website without JavaScript. So these are the 3 languages we're going to look into in this particular session. So now let's look at them one by one. So first, Python. So Python is a general purpose programming language which can be used for so many different purposes, but primarily it is used for data science and scripting. It can also be used to create web applications using web frameworks like Django and Flask. Next, looking at Java. Java is a fully object-oriented programming language which is popular even right now because it is platform independent. You can run it on any machine you want to. So Java is still popular because it's used in various aspects. It mainly dominates the services and banking industry. So now you can use Java for web applications, mobile applications, data analysis, and data streaming, and there are so many different aspects to it. Now finally, looking at JavaScript. JavaScript is a text-based scripting language which can be used for both client-side and server-side scripting. Now, JavaScript basically tells HTML and CSS on what to do. So basically, it creates dynamic web pages. Now, JavaScript is widely used in web development. It also is used in other places, for example, to code Arduino, and there are so many other aspects where you use JavaScript in software development. but mainly it is used for creating dynamic web applications. So now JavaScript has so many different web frameworks. For example, there is React.js, which is supported by Facebook. There is AngularJS, which is supported by Google. So there are so many different frameworks which you can use and start off with in JavaScript, and that is the main reason it is currently popular, because every single company who uses a website uses JavaScript for their front end. Now, looking at all these three languages, these three are the top three programming languages which you're going to look into, and I would suggest you start off with Python in these three, because Java or JavaScript is a little complicated to learn at the beginning, but Python is a very simple programming language which you can easily start with. So that's the language you're going to start off with right now. So now, without any further delays, let's begin with this session.
So what is Python? Well, Python is a high-level object-oriented programming language for general-purpose programming. It is one of the most widely used high-level programming language and is well known for executing basic tasks with less code, which makes it more compact and an economical language to learn. If you see, Python code is often 3 to 5 times shorter than the Java codes, and around 5 to 10 times shorter than C++ codes. Well, if you talk about its history, it was developed by Guido van Rossum in the year 1991, and since then its open source community is still growing. So how do you think he came up with this name? Was it because of a snake? Well, no. Rossum named Python over the name of a sitcom TV series, Monty's Python Flying Circus. It seems he was highly impressed with the show, right? So these were some of the high-level introduction to Python. Now, a question might arise in your mind that what made Python so popular, or why you should learn it. So let's discuss it one by one. So the first point we have is simple and easy to learn. Well, if you compare Python with any other language, for example Java or C++, you'll find that its syntax is way lot easier than them. You don't have to worry about the missing semicolons in the end. And its syntax is more readable, and you are safe from writing multiple lines of code just for printing a statement, like in case of Java. If you talk about Python, all you need to write is just one line of statement. For example, print, and within the double quotes, mention whatever you want to print. So this is how it is simple and easy to learn. The next point comes the career opportunity. Well, like I told you in the beginning of this video itself, that Python has a huge career opportunity in the IT industry. Almost every other IT company, be it a startup or a multi-billionaire company, are using Python in some or the other ways. So if you're a Python developer, you will be in a huge demand for a wide range of jobs in the domain of machine learning, databases, data analysis, cloud infrastructure, website designing, website reliability, testing, scraping, security, mobile developments, and many more. If you don't trust my words, just go and look out for Python developer job on any major job website. You will find thousands of job opportunities out there with an average salary of around $116,000. This indicates that there are many companies out there who are competing to hire a knowledgeable Python developer for them. So yeah, you have a huge career opportunity in Python. It all depends on your skill. Alright. Next is large open source community. Well, if you become a Python developer and when you are stuck or you want to learn something new, then you don't have to worry about it. You'll find a large number of resources like reference manuals, books, tutorials, videos, forums, etc. out there on the internet. If you have any doubt or some technical issues, you can directly seek help from thousands of Python community members on forums, Twitter, Facebook, and pretty much everywhere. Now, since Python is an open source community, you will always find people who are trying to improve it, keeping it fresh and up to date with current trends and bringing out newer version of the language. Right? So yeah, it has a damn large open source community. Next we have is reliable and efficient. Ask any Python developer or anyone who has ever used the language, and they will agree that it's speedy, reliable, and more efficient. You can work with and deploy Python applications in nearly any environment, and there's little to no performance loss, no matter what platform you work with. Again, because it's versatile, this also means that you can work across several domains including web development, desktop application, mobile applications, and many more. You're not bound to a single platform or domain, as it offers the same experience almost everywhere. Alright, so next we have is the extensive library. Well, Python has a huge set of library list which would be useful for any programmer interested in Python depending on their area of interest. For example, you have NumPy for scientific computing, Plotly for data visualization, NLTK for natural language processing, Django for web framework, Pygame for game development, and there are many more. It can be used in a lot of places and has a wide variety of application. Like for web development, you can use Python web framework like Django, Flask, and Tornado. If you are into developing desktop application, you can go with PyGTK and Copo. If you are planning to use Python in the field of machine learning or deep learning or data science, you'll find many Python libraries for it. Like sklearn, TensorFlow, Theano, NLTK, and many more. If you talk about cloud and DevOps, you can use OpenStack Python Software Development Kit, which is generally used to write Python automation scripts to create and manage resources in your OpenStack cloud. You can even use a Python library named Fabric for streamlining the use of SSH for application development or system administration tasks. Alright, last what we have is hardware programming. Next, if you're planning to switch over to hardware programming, you have Raspberry Pi to connect your project to the real world with Python. Well, now that you know how important is Python to the world, let's see the popularity of Python in industry. Well, big tech giants are using Python. In fact, Python is one of the Google's favorite languages. They are always hiring experts in it, and they have even created many of their popular products with it. Well, I don't think I should again mention that since many big companies like Yahoo, Facebook, Netflix, Dropbox, YouTube, BitTorrent, NASA, and many other rely on Python developers. So these companies are always in search of talented professionals who have already worked on and have some experience in Python. There is and there always be a demand for Python developers and Python web developers, and they are even offered some decent packages. So in this Python certification series, we'll understand how to install Python on your machine. I will also teach you to set up your Jupyter Notebook environment for performing demos and hands-on in our course. So the very first thing that we'll be doing is installing Python on our system. So I have already installed Python in my system. For those of you who don't have it, you can download it and get it installed from its official website www.python.org/download. So let me just show you how easy is it to install Python on your system. Let me open my default browser and I'll write here www.python.org/download. So as you can see here, we have a download option of download Python 3.7.1. If you want a different version for Windows, Linux or Mac, you can just click over to these links. For example, if I am a Windows user and I want a different version of it, then let's see. I click the link and you can download different versions of Python from here. So the first two options that we got up here is latest Python 3 release, Python 3.7.1 and latest Python 2 release, Python 2.7.15. Now these are the two popular versions of Python. Now which version should you download? Well, I have installed Python 3 in my machine. In the past, there was a bit of debate in the coding community about which Python version was the best one to learn, Python 2 or Python 3. Specifically Python 2.7 or Python 3.5 or 3.7. Alright, let me just tell you, Python 2 has been most popular version for a decade and a half and is still in demand at certain companies. However, more companies are moving from Python 2 to Python 3. For example, in 2017, Instagram migrated the majority of their Python code base from Python 2.7 to Python 3. As with each newer version of Python, it is getting a faster runtime. On the other hand, nobody is currently working on to make Python 2.7 work faster. Also, the community support for Python 3 is more better. So for someone who wants to learn Python programming for beginner, I'd suggest that you should avoid spending time on a version that is becoming obsolete. Well, let's download Python 3 for Windows. So let's directly jump up to our first window and click on download Python 3.7.1. Download it. So yeah, it's downloaded. Just click over the .exe file and follow the installation step and it will get installed. Click it. Click on the install now version. Select the drive where you want to install it and click on the next, and it will be installed on your machine. Alright, so let's click on the install now option. Yes. And the setup will install Python on my system. Well, if you are starting Python, you will find that you will have various options where you can write down your codes and get it executed. By default, we use the Python CLI. You can use any text editor like Notepad or Notepad++, or you can even use any Python IDE like Anaconda, which has Jupyter Notebook and Spider pre-installed in it. Python is majorly based on indentation, so these IDEs will help you a lot while coding and debugging your program. So by then my setup was successful. Let's close it. For this tutorial, I'll be using Jupyter Notebook, which is a web-based application that will allow me to write my Python codes on it. It's very to use and it gives me an interactive data science environment. Alright, if you're installing Jupyter Notebook and Python, I would strongly recommend you to use the Anaconda distribution, which already includes the Python, the Jupyter Notebook, and other commonly used packages for starting with Python. Alright, so for downloading it, let's visit the website www.anaconda.com/download. Let's open our default browser, www.anaconda.com/downloads. So as you can see, we have a download option up here. Just click over it and your installation will start. Open the downloaded file and follow this series of steps and install Anaconda on your machine. Alright. So for me, I have already installed Anaconda on my system. So let me just go over there and open it. Anaconda Navigator. This might take some time to start. So this is how the Anaconda Navigator looks like after the installation. From here, I'll select my Jupyter Notebook and hit the launch button. My Jupyter Notebook will open in my default browser. So here's my Jupyter Notebook. It opened on the local host with port number 8889. So this is how the Jupyter Notebook will look like. So from here, go on to the new, select Python 3 from the notebook. And this will redirect you to the Python notebook page where you can write all the different sorts of Python codes on it, ranging from a beginner level to an advanced one. Now that we have set up our environment for coding, let me just give you a glimpse of how easy is Python. You want to perform addition? It's as simple as 1 plus 2 equals 3. That's it. All you need to do is 1 plus 2 and hit enter. You'll get the output. So in this Python certification series, we'll learn about Python variable and Python token. Let's discuss them one by one. So our first topic is Python variable. How do you think the value is assigned? Well, for assigning the values, there are two different methods. First is assigning single value to a variable, and the next is assigning multiple values to a variable. So let's start with assigning single value to a variable. You know what? Unlike Java or C++, you don't have to add any data type for a variable. Just specify the name of the variable, for example, a equal 10. So depending on your data, Python will automatically detect the data type of your variable, which in this case is integer. Alright, let's see another example. Suppose we have a name as Victor. So Python will automatically detect that this name variable is of data type string, since it stores the string value. Alright, next we have salary as 2000.23. So since 2000.23 is nothing but a floating type, so automatically Python will detect that salary is of a data type float. You don't have to specify a data type to a variable. Alright, let me just show you this example in our Jupyter Notebook. For example, I need to store an integer value. So I'll name a variable like a equal 10. 10 is integer and I'm not specifying any data type for it, right? Hit enter. Since no error is appearing, so I guess it's correct. But what if I just write int a equal 10? So as you can see, it gave me an invalid syntax. So you cannot use any data type before a variable. Alright. Next, what if I want to store a string variable? Just like name equal John. Alright, hit enter. Similarly, for a floating data type, salary or any variable name equal 2023.234. Alright, it's as simple as that. Alright. So now that you have learned how you can assign a value to a variable, let's see how you can have multiple assignment to a same variable. Alright, so let's suppose you are assigning three variables as a equal 10, b equal 10, and again c equals 10. So here we have three variables, and what you have to do, you have to assign the same value to all of them. So instead of assigning value one by one, what you can just write? You can just write a equal b equal c equal 10. Alright. And it will be executed without any error. Fine. Now this was simple. Now what if you have to assign different value to each variable? For example, I have a variable as x equal 20, y equal 30, and z equal 40. So in this case, what you can do for multiple assignment, you can just write x comma y comma z equal 20 comma 30 comma 40. It's as simple as that. Now let me just print any of the two variables and check if we are correct or not. So let's print y and let's print a. So yeah. So we got the output as 30 and 10. Y equal 30 and a equal 10. Even if you want, you can just check it by updating the value, like a equal b equal c equal 20. And this is, make it something else, like 40 and 50. And now print the value of y and a. So you'll get the value as 40 and 20. Alright. So this was about the assigning single value to a variable. We also learned about assigning multiple values to a variable. A equal b equal c equal 10, and this example we already did, right? And we got the output as 2010. Fine. So now that you know how you can assign value to a variable, so let's move ahead and start our discussion with some basics of Python. So I'll start with Python token. So what exactly is this Python token? Well, Python token is the smallest meaningful component, or it is a very basic component of the source code. The characters are categorized as one of the four classes of tokens that describe their functions. It can be a keyword, it can be a literal, it can be an identifier, or it can be an operator. Fine. So let's discuss them one by one, starting with keyword. So what are these keywords? Well, these keywords are some sort of reserved words which are designed for a specific purpose. You cannot use a keyword as a variable name or an identifier name. Some of the keywords in Python include for, if, del, break, continue, true, false, etc. You cannot use them as your variable. These words in Python have a specific purpose and have a specific meaning to it. Alright, let's move ahead. Next is the identifier. Well, it is the name which you give to your variable or to your function or to your class. For example, if you are defining a variable as a equal 10, then the word a or the variable a is defining the identifier. Alright. Well, before you start naming your variables or methods or class, you must know that there are certain set of rules or guidelines for naming an identifier. Let's see them one by one. So the first one is no character except the underscore can be used as an identifier. So what does that mean? Let's see. So you cannot have a variable name as 80@123 equal something, any value. You cannot have a variable name like this. It will throw you an error. Alright. Or you cannot even have a variable like 80.we equal 20. Even this will throw you an error. Alright. But instead of it, if you write 80_we, this would be perfectly fine. Alright. Next is keyword should not be used as an identifier name. This I told you earlier also, right? It's like if you are mentioning some keywords like if equal 10, obviously this will throw you an error. Or you're writing while equal 10, then this will give you an error. You cannot use any keyword as a name of an identifier. That is a name of a variable, a class, object, or a function. Alright. Next is Python is case sensitive. That is VAR with capital V and VAR with small v are two different identifiers. Let me show you this. Suppose I mention a equal 20 and capital A equal 10. So what do you think the value should be if I print A? Would it be updated to 10 or would it be same as 20? Well, let's see. So the output is 20. So it means that small a or the a in smaller case and a in uppercase both are treated differently in Python. Print capital A. Alright. So let's move ahead. Next and the last one is first character of an identifier can be a character underscore but not a digit. Well, what does this mean? 1 to 80 equal 10. This is wrong. 1 to or 41 at the rate RAC equals something. Even this is wrong. But what you can do instead, you just specify underscore before this. Underscore 41 RAC without the at the rate part, as no special character other than underscore is allowed, equal 10. So this thing will be accepted without any error. Fine. So this was all about the identifiers. Next comes the literals. Well, literals are the constant used in Python. Or you can say that literals are the data given in a variable or a constant. Basically, there are 4 different types of literals: string literals, numeric literals, boolean literal, and special literal. Let's have a look at them one by one. Starting with string literals. Well, you can create a string literal just by enclosing a text within the code. Both single and double quotes are allowed in a string literal. For example, you can have a variable as name1 equal double quotes John, and you can even have a variable as name2 equal within single quote John, or maybe James. Both are correct. You're not getting any error, right? So since you are not getting any error in the output, so it verifies that you can use both the single and double quotes in string literal. Okay, now what if you have multiple line input? So how will you print that? Let's see for a multiple line input. Multi-line equal. So all you need to do is mention 3 single quotes. Just 3. Alright. And after that, start writing like string 1, enter different line, string 2, line 3, string 3, and so on. Alright. And again, you have to end it using 3 quotes. Fine. Execute it. You won't get any error. And if you print the multi-line.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
You'll get the output as str1, str2, str3 in 3 different lines. Alright, let's get back to our tutorial. So what was our input? Name1 equal John, name2 equal James, print name1, name2, and we got the output. Yeah, we discussed this. We have a multi-line thing within triple quotes. You had a multi-line thing in which you needed the output in 3 different lines. So yeah, you got it using 3 quotes. Alright, fine. So this was about the string literal. Later in this session, we'll see what are the various other functions you can perform on the string literal using some of the Python's existing library. For now, let's move ahead and let me give you an overview of numeric literal. So what are these numeric literals? A numeric literal is a character string whose characters are selected from the digits 0 to 9. It consists of a signed character. It can be either positive or negative, or it can even contain a decimal point. Well, if the literal contains no decimal point, then it means that it's an integer. If your number is too long and we add capital L or small l at the end of the number, it makes it a long number. Or if the literal contains a decimal point, it becomes a float. But yes, remember that you can only use one decimal point in a number. Have you ever seen a number with more than one decimal point? Never, right? Well, just for the FYI, I'm not talking about the IP. Alright. By the way, in Python, the value of an integer is not restricted by the number of bits. It can expand to the limit of the available memory, and since the value of the integer depends on the available memory, so no special arrangement was made in Python for storing large number. So any doubt up till this portion? Well, if you have, please add it in the comment section below. Alright. So moving on ahead, next we have is the Boolean literal. Well, these Boolean literal have just 2 values, either true or false. Well, remember that both these true and false are also a keyword, so you cannot use them as an identifier. They are generally used when we are dealing with some condition whose outcome is either true or false. Alright, so this was about the Boolean literal. Next we have is the special literal. Well, Python has just one special literal as none, which is used to specify the field that is not created. Well, if you are from a programming background or you just have a basic knowledge about C, C++ or Java, I think you must have heard about the keyword null, right? Well, if yes, then this null is nothing but the equivalent of null keyword in C, C++ or Java. Alright, so I hope that you guys have understood about literal. Well, there are many cases where you can use none. Let's see an example. It's a self-explanatory example, just go through it and we'll proceed. Alright, nothing needs to be explained in this. Under Python token, we covered till little part, right? So what are these operators? Well, these are some specific character which have a specific task to perform. And based on the function and the task, the operators are further segregated into 7 different types of operators. Arithmetic operator, assignment operator, comparison operator, logical operator, bitwise, identity, and membership operator. Fine. So let me discuss them one by one. So starting with arithmetic operator. Well, arithmetic operators are the one which is used to perform some arithmetic calculation. So what it does, it takes 2 operand to perform operation on them. For example, 2 plus 3. So here 2 and 3 are operand, and the character plus over here is nothing but arithmetic operator. Alright. So there are other arithmetic operators too, like plus, minus, multiplication, division, mod. All these characters are a part of arithmetic operator. Let me just show you one more example. Like 1 plus 2. So here 1 and 2 are the operand, and plus here is a arithmetic operator. 1 minus 2. Again minus is a arithmetic operator. 2 mod 1. Mod is what? Arithmetic operator. Alright, let's move ahead. Next we have is the assignment operator. Well, this assignment operator is used to assign a value to a variable. The character which comes under this operator are equal to, plus equal to, minus equal to, multiplication equal to, and etc. For example, you declare a variable as var equal 10. So this equal to is your assignment operator and is used to assign value to a variable. Let's get back to our Jupyter notebook and learn more about it. So for example, I'm defining a variable var equal 10. So this equal to is nothing but a assignment operator. Var plus equal 10, again an assignment operator. But what does this mean? So what does this mean? Well, it means that var equal var plus 10. Alright. So if you print the value of var, what do you think the output should be? Well, you'll get the output as 20. Since the value of var is already 10, so 10 plus 10, it's 20. So the updated value of var is 20. Similarly, you can perform var minus equal to 10 and again get your value printed. So again, the updated value of var would be 20 minus 10, 10. So this plus equal to or minus equal to, it is generally named as a shorthand, which means add or subtract and assign value to self. Alright. Same example is mentioned over here, like a equal 10, a multiply equal to 10. So it means that a equal 10 into 10. When you print a, you'll get the output as 100. Alright. So next we have is comparison operator. Well, it is used to compare two values and it returns true or false as the output. Alright. The operators which are a part of it are less than, greater than, less than equal to, greater than equal to, or not equal to. For example, let's see what example we have up here. A equal 10, b equal 20. A is greater than b. Obviously 10 is not greater than 20, right? So it is giving me false as the output. Alright, fine. So let's move ahead. Next is the logical operator. Well, these logical operators are used to perform some logical calculation. And the operators or the keywords which are a part of it are and, or, and not. For example, we have a equal 10 is less than 10 and 2 is greater than minus 1. Then print a. So you are getting output as false. Okay. Let's jump back to our Jupyter notebook and see why we are getting the output as false. So you had a equal 10 is less than 10 and 2 is greater than minus 1. So if you see, we have two comparison operator up here. So what is the value of 10 less than 10? Since it is a comparison operator, so it will give me a false, right? 10 is not less than 10. And 2 is greater than minus 1. This is true. So you can summarize this as false and true. Alright. So since it's false and true, therefore it equals to false. Well, how? Well, do you remember the binary calculation that you have learned in your college? It's like 1.1 equal 1 or 1.0 equals 0 or 1 and 1 equal 1 or 1 and 0 is 0. So consider true as 1 and false as 0. So false and true is false. Alright, that's why you got the result as false. Now if you print the value of a, you'll get the output as false. Alright, so next we have is the bitwise operator. So this operator is used to perform the bitwise calculation. This operator includes and, or, left shift, right shift, not. Alright, so let's see their use one by one. Let's see the example what we have up here. So we have 7 or 5, the output is 7. 7 and 5, the output is 5. So how do you think we are getting this output? Let's see the calculation. So how it is calculated. So if you convert 7 into its binary form, it's 111. And if you convert 5 into its binary form, it's 101. Now if you are performing OR, so basically you are performing a binary addition on it. And if you are performing an AND, you are performing a binary multiplication on it. Alright, so let's see. So if you are performing a binary addition on it, so 1 plus 1 is 1. 1 plus 0 is again 1. And again 1 plus 1 is 1. So that's why you are getting the OR of 7 and 5 as 7. Even you can verify this using the calculator. Open a calculator. Yeah, it's a programmer calculator. So 7 or 5. So you'll get the output as 7. So it's correct. Fine. Next operator that we have got up here is tilde operator or the not operator. Well, this operator is used to perform a not operation. So what is not of 7? What is not of 7? It's minus 8, right? How it is minus 8? Let me just show you using a notepad. Let's open notepad. Alright. So 7 in its binary form with 4 bits, what it is? 0, 1, 1, 1. Alright, if you perform a not of 7, that is not of 7, what you will get? All the bits would be switched. Like 0 would be converted to 1, again 1 to 0, again 1 to 0. So you'll get 1000 and automatically a negative sign would be added at the beginning. So you'll get minus 1000 in binary form, which you convert into decimal, you'll get it as minus of 8. Alright, that's why the output of not of 7 is minus 8. Fine. Next is the left shift and right shift operator. Let's see what is the output first. For example, I'm trying for a right shift. Then 10 right shift 2. What is the output? It's 2. Let's see how we got the output as 2. Open our notepad. Let's remove this. So 10 in its binary form, what it is? It's 1010. Alright. Well, when you're performing the right shift, you're telling the interpreter that you want to shift your bits toward right. And how many bits you want to shift is basically 2, since you have mentioned 10 right shift 2. Alright. So 1010 shifted 2 bits to the right. 00 and remove 10 from the end. Alright. So this is how you are shifting 2 bits towards the right. So you got the result as 0010. So now if you convert this into decimal form, you'll get the output as 2. Fine. So it's like you're trying to push 2 bits from the left towards the right. Is it clear? Alright, fine. Let's move ahead. Next we have is 10 left shift 2. What is the output? It's 40. Let's see how we got that output. Again, 10 in its binary form is 1010. So when you're performing a left shift, it's like pushing the bits from right towards the left. So 10 left shift 2 is like 1010 and you are adding 2 bits in the end, since you are shifting 2 bits to the left. So you are getting 101000. So let's convert this into its decimal form. So 101000 in its decimal form is what? 40. So that is why you're getting the result as 40. So there's a shortcut trick. Well, the shortcut trick is that just add zeros equal to the number of bits that you want to shift towards the left. Alright. For example, I want to perform 10 left shift 3. So my output should be 101 000 and one more 0. Alright. Since I'm moving 3 zeros. Alright. Since I'm moving 3 zeros towards the left. So let's convert it. So it's 80. So you're getting the output as 80. Let's verify it again. Well, if you perform 10 left shift 3, you'll get the output as 80. Fine. Well, I hope the bitwise operator is clear to you guys. Well, in case you have slightest doubt, please add your doubt to the comment section below and we'll try to reply them at the earliest. For now, we can just move ahead to the identity operator.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Well, these operators are used to test if two operands shares an identity. The operators which are a part of it are is and is not. These are basically two keywords. Alright? For example, what we have up here, x equal 10, x is 10, it's true. Or x equal 10, x is not 10, it's false. Alright? It is just used to test if the operand shares an identity or not. Alright? So next and the final operator in Python is the membership operator. Well, this operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, it can be a string, or it can be a tuple. I know some of you guys might be thinking, what is this list or what is this tuple? And guys, I'd say that just be patient. I'll teach you about them in detail during this session. For now, you can just understand that this list is almost same as array, which you had already studied in C, C++ or Java. It's almost same as that. Alright? And this membership operator, it is used when you want to check if a certain element is present in a list or not. So let's see what are the operators which are a part of it. So well, we have in and not in keywords which are a part of this membership operator. Alright, let's see an example. So what's the example up here? So we have defined a list, or you can say we have defined an array, which consists of dog, cat and wolf. So we are checking for lion and pets. Since pet is the name of a list or an array, you can say. So we are searching for lion and pet. So since there is no lion in it, so the result is false. Next, what we are doing, we are seeing for wolf and pets. So yeah, wolf is present in pet. So we are getting output as true. Alright. So let's proceed and learn about function. So what are these functions? Well, a function is a block of organized reusable set of instruction that is used to perform some related action. But why do you even need a function? Well, what if you have to write a program in which you have to use same set of code again and again? For example, you wrote a code of 20 lines or 40 lines, and those 40 lines of code are coming in your main program at 10 different places. And you have to use those 40 lines of code 10 different times in the program. So I don't think that none of you would be interested in writing the same lines of code again and again. So in order to resolve this issue, they created function. So well, this function is a block where you write your code which you think you might use it again at some point of time. Therefore, it allows the reusability of the code and thus minimizes the redundancy. In Python, there are basically two types of function. The first one is the user-defined and the second is built-in function. Let's see them one by one. So what is a user-defined function? Well, any function defined by a user is a user-defined function, right? Syntax. It starts with the keyword def, after that an identifier for a function name, and then you pass the arguments into it. Alright, followed by semicolon, and after that you mention the set of statement inside it. Alright, let's see an example. For example, if you want to add two arguments, so you define a function as add, and inside add you pass two parameters as a and b. So sum equal a plus b. And return sum. That's it. So it's as simple as, let me just define a user defined function for you. It's like it starts with the keyword def. After that, I'll write a function name as add. Inside that, I'll pass two arguments, a and b. Semicolon. And this function should return me the sum of a and b. Alright? Fine. So this is my user defined function. Next is the built-in function. Now these built-in functions are a predefined set of functions in Python. We have abs function, which returns the absolute value of a number. We have all function, which returns true if all items in an iterable objects are true. We have any function, ASCII function, ben function, bool function, and many other built-in functions are available there in Python. If you want more information about it, you can just check out the Python official doc. Alright. Now that we have defined a function, now let's see how we can call a function. So calling a function, well, there are two ways of calling a function. You can either call it by passing a value or by passing a reference. Let's see them one by one. So first is pass by value. Calling a function by passing the value. For example, a equal 10. Def, that is keyword. So we are defining the function as print the value of b is b. And again inside the function we are updating the value of b to be 100 and print the new value of b is b. And then what we are doing, change it and we are passing a. Now since the value of a was 10, so this function would take the value of b as 10. So print value of b is 10 and new value of b is 100. Let me just show you in order to resolve this issue. Let's define the value as a equal 10. Define my function. Inside that I'll pass an argument as b. Print the value of b is b. You have to concat. Fine. And next we'll update the value of b to be 100 and again print the new value of b is b. Fine. So this is my function. Now what I'll do, I'll call my function by passing a value. Calling a function by passing a value to it. So I'll write my function and inside that I'll pass the value as a. Since the value of a was 10, let's see the output. See, so we got the output as the value of b is 10 and the new value of b is 100. So this was about calling a function by passing a value to it. Next we have is pass by reference. Calling a function by passing the reference. For example, so we have a list as c, 10, 20, 30. So we are defining a function as change them and we are passing an argument d to it. Inside the function we have print value of d is d. D of 0, it's a numeric constant. We are defining it as 99. D of 1 as 98. Then print the value of d is d. Then change them. Now when we are calling a function by passing the reference, so what we are doing, we are just passing the entire list to it. So what will get the output? We'll get the output as value of d is 10, 20 and 30 and the new value of d is 99, 98 and 30. Let me just show you with an example. C equal 10, 20, 30, right? Now let's define my function 2. Inside this d is what? Print the value of d is d. Alright. Next we'll define some numeric literals like d of 0 is equal to 99. D of 1 equals 98. And then print the new value of d is again d. Fine. This is my function. Now if I call my function using pass by reference, so my function 2 and I pass the value c into it. So let's see what we get the output. So we got the output as the value of D is 10, 20, 30 and the new value of D is 99, 98 and 30. Fine. Let's move ahead. Well, when a parameter is passed by reference, the caller and the callee uses the same variable for the parameter. Well, if the callee modifies the parameter variable, the effect is visible to the caller's variable. But when a parameter is passed by value, the caller and callee have two independent variables with the same value. If the callee modifies the parameter variable, the effect is not visible to the caller. Well, the things that you need to note in this definition are, well, the variable word here means the caller variable itself. That is, if I pass a local variable by reference and assign to it, it will assign the caller's variable itself. Do you know what is the meaning of reference and pass by reference? Well, it is different from the general term reference. It is that this reference is temporary and implicit. What the callee basically get is a variable that is somehow the same as the original one. Here on the screen is a very good example of pass by reference and pass by value. Alright. In pass by reference, you are filling a cup using the reference of the cup, and in pass by value, you are actually filling the cup using some values. So this was all about how you can define a function and how you can call it in Python. Let's get back to the quiz and test yourself. The following function takes two parameters and print the first one. So fill in the missing code. Fill in the missing code. What is the code? My definition function takes first name, last name, and what it should print. So post your answer in the comment section below and get it verified with us. Alright. Next question is a function which returns the x parameter plus 10. Alright. So fill in the missing code. Define my function as x and write the entire function for it. You have to write a function which return the x parameter plus 10. And again, post your answer in the comment section below and we'll let you know if it is correct or not. Similarly, we have fourth question. What is the output of fruit? We have a tuple up here as fruit equal apple, banana and cherry. If mango and fruit, then print 3 plus 4, else print 2 into 2. Again, print the output of the following code in the comment section below with the question number. Alright? Fine. Now let's discuss about the Lambda function in Python. So what is this Lambda function? Well, a Lambda function is a small anonymous function. Lambda function can take any number of arguments but can only have one expression. Note the fact that Lambda function cannot have more than one expression. So here's the syntax. Lambda argument colon expression. For example, we have x equal lambda a colon a plus 10 and print x of 5. So what it is basically doing, it's defining a lambda function that adds 10 to the number passed in as an argument and then print the result. Let me just show you in our Jupyter notebook. Let's define a lambda function as x equal lambda of a such that a plus 10 and then print x inside that will pass the value of 5. So what do you think the output should be? 5 plus 10, it would be 15. Alright. If you change 5 to 10, the output would be 20. Alright. Let's move ahead. So next is function versus lambda function. So what we are doing up here, we are comparing function with a lambda function. So here's a normal function which takes two arguments and return the multiplication result of both of them. And here is a lambda function for the same. It's like r equal lambda x comma y such that x multiplied by y, and if you call r 12 comma 3, what it will do, it will return the result of 12 multiplied by 3, that is 36. I'll just show you this in our Jupyter notebook. For example, I'm defining a function as def. Let's name my function as multi. I'll pass two arguments up here, x and y. colon. Now return me the product of x and y. That's it. It's done, right? Now, what if I have to define a lambda function for this? So I'll write like z equal lambda of x comma y such that it equals to x multiplied by y. Fine. Now if I want to test this, I'll write print z of, I'll pass two values in it, 12 comma 3. So it should return me as 36, right? So yeah, I got the output as 36. Fine. Let's move ahead. Next is the power of lambda function. Well, the power of lambda function is better shown when you use them as an anonymous function inside another function. For example, let's say you have a function definition that takes one argument and that argument will be multiplied with an unknown number, right? For example, you have my function as n returns lambda a such that a plus n.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you're defining a variable my sum equal my function of 3. For example, let's see in our Jupyter notebook. Define my function and we'll pass an argument as n such that it should return lambda of a such that a multiplied by n. Alright. Now you can use this function definition to make another function that always doubles the number you send in. For example, I can write double me equal my function. I want to double it, so my function of 2. I need to multiply it with 2. Now print what number do I need to multiply? So double me for, I want the double of 12. So double me 12, the output would be 24. So if you want to triple it, just change it to 3, your output would be 36. And so on. Alright. So this was all about the lambda function. Fine. Well, in this session, we'll learn about various data types in Python. Well, Python has majorly two data types, immutable data type and mutable data type. Immutable are the one which cannot be changed or modified, and mutables are the one which can be changed. Alright? Immutable data type consists of numbers, strings, and tuples. On the other hand, mutable data type, they consist of lists, dictionaries, and sets. Alright? So let's discuss about them one by one, starting with numbers. So under the topic of numeric literal, I have already discussed that Python has 4 different types of numeric literals: integer, long integer, floating number, and complex number. Well, I have also told you that you don't need to specify the data type of a variable while you are declaring it. Remember, Python would automatically convert a number from one type to another if it needs. Fine. Don't worry if you want to explicitly convert one data type to another. You can do it using int function, long function, float function, or complex function. Alright, you have that option available with you. For now, let's just move ahead and see how we can find the data type of a variable. Let's see. Suppose I'm declaring an integer variable a equal 10. Let's define a name. As Jill. Now, what if I want to check the data type of these variables? So how can I do that? So for that, we have type function. So print the type of variable a. Alright? Or print the type of variable name, or print the type of variable salary. Fine, execute it. Sorry, there's a typo, it's type. Alright, so you can see that variable a is of type integer, variable name is of type string, and variable salary is of type float. Fine. Alright, let's get back to our tutorial. So this was about the numbers. Next is strings. Well, anything which is written under the single or double quotes is treated as a string. Alright, let's perform some operations on string and understand them in detail. Suppose I have first string as hello world, and my second string is Intellipaat. Alright, now what if I want to print first character from the string 1 and the last character from string 2? So how will I do that? Let's see. So what you can do, print str1, and I need the first character. So my first character is at index number 0. I'll just mention str1 of 0. And I want the last character from string 2, right? So print str2. So if you want the last character, just specify -1. Execute it. So you got the output as capital H and small t. Since capital H is the first character from string 1 and small t is the last character from string 2. Alright. So now what if I need to extract hello from hello world? So how will I do that? What I need to do? Extract hello from hello world. So all you need to do is print from which string? String 1. Hello starting from 0, and it should end till 0, 1, 2, 3, 4. It should end till 5. Alright. And execute it. So you'll get the output as hello. Fine. This is how you can collect the substring from a string. One thing to remember is that if you check the index number of hello, so it would end at 0, 1, 2, 3, 4, 4, right? So when you want a substring, so you have to mention it as +1. So 4 plus 1 is 5. So 0 till 5. It won't include the fifth position. Generally, if you are extracting a substring, the last number which you are including, that thing is not included. It means that everything which would be between 0 and less than 5 would come as the substring. Alright, let's perform some operations on it. So first we have is the find function. So what are these find function? Well, this find function returns the position of the string. Let's take an example. For example, I have a string as str equal attachment. And what I need to do, I want to find the position of the substring me from it. So str.find, and inside that just mention what you want to find. Like I want to find the position of me. Let's execute it. So you got the output as 6. Why? Since me starts from 6. 0, 1, 2, 3, 4, 5, and it's on 6th position. So that's why you got the position as 6. Next is replace. Well, this replace function is used to replace one character or string with other. Fine. It's like, what if I want to replace this me with m? So str.replace. What I want to replace? First mention that I want to replace me. With what I want to replace? It's m. Fine. Execute it. So you got the output as attachment. attachmnt. Fine. ME is replaced with M. One more thing that you can do up here is, let me just show you. You can convert the word attachment into attach. Let's see how. Attach dot replace. So what you need to replace from here is MENT. You don't want MENT from here. So what should you replace it with? You can replace it with space. That's it. If you execute it, you'll get the word attach. What if I don't mention the space up here? So you'll get the output as attach. Even that work. Alright? Fine. Next we have is the split function. Well, this function is used to create split on the basis of a character. For example, I have a split string which consists of word 1, comma, word 2, comma, word 3. So all these 3 different words are separated by comma. So what I want to do, I want to split the entire string on the basis of comma. So I'll write split str dot split on the basis of comma and execute it. So as you can see, I got the output as 3 different words. Word 1, word 2 and word 3. Let's move ahead. Next is the count function. Well, count function returns the count of the character in the string. For example, let's take a string as str3 equals Intellipaat. Now I want to find the count of letter I from this particular string. So str3 dot count, I'll mention I. Let's execute it. So what do you think the output should be? INTELLIPAAT. So do you think it should be 2? Well, according to me, it will be 1. I'll tell you why. See, the output is 1 because well, remember I told you Python is case sensitive. So both the uppercase and lower cases are treated differently. So if I'm searching for small I, that small I is just appearing once. So I got the count of small I as 1. Now, what if I convert this string to uppercase? Dot upper. Let's convert it to uppercase. Okay, that's it. str3 dot upper. So it gave me Intellipaat. Let's store it in some variable like str4 equal str3 dot upper. Fine. Now if you count the number of i's in str4, you'll get the output as 2. Why? Since in capital Intellipaat you have 2 i's. Alright? Fine. So we discussed about the upper, which converts the character string to the uppercase. Fine. Next is the max or min function. Well, these functions are used to return the max or min ASCII values. For example, let's take a string 5 as anything. For example, exclamation mark, @ hash, 123, capital A, small b, small a, c, capital C. Alright. So this is my string 5. Now I want to find the maximum ASCII value from it. So what I'll do, I'll just write max str5. Execute it. I must to mention this. Put it under the quotes and execute it. So the character with maximum ASCII value is small c. Alright? Or what if I want to find the minimum ASCII value from string 5? Let's check for that. So minimum ASCII value in string 5 is of exclamation mark. Fine. So let's move ahead. So well, next we have is the tuple. Tuple are a group of values within the parentheses, and since they are immutable data type, so the values within the tuples cannot be changed. For example, we have defined a tuple up here as my group equal A, B, C and D. Alright, so this is the example of a tuple. So let's move ahead and perform some operations on it to understand it in detail. Let's get back to our Jupyter notebook. Let's define a tuple as my tuple equal within the parentheses. I'll mention A, then B, then C and D. Alright, so this is my tuple. So the very first function that we are going to perform on it is concatenation. So what are these concatenation? It is used to add two strings or character. Alright. Basically, concatenation is used to add two or more tuples. Alright. For example, I'll define another tuple as my tuple 1 equal E and F. So if I need to concatenate it, I'll just write my tuple plus equal my tuple 1. And let's print it. Print my tuple. Let's see the output. You got an error as invalid syntax. What is the invalid syntax up here? Something is invalid here. Let's define it again. Okay, this semicolon is missing up here. Fine. Execute it. So yeah. So this concatenated me and gave me the result as A, B, C, D, E and F. So this is how concatenation is done in tuple. Concatenation. Next we have is the repetition. Repetition is used to duplicate the string or character for a given number of times. For example, what if I want to double the contents in my tuple? So I'll just write my tuple multiplied by 2. And again, that's it. My tuple multiplied by 2 and hit enter. So you'll get the output as double values of A, B, C, D, E and F. Fine. So this is how a repetition is done in a tuple. So let's move ahead. Next function that we need to perform is indexing. Indexing shows the index position of a character or a string within the group or within the tuple. For example, I want to find what character is present at the index number 1. So I'll just write my tuple of 1. So at first index, B is present over there. It's like A is present as 0th index, B at 1, C at 2, D at 3 and so on. Fine. So this is how indexing is done in tuple. Next is slicing. Slicing shows a specific set of index character or string. Fine. For example, I want a specific set of strings which lies between the index number 1 to 4. So my tuple I want a specific set of string which lies between 1 to 4. So this is my 0th, 1, 2, 3 and 4. Fine. So I'll get the output as B, C, D and E. Let's check it. So I got the output as B, C, D and E. Fine. Alright. So let's move ahead. So next we have is the list. List is a sequence of mutable Python data type which is defined within the square brackets. And now since they are mutable, they can be easily changed. Let's move ahead and perform some operations on it and understand it in detail. So what is an example? Okay. So we define a list as A, 10, 7.12 and data. So it is consisting of mixed data type values. It even has an integer, a float and a string. Fine. Let's get back to our notebook and define a list. So this is my list. My list equal within parentheses a string, a number, a decimal, and a string with multiple character. Fine. So this is my list. Now let's see what are the operations that we need to perform on it. First is concatenation. Well, again the concatenation is same as the one which we learned in tuple. It is used to add two or more lists together. Let's define another list as mylist2. Mylist2 consists of element as, let's take Python, or it consists of an integer. Now what if I want to concatenate my list with mylist2? So what I'll do, mylist plus equal mylist2. Let's see what is the result. Let's print the value of mylist. So you got the result as A123 3.14 John Python 20 Python 20. So you got this result 2 times because I executed it twice. It's my fault. So what you can do, you can just mylist dot remove. Hold on. I don't want to execute this entire list or statement, so I'll define it under different block. So mylist dot remove Python Okay, I have misspelled Python as okay. Remove this. Again, remove this. And remove 20 and again remove 20. If you again remove it, you'll get an error. Fine. So let's see what we have currently in my list. Let's print it. Okay. Let's get back up here and execute it just once. Okay. So as you can see, my list got updated with Python and 20. Fine. Next is repetition. Well, repetition is again same as tuple. It is used to duplicate your list with n number of times. Well, next is repetition. It is used to multiply your list by n number of times. For example, my list into 2 would duplicate your list with each element appearing twice in the list. Alright? Fine. Next is Slicing. Again, same as tuple, if you want a specific portion of a list, we can just mention the starting index number and the ending index number plus 1, and it would return us the sliced list. Alright. For example, as you can see here on the screen, we have my list, and inside that we have A1, 3.14 and Python. And we want a sublist from 1 to 4th index number, like 1, 2, 3, 0, 1, 2, 3 plus 1. 4th won't be included, so we'll get the output as 1, 3.4 and 3.14 and Python. Alright. Next is append. Well, appending is adding any value to a list. It's almost same as the function what we did up here. Right, it's like my list dot append and add any values with which you want to append. Like I want to append with 10 and print my list. That's it. So as you can see, we got 10 in the end. Fine. So moving on ahead, next we have is extend. Well, again, extend is another function which is used to concatenate two different strings. Alright. For example, I'll define my list 3 as C and D, and I want to append my list with my list 3. Let's print and see what result do we get. So as you can see up here, C and D got added with my list. Fine. Well, next is insert. Well, using the index number, you can specify any value in between the list. For example, I want to insert a number before 3.14. So I'll write my list dot insert. I'll mention the index number. My index number is 0, 1. I want it after 1. And what value I want. For example, I want to insert a 20, 30. Alright. Let's print my list and see what is the result. You cannot use a string up here. You just have to mention the number, index number. So yeah, you got my list at first position. So what if I want to insert it before 3.14? That was my target, right? Now your updated string is this 0, 1, 2, 3. So you want to insert it at third position and you want to insert 40. So at third position, that is 0, 1, 2, 3. So after 1, 2, 3, 40 would come. So after 1, 2, 3, 40 is up here. Alright. So this is how you can insert any number at a given index number. So this was all about list. I hope you understood the difference between a list and a tuple. If not, let me just summarize it again. A tuple is immutable while a list is mutable. Open and close brackets are used when you are grouping items under it. And in the case of list, square brackets are used. Fine. So this was all about the list. So let's move ahead and discuss about dictionaries. Well, these are more flexible data type in Python. And you define a group within the curly braces. Fine. While defining the elements in a dictionary, you have two elements, key and its value. Fine. Or in other words, we can say that we define an index for each element. Let's explore various operations that we can perform using dictionary. So first one is defining an empty dictionary. Don't mention anything within the curly braces. That would be an empty dictionary. Alright. Next is integer keys. That is dictionary with integer keys. For example, 1 apple, 2 ball. So the key 1 and 2 are just integer, right? So it's a dictionary with integer keys. Next is mixed keys. Dictionary with mixed keys. That is, we have key of mixed data type. For example, name is string up here, 1 is integer, right? So this is mixed key. Next we have is pairing. That is from sequence having each item as a pair. Dictionary, 1 apple, 2 ball, all are taken as a pair element. Fine.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Next is accessing dictionary. So what if I want to access a dictionary? So I can directly access using the key. Fine. For example, the word 1 is associated with key 1 and word 2 is associated with key 2. So if I want to access word 1, I can directly write my dictionary of 1 and it will give me output as word 1. Fine. Let's move ahead. Now what if I want to find the length of the dictionary? Then I can directly do it using the len function. Len of my dictionary is giving me the output as 2. Why? Since it consists of two elements, word 1 and word 2. Fine. Next is key. Now what if I want to find the key of my dictionary? So I can just use the key function. My dictionary.key. It is returning me all the keys within the dictionary. Fine. It is returning me all the key defined within the dictionary. Next is value. Well, this function is used to return all the values defined within the dictionary. For example, we have apple and ball as value within this dictionary, my dict. Alright, so that's why using value function, we got the output as apple and ball. Fine. Let's move ahead. Okay, so now that you have learned about dictionary, so let's discuss about the last data type, that is set. Sets are the unordered collection of items within the curly braces. That is, items are defined within the opening and the closing curly braces. And you don't have to define the key value in it. It is basically unordered collection of items. If you are adding elements in the set, then make sure that every element in the set is unique. For example, you can define a set as my set equal 1 to 3. Well, it's almost similar to as dictionary, right? But it does not has any key value associated to it. It's the only difference between a set and a dictionary. Alright? Let's perform some of the function using set and understand it in a better way. So the first one is creating set. You already created a set. Alright. Next is union. Well, union of two sets return the common value from both the set. For example, my set S1 equal 1, 2 and C. My set S2 consists of 1, B and C. So if I am performing a union on it, so it is returning me with 1, 2, C and B. So basically what it is doing, it is returning me the common values of both the set. Fine. Next is the intersection. Well, intersection is used to return the common result from both of them. That is AND of my set S1 and my set S2. So what are the common elements in both of them? We have 1 2C, 1BC. So we have 1 and C common in both the set. So we got the output as 1 and C. Fine. Next is the difference. Well, this difference would omit all the common value from both the set, and it will return the only value which is a unique in first set. For example, we have 1 2C in set 1 and 1BC in set 2. Next we have is Python classes and object. So what is a class and object in Python? Well, Python is an object-oriented programming language, and almost everything in Python is an object with its properties and method. And a class, it's like a blueprint for creating objects. Let's see an example of a class. We define a class as class space class name colon, and inside that you define its objects. If you want to call an object, let's see how you call it. You're defining a variable as obj1 and you are assigning all the object of my class to it. And if you want to print one of the variable of my class, so you can access it using obj1. Alright. So this was about the classes and object in Python.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Different types of flow control like if, elif, for, while, etc. that we are going to use in Python. Next is the Python flow control. Well, these flow controls are the one which control the flow of execution of your program. So we have 6 different types of flow control in Python: if else, nested if else, for, while, break, and continue. Let's discuss them one by one, starting with if else. So what is this if else? Let's see its syntax. If the condition is true, then execute statement 1, else execute statement 2. It's as simple as that. Let's see the flow of execution. You start it, you check the condition. If the condition is true, then execute block 1. If the condition is false, then go to the else part and execute block 2. Fine. Yeah, this block 1, it comes under if part. Alright. Let's move next. Let's move ahead. Next is nested if else. Let's see the syntax. If condition 1 is true, then execute statement 1. Else, if condition 2 is true, then execute statement 2. If none of them is true, then execute statement 3. Let's check the flow control of it. Start, check for condition 1. That is, if condition 1 is true. So if condition 1 is true, then the statement executed with the if block is executed. That is, execute block 1. If first condition is false, then go and check for the second condition, that is else if condition. Now if else if condition is true, then your second block would be executed. If none of them are true, this block would be executed. That is execute block 3. And yeah, remember one thing, there is no condition associated with the else block. Else block would only execute if all the above conditions are false. Fine? Alright. Next is the for. Let's see the syntax. For iterate colon execute statement. Let's check. Well, it's the example of a program. Like start, we are defining a variable as count equals 0. Then execute statement. Then increment the value of count by 1. And then check the condition if count is less than 10. Is 1 less than 10? Yeah, the condition is true. So again repeat it and again execute the statement, again increment the value of count by 1, that is count become 2, and again check if 2 is less than 3. And so on, continue this till 10 is less than 10. And when this thing arrives that 10 is less than 10, your condition becomes false and you exit the loop. So this is how a for loop works. Let's understand this in a better way with an example. So this is our code. Alright, we have defined a list fruits as apple, banana and cherry. For x in fruits, x in fruit of 0 is apple. Then print x X is what? Apple. So apple would be printed as the output. Now again, what we'll do? We'll again go back and check for X and fruits. Now X of 1 is banana. Then print X. X is what? Banana. So it would print as banana. Again, it will go back. X and fruit of 2 is what? Cherry. Print X. Cherry would be printed. Now if it goes back, there's nothing left in the fruit. So nothing would be printed. Alright. So you got the final output as apple, banana and cherry. Fine. Alright. So let's move ahead. Next is the while. The syntax for this is while condition is true, then execute set of statement under the while. Start, check for the condition. If it is true, then execute block 1 and then again repeat the loop until the condition is true. In case the condition is false, then just exit the loop. Let's understand this better with an example. This is my code. Like a equal 1. In variable part I got a equal 1. While a is less than 5. Is a equal 1 less than 5? Yeah, condition is true. Then what? Print the value of a. Alright, so we got the output as 1. After getting the output, increase the value of a by 2. So a plus equal to 2. That is 1 plus 2 equal 3. Now again go back to the loop. Check for the condition. Is 3 less than 5? Condition is true. Then again go to the print a part. What is a? 3. So print a. So you will get the output as 3. Again increment the value of a to 2. That is a equal 5. Now check the condition. Is 5 less than 5? No. I think here we got the condition as false. So we got the final output as 1 and 3. Alright. Let's move ahead. Here's another example. A equal 1. In the variable part a equal 1. Check the condition. While a is less than 3. Is 1 less than 3? Yeah, condition is true. Inside the while part, the first condition that we check, if a mod 2 equal 0. Is 1 mod 2 equal 0? No, the condition is false. So we'll jump to the else part. So we'll jump to the else part and print a is odd. Now since the value of a currently is 1, so 1 is odd. Fine. Then what we'll do, we'll increment the value of a by 1. That is 1 plus 1 equal 2. Fine. Now again we'll go back to the while part. Now we'll check if 2 is less than 3. Yeah, the condition is true. Fine. Now what we'll do, we'll jump to the if part and check if 2 mod 2 equal 0. Yeah, the condition is true. So this time we'll check if 2 mod 2 equal 0. So yeah, the condition is true. So what it will do, it will print the if part statement. That is a is even. A in this case was 2. So 2 is even. Fine. So this is our output. Next, again it will go and increment the value of a by 1. So now 2 becomes 3. Again it will go back to the while part. Is 3 less than 3? The condition is false. So your final output is 1 is odd and 2 is even. Fine. So this was about the while statement. Let's move ahead and learn about break. So this break statement, it is used to break the loop at a certain condition. Alright. Let's understand this with the help of this flowchart. Start it, check the condition. If the condition is true, then check the break condition. If the break condition is false, then only execute block 1 and repeat the loop. If the break condition comes to be true, then break the entire loop and then exit the loop. Alright. Let's check it with an example up here. For example, a equal 10. while a is greater than 0, check for if a is not equal to 5. If a is not equal to 5, then print a. Else break it. Fine, let's execute it. Sorry, just manage a minus minus. A minus equal to 1. Fine. Stop it. Let's mention it up here. So we got the output as 9, 8, 7 and 6. Fine. So the moment loop becomes 5, we got exited out of the loop. Next we have is the continue statement. Well, the continue statement won't break the loop. So it will just skip the statement in case the condition is true. Let's understand this with the help of this flowchart. So start, check for condition 1. If it is true, then check for continue condition. If it is false, then execute block and repeat. Then in case if the condition is true, then stop executing that particular block for that particular loop and cut for that particular iteration, and again go back and repeat and check the condition.
Web scraping is a term which is used to describe the use of a program or an algorithm to extract and process large amount of data from the web. Whether you are a data scientist or an engineer or anybody who wants to analyze large amount of data sets, then the ability to scrape data from the web is a useful skill that you should have. Let's say you find data from the web and there is no direct way to download it. Then web scraping using Python is a skill which you can use to extract the data into a useful form so that it can be imported for further analysis. Well, this was just a quick overview of web scraping. So before we dive deep into web scraping, let me just discuss the agenda for today's session. We'll start this session with a basic introduction to web scraping, where you will learn about what exactly is web scraping, how it differs from web crawling, and what are the various applications of web scraping. During our session, we'll also discuss about the legality of web scraping to know whether web scraping is a legal thing to do or not. Once done with this, we'll move to the demo part where I'll show you how you can scrape the data from the web using Python libraries, Request and Beautiful Soup. For this tutorial session, it would be good if you have a basic knowledge of HTML tags. If not, then don't worry. I'll discuss some of the basic HTML tags during this session. I hope the agenda. So without delaying any further, let's quickly jump into web scraping basics. So what is web scraping? Well, web scraping, also known as screen scraping, web data extraction, web harvesting, etc., is basically a technique which is used to extract large amount of data from the websites. These data are mostly unstructured in nature, and once extracted, you can transform it to a structured data and save it to a local file in your computer or to a database in a tabular or a spreadsheet format. The data displayed by most of the website can only be viewed using a web browser. And most often, they do not offer the functionality to save a copy of this data for personal use. Only option then you have is to manually copy and paste the data, which is a very tedious job and can take many hours or sometimes days to complete. Now using web scraping, you can automate this process. So instead of manually copying the data from the website, the web scraping algorithm will perform the same task within a fraction of time. So this was about what is web scraping. Let's move ahead. Now next we have, is web scraping or web crawling the same thing? Well, there is a very subtle difference between web scraping and web crawling. Moreover, web scraping and web crawling are interrelated. The words web scraping and web crawling may look similar and many people use this word very frequently, but both have lots of differences between them. In simple terms, web crawling is the process of repetitively finding and fetching hyperlinks starting from a list of starting URLs. Broadly speaking, web crawling is a process of locating information on World Wide Web, indexing all the words in a document, adding them to a database, then following all hyperlinks and indexes, and even adding that information to the database. Major search engines like Yahoo, Google, Bing, etc. all have such a program, which is also known as a web spider or a bot. But when you see, on the other hand, web scraping is a process of automatically requesting a web document and collecting information from it. Strictly speaking, to do web scraping, you have to do some degree of web crawling to move around the websites. Web crawling is generally what major search engines do for searching any kind of information. Web scraping is essentially targeted at specific websites for a specific data. For example, stock market data, business leads, or supplier product scraping, anything like that. But an important thing to know is that web scraper can do things a web crawler wouldn't do. For example, they doesn't obey the robot.txt. I'll tell you in detail what exactly it is later in this session. But now just understand that they doesn't obey robot.txt. It is a file which tells that what you can crawl and what you cannot. So web scraper does not obey that robots.txt file. Don't worry, later on we'll read about it in detail. Next is submit forms with data, or execute JavaScript, or transforming the data into required form and format, or even saving the extracted data into database. So these are the things a web scraper can do, but a web crawler cannot. I hope you guys are clear with the difference. So moving on ahead, let's learn about some of the use cases of web scraping, or under what business scenario you could use web scraping. So on number one, we have tracking competitive pricing. Well, web scraping helps in extracting products or service price of the competitors to stay ahead of the cutthroat competition. Next is sentiment analysis. Well, sentiment analysis is analyzing the reaction or response of a customer or a consumer. Using web scraping, it can be easily traced by extracting ratings, reviews, and feedbacks on forums as well as e-commerce websites. Next, we have market research. When you are planning for a product or a service launch, then you can use web scraping to study the market in advance, and it can help you out for the product campaign's launch. Next is industry scrutinization. Most of the time, you and your business would demand to know that who all are present in terms of market player. So in this case again, web scraping can surely help a big time. Next is content aggregation. Well, if you want to gather information from multiple documents or web server for further processing, then what you can do? Then you can just web scrape the data. Then you can just process the unstructured data and convert it into a organized structured data. And it can be further used as a real-time information. Next is monitoring brand value. You can make future decisions easily and very accurately by analyzing the brand value on scraped filter data related to your brand, along with some positive and negative keywords. Next we have is the lead generation. Well, you can use the scrapped data to identify who to target in a company for your outbound sale campaign. You can even use it to locate possible leads in your target market or identify right contacts within each one. Well, this was some of the business application of web scraping. Well, if you research out there, you will find out n number of other business application for web scraping. Now, since that you are fetching data from a different website. So now that you have seen various business use cases of web scraping, and you know that what you do in web scraping is you fetch the data from other websites. So a question might arise in your mind, like, is web scraping or web crawling a legal thing to do? Well, the answer is maybe. Crawling means fetching content from the web pages in an automated manner rather than to manually opening each page in your browser. The calls made by the browser agent to the target server that hosts the web page is quite similar to the way the bot hits a page to grab its content. So now the question arises, why is crawling a taboo among those who only have learned to use the term? Well, it's mostly because it's quite often used against the website policies and breaks the ground rule of crawling. So here are some thumb rules that you must follow if you want your bot to behave humanly. The first one being robots.txt. Well, be it a commercial or a non-commercial, Indian, American or any website, one of the easiest way to find out which websites allow scraping and which doesn't is simply by checking their robots.txt file. You can do it by appending /robots.txt at the end of the website URL you wish to scrape. For example, what if I want to check the robot.txt file for amazon.com? So I'll just write www.amazon.com/robots.txt. So as you can see here, it gave me a list of allowed and disallowed links which can be crawled. You can consider this as a filter consent form that you should abide by if you want to crawl that site. It tells you what URLs you can and what you cannot crawl. This is really bot specific. Even Google's bot cannot crawl a blog page unless the site is worried about the page's SEO. Next is the public content. We'll crawl only public content keeping copyright policies in mind. If you are crawling a site only to reproduce the same content on a new site of yours, then good luck with that. You can easily do that. It's a very legal thing and no one is gonna pose you or sue you for that. Next is terms of use. Check the website's terms of use and make sure all's well between them and you. You should definitely read the terms and condition of a website you want to scrape. If the data is under Creative Commons, you should definitely read the terms and condition of a website you want to scrape and check if the data is under the Creative Commons that you can use it commercially. So basically, if terms and conditions states that scraping is illegal, then you shouldn't scrape that website. Next is authentication based websites. Well, some sites need authentication before you could access their content, and mostly they would discourage crawling because they only want real human beings to get logged in. Next is crawl delay. Robots.txt also lists delay to be maintained between consecutive crawls to ensure you're not hitting their servers too hard. If you overload them with requests, chances are that your IPs will be blocked. Let me tell you about an ongoing case between LinkedIn versus HIQ. In August 2017, LinkedIn blocked HIQ from accessing its data available in public LinkedIn profiles of registered users. So what these HIQ guys were doing, they were just extracting information from LinkedIn. All the public information, all your public profiles which were being extracted by HIQ. So what LinkedIn did, it blocked the company from accessing its data. HIQ took LinkedIn to the court and the case is still ongoing. The case hinges on the question of who owns a piece of data and the circumstances under which the information can be viewed as residing in the public domain, accessed by all and sundry. The appeals court judges may rule that LinkedIn owns exclusive right to the data, which would not have been compiled without the entrepreneurial talents of the LinkedIn founders. Conversely, the judges may conclude that since LinkedIn users set their profiles to public, placing them in full view of search engine and general web surfers, they are giving companies like HIQ free rein to view and use the data as they see fit. So it's a knife-edge decision with strong arguments on both sides. Either ruling could have profound implication for how people like you and me interact with the data in your daily lives. So this was a story of how HIQ breached the policy of LinkedIn by web scraping their data. So as you know that for this tutorial, I'll be scraping using Python. So what are the basic Python libraries that I'll be using for web scraping? Well, the first one is the request, which is used for fetching URLs. It defines the functions in class to help with the basic URL actions like digestion, authentication, redirection, cookies, etc. Next is the beautiful soup. Well, it is an incredible tool for pulling out information from a web page. You can use it to extract tables, lists, paragraph, and you can also put filters to extract information from web pages. Beautiful Soup does not fetch the web page for us. That's why I'm using the combination of both request as well as the Beautiful Soup library. Python has several other options for HTML scraping in addition to Beautiful Soup like Mechanize, Scrapemark, Scrapey, etc. Don't worry, we'll discuss about them in our next tutorial. For this tutorial, we'll be just focusing on beautiful soup and requests. So let's move ahead. Well, while performing web scraping, you will have to deal with HTML tags. Thus, it's very important that you must have a good understanding of them. If you already know the basic of HTML, it's good. But for those who don't, I'll try to cover the basic for you guys in just 2 minutes. Here's a basic HTML code. The first line, !doc_type HTML. It indicates that this particular HTML file is written in HTML5. So basically all the HTML5 documents must start with it. Next is the HTML tag. All the HTML documents are contained between an opening and a closing HTML tag. Next we have is the opening body tag. Well, this is the visible part of HTML document. Like whatever you see on the web page is mentioned inside the body tag. Next is the body tag. Well, it is the visible part of HTML document. Like whatever you see on a web page is enclosed between a body tag. Next we have is the h1 tag. Well, HTML headings are defined with the h1 to h6 tag. There are 6 different types of heading which are defined as h1, h2, h3, h4, h5 and h6. For example, h1 is the main heading, then h2 is a subheading and so on. After headings comes the paragraph. For paragraph we have a p tag over here. This tag is used to define a paragraph. There's the ending body tag and the ending HTML tag. Let's move ahead. Next we have is the table tag. Don't get confused with this style thing. The main tag over here is table. The style is just one of the attribute of a table. Like it's telling that the width of the table should be 100%. We represent the row as tr tag and the rows are divided into data using the td tag. For example, I mention a name over here like James. James is a data of a row. It's a cell. Fine. We add another data to same row. James Smith. Another data to the same like 45. So first name, last name and age are being added to same row tr. Now again, what if I want to add elements to my next row? So again I'll define another row tr. Then again I'll write first name, last name and the age. And then again close the tr tag or the row tag. These are some of the basics. See what we have next.
Just a quick info, guys.
Basic HTML tags which I'll be using in this session. If you want to learn more about HTML tags in detail, you will find multiple online sources freely available for you. You can just learn about HTML in detail from those websites or content. For this session, I'm considering all of you have a brief idea about the HTML basics. Let's start scraping our website. So we'll be scraping a web page using beautiful soup. Here I'll be scraping a data from a Wikipedia page and our final goal is to extract list of country from it. Let's scrape out Wikipedia step by step. So we'll be writing our Python code on our Jupyter notebook. Well, for those of you who don't have Jupyter notebook installed in your machine, I'd suggest that you can just go over to www.anaconda.com/downloads and from there you can install the Anaconda Navigator. Anaconda Navigator already have pre-installed Jupyter notebook in it and you can just hit the launch button to start the Jupyter notebook. So this is my Anaconda Navigator. I'll hit over the launch button and my Jupyter notebook will start on my default browser. So let's start. So the very first thing that I want to do is to import the library used to query a website. For this, I'll be importing requests. Now what I want to fetch, so I need to mention a URL. So specify the URL. URL will be a Wikipedia link. So wiki_link equal. So this is the link. So there's the list of different Asian countries by area. And what I want to do, I want to extract this particular column from here. Like I want to extract country from this table, all the different countries. So let's just copy this up, paste it over here. So this is my wiki link. It's a string. I need to convert this URL as a text. So I'll just write my link equal requests dot get wiki link to text. Fine. Executed. No error. Let's move ahead. If you want to check if the links are fetched correctly or not, just write print link and hit enter. So yeah, so it's executed and I think it's working fine. So as you can see here, it fetched me all the different links from that particular web page. So my next task is to parse the data returned from the website. For that, I'll be using beautiful soup. So I'll be importing from BS4. I'll import beautiful soup. Then I'll define a variable soup equal beautiful soup. Inside that I'll pass my variable link and LXML. So what I did up here, I parsed the HTML in the link variable and stored it in beautiful soup format. So now what I'll do, I'll use the function prettify. So now if you print soup, let's see what is the output. Now even not much readable, but yeah, it passed the HTML from the link variable. So next what I'll do, let's prettify it. So using prettify function, I'll get a nested structure of HTML page. This will help me to see the structure of the HTML tags. This will also help you to know about the different available tags and how you can play with these and extract information. So for it, all you have to do is just write print soup.prettify. Fine, execute it, and it's done. So here you got a nested structure of HTML page. Cool. Fine. Next we'll work with the HTML tags. So basically the general syntax for it is soup.tag. That's it. For example, I want to fetch out the title. So I'll write soup.title. Execute it. So my title is list of Asian countries by area / Wikipedia. Now, what if I just want the string part of it? Now, what if I don't want these tags over here? I just want the string from up here. Like, I just want list of Asian countries by area - Wikipedia. So what I'll do, I'll just write over here soup.title, and from that I just need the string part. Execute it. So yeah, you got the string without the tags. Fine. Now let's move ahead and check out what are the various links in this particular web page. So for that, what I want to fetch the A tags. So soup.a. So all you can see is that we have only one output. Now to extract all the links which have A tags in it, so we'll use find_all function. Like soup.find_all. Inside that, mention A. Execute it. Alright. So it's showing me all the links including titles, links and other information. Fine. Now to show only the links, we need to iterate over each tag and then return the link using the attribute href with a get. Fine. So for that, what you'll do, let's see. For example, I just want the links. So let's define all link. So let's define a variable all link equal soup.find_all with A tag. Now for link in all_link, then print link.get href. Fine. Let's execute it. Invalid syntax. Sorry. Execute it. So yeah. So what you got up here is all the href link. Fine. Now coming to our main task. So our main task was to extract these country from this particular table. So what I want to do, I want to find the right table. So as we are seeking a table to extract information about the country, so we should identify the right table first.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So let's write the command to extract information within all the table tags. So all underscore tables equal soup dot find underscore all. Inside that, pass the table tag. Alright. So this will fetch me all the table tags. If you print it, print all underscore tables, you'll see that we have all the different table tags up here. Fine. Now we have to identify which one is the right table. So we'll use the attribute of class of table and use it to filter the right table. So how are you expecting that you are going to check this class? So if you open your Chrome, let me just open my Chrome. Open that particular website or web page, hit enter. You can just check the class name by right click on the required table of the web page and select the inspect element. For example, I need the class name of this. I'll do a right click over here, select inspect element. Okay, yeah, so this was my table class. Fine. The class is table, and what is the class name? Wiki table sortable. Fine. So I'll just copy the class name over here. So I'll define another variable as right underscore table such that soup dot find, and it consists of all the table tags. And which table in particular I want, which has class name as, what was its class name again? Wiki table sortable. Wiki table space sortable. Fine. So there's my right table from which I want to extract the information. Right underscore table. Let's check if it's correct or not. Yeah, it's the correct one. Rank, country, area, kilometer square, nodes. Rank, country, area, kilometer square, nodes. Fine. So this one is the correct table. Fine. Now as you can see here on the screen that all the country have some link in it. So what does it mean? So each of the link has some A tag in it. So I've already fetched the right table and all I want to do is get the correct A tag from it. So I'll define like table links as from right table dot find all, and what I want to find is my A tags. Execute it. Let's check table underscore links. So yeah, we have complete list of these countries over here. Fine. Next, what you can do, you can just import them to a data frame. For example, I'll define it empty list as country. Now for links in table underscore link, this was my variable, right? Table underscore links. Sorry, country dot append
link dot get, and I just want to get the title part of each links. Fine. Executed. Now print the entire list, like print country. Sorry, we got a wrong output over here. Okay, it was links, right? So executed. Okay, fine. So we got the entire list of our country over here. Fine. Now all I want to do is represent them in a data frame. Fine. Let's see. So for importing it into a data frame, what I need to do, I need to import pandas. So import pandas as PD. Next, I'll define my data frame as df equal pd dot data frame. Fine. Now I'll define a header file for it. So data frame of, like, it's a country, right? So country equal this country. Fine. That's it. And print your data frame. Execute it. So you got the final output. And this is how you scrape the data from a Wikipedia page.
Well, file handling is a very important of any web application. Well, you have 4 different features which you can perform in a file handling. You can open, read, write and delete a file using Python. Alright, let's see them one by one. The first one being open. So you can use open function to open a file, and it takes 2 parameters, the file name and the mode. Let's see the syntax. Syntax is f equal open path of the file. So you have the syntax as f equal open path of the file and its mode. Fine. Let's see what are the modes. So we have 4 different types of mode: read, append, write and create. For reading, you specify R. It's a default value and it opens the file for reading. And if the file does not exist, it would return you an error. Next is the append. And the mode is A. Alright. What it will do, it will open a file for appending. And in case if the file does not exist, it would create a new one. Next mode is W, which is write. It opens a file for writing and creates a file if it does not exist. Fine. I'll tell you about the difference of appending and writing later in this section. Alright. Next and the final one is create. That is X. It creates the specified file and it returns an error if the file with the same name exists. It creates the specified file and it returns an error if you already have a file with same name. Fine. Let me just show you. Like f equal open path of the file. I'll open it in my D drive. D slash name of the file test file dot txt and comma, what should be my mode? It is a reading mode. R. Hit enter. Okay. So as I told you earlier, it would throw you an error if the file does not exist, right? If you want to create it, you have to mention X up here. And it will create your file. Let's go to our D directory and let me just show you the file. D. So you can see the test file up here, right? So this is how you can open a file in Python. Or you can even write W up here. It won't throw you an error, since it creates a file if it does not exist, but it won't throw you an error in case the file with same name exists. Alright. Next is the read function. Well, suppose this is our file. It consists of the document hello welcome to demo file.txt. This file is for testing purpose. Good luck. Let's open our demo file. test file. Hello everyone, welcome to Intellipaat. Good luck. Let's save it. Save it as test file.1. Fine. Let's see what operation we can perform on it. Now, what if I want to read it? So how will I do? So f equal open demo file.txt comma mode r. R is what? Reading mode. And then print f.read. Fine. Let me just open that file for you. F equal open. The path of the file, it was d:/test file1.txt, and in what mode? I want to open it in read mode, and I want to print all the content which is present in that particular text file. So f.read it first and then print it. Hit enter. So these are the content of my file. Hello everyone, welcome to Intellipaat and good luck. Fine. Now what if I want to read some parts of the file? Like I want to read the first 5 characters of the file. So what will I do? Let's see. Just copy and paste it. I want to read the first 5 characters. So just mention 5 up here. What will it do? Print first 5 characters from the text file. Hit enter. So you got the output as hello 0, 1, 2, 3, 4 and 5. So these are the first 5 characters from the string. Alright. Fine. Now what if you want to read the first line? So for that you have a function as readLine. Alright. You have a function as readLine which would be used to return one line or the first line. Again copy it. Paste it up here. ReadLine. Just hit enter. Sorry, you got an error. Okay, readline. Okay, sorry, L is small. Readline. So you got the output as hello everyone. This is my first line. Next, what if I need to read first 2 lines of my document? So what will I do in that case? So in that case, what you can do, you can use readLine twice. And it will print first 2 lines of your text. Like this. Again, do it once more. f.readLine. Hit enter. Again, the same error. Okay. So what you got? So you got the first 2 lines from your text. Alright. Now looping through the file. Now what if you want to read the file line by line? So you can use a for loop in that case. So it's like for x in f such that print x. If x is 1, then print first line, x is 2, then print second line, 3, so on. Alright. So you'll be able to read the file line by line. Hello everyone, welcome to Intellipaat and good luck. Next is reading and creating. Now to write to an existing file, you must add a parameter to the open function. Like you can write a or w. A will append the file, that it will append or add something at the end of the file, and w, it will overwrite any other existing content. For example, let's copy paste it up here. Instead of r, let's mention a, it's for appending. And f.write whatever you want to write. This is the appending statement. Execute it. Fine. Now if you will check the file, just check the existing file. Open it in a readline mode. R for X and F, print X, execute it. So yeah, so as you can see, this is the appending statement got added at the end of the file. Now what if I use W instead of A? So what will it do? This will overwrite my statements. So here I can write print f dot write this will overwrite everything. Execute it. Done. Now let's check it again. What are the contents of my file? So if you check it, so only this is left. This will overwrite everything. Fine. So this was about how you can write to an existing file. Alright. Next we have is creating a new file. Well, you can create it using X, A or W. Using X creates a file and it returns an error if the file exists. Append, it creates a file if the specified file does not exist. And finally W, it creates the file if the specified file does not exist. For example, fopen myfile.txt_x, it will just create a new file. And in case you are attempting to create a file with the same name, it will throw you an error. For example, remove this. This file already exists, right? If I'm trying to create it again, it will throw me an error. Alright, as file already exists or file exists. Fine. Next and the last we have is the delete. Well, import OS module is used to delete a file. How you can delete it? Import the OS module, os.remove demofile.txt. That's it. But for that, what you have to do, you have to first close the opened file. So f.close, inside this, mention the name of the file, or the path of the file, d:/testfile1.txt. First close it. Sorry. It's like f.close. Close the file. Now, if you want to delete it, you need to import OS module to it. Import OS and os.remove inside that name of the file. What is the name of the file? Testfile1.txt. That's it. Got the error. The system cannot find the specified file. So I guess the file is it's not deleted. Okay, I haven't specified the path of the file. I just written the name of it. So I'll write d:/ and the file got deleted. So yeah, there is no test file 1. Alright, fine.
Java has been one of the most popular programming languages since 1996. As per Oracle, which now owns Java, there are around 10 million Java developers worldwide. And Java has been widely accepted as the language of choice for developing, almost any kind of application that ranges from a small web-based Java applets to large distributed enterprise applications. It's used in small embedded devices as well as, mission critical applications as well. So it's almost, it's used in almost every corner of the world today. Let us start with what is Java. So Java was developed as a high-level programming language by Sun Microsystem in 1996. The team led by James Gosling was the one behind this project, and it was known as Project Oak at that time. It borrowed a lot of features from C++ because that was one of the most predominant languages at that time. It was created on the lines of being object oriented. It also removed couple of inconsistencies and not so commonly used features in C++. So that was the main aim of creating Java. Of course, now it acts as not only a platform but also development and runtime environment for a lot of enterprise and web-based applications. Okay, so let us move towards why was Java created. So there was a need at that time for the cross-platform language for multi-device development. At the time, C++ was a predominant language, and though it was object-oriented and widely used, it was highly resource intensive. So the aim of creation of Java was write once and run anywhere. So as I said that at around 1996, C++ was dominating the market and it was widely used for creating a lot of software applications. So the primary goal for creation of Java was the need of an appropriate language for developing the embedded device applications. So C++ has always been known as a very resource hungry language. So the C++ developers were required to manage the memory themselves, and a very small program like Hello World, which was written in C++. So Microsoft Visual Studio required around several megabytes of memory for running that code. The runtime requirement for running this C++ code was very high. So there was a need at that time for creation of a language that would generate a very small code, and the runtime environment for that language should not occupy a lot of space on the target device, because as I said, the target was the embedded device applications. So that was one of the other reasons. The other thing was it also demanded portability, because these embedded devices use different varieties of CPUs and they all of them have a different architecture. So each architecture made C++ behave in a different manner in on different machines, and the code typically was required to be rewritten for different devices. So the complexity of managing multiple build environments and code base was one of the biggest challenge there. So Java was kind of an attempt to create a higher level language that resolve these issues, and that is the reason. I mean, as I said, it was developed with the aim of writing once and running anywhere. So how is that basically done? So in a traditional model like in C++ or C, what happens is a source code written in the higher language high level programming language was converted into the native code, which is basically the machine code that the CPU understands and executes, and because of that the issues happen, because the embedded device each have a different CPU and each of them have like a different architecture. Because C++ compiler was creating the native code which was common for all of these CPUs, the execution was coming out as different, and that was creating an issue. So how Sun and Java solve this issue was, what they did, they first of all compiled the source code into the byte code, and that byte code was supposed to run on a Java virtual machine. So what basically a Java virtual machine was, so each device like like a Windows or a Windows machine or a Linux machine, so there was this virtual machine that was supposed to run on each of these devices, and that kind of hides the complexity of accessing the different CPU. So it basically, the JVM acted as a virtual CPU for different applications, and that gave a common platform of execution, and this is how Java resolved this issue. So they basically converted the source code into the bytecode, and this bytecode was supposed to run on the JVM, which was, as I said, the virtual CPU for different machines. Now, what is JVM, JRE, JDK? These are the terms that we keep on hearing. So JVM, as I mentioned, that it's a virtual machine that runs on the host, and it helps in executing the Java executables, that is the class files. JRE is a Java runtime environment that provides the core libraries along with JVM for running the bytecode, and JDK is essentially a Java development kit, and that is useful for people who want to develop Java apps. It provides a JRE and a compiler. So JDK is like an envelope which is having everything inside it. Now let's come to the different features of Java. First is platform independent. So as we had discussed that the introduction of the JVM is the main thing which kind of gives this platform independence to this Java. So JVM is basically providing the runtime environment for the Java executable. So it basically acts as a software program that runs on the target environment. So as long as you have a JVM for the desired machines, the compiled Java code, that is the bytecode, will always run on that machine without requiring any change in the source code. So that makes Java a platform independent language. Second is it is compiled and interpreted. So languages like C++, Pascal and all, these languages basically compile their source program into the object code. The linker then converts the object code into an executable, and when you run that executable, the loader in the OS that loads the executable code in memory and resolves the function references, and then it eventually executes the code. But in case of Java, the compiling and running is very different from the other procedure. So Java compiler basically translates this source program into the bytecode, and as we had mentioned that this bytecode is almost like the instruction code for the virtual CPU, that is the JVM. So there is no linker process involved here. And so when we run this Java executable on the machine, the interpreter converts the bytecode instruction into the real CPU instruction. So there's a reason, Java is again compiled at the first place from the source code to the bytecode and then interpreted line by line. So it also has a just-in-time compiler that translates the bytecode into the machine language code just before the real CPU begins the program execution. So that kind of results in the faster execution. Again, it's not as optimized as the C++ compiler because it is done at the runtime. But again, with the passage of time, it has become really fast. Next, it is object-oriented. Java is object-oriented. Basically, that's object-oriented design is a technique for programming that focuses on data, that is like the data and objects and the interfaces to that object. Basically, that believes the type of design that believes in the interaction of the objects rather than actions. That is the object-oriented architecture. Java is an object-oriented language. Simple. So as compared to C++, Java was considered really simple. The syntax of Java was like a cleaned-up version of the syntax for C++. There wasn't any need for the header files, pointer arithmetics, structures, unions, operator overloading, etc. Also, being object-oriented programming language, it kind of was really simple to understand, robust and secure. Okay. So the introduction of JVM in the architecture helped the developers in creating the secure and robust Java applications. So as we had discussed earlier, the bytecode was interpreted by the JVM, and the JVM contained a bytecode verifier. So this verifier not only checked for the validity of the bytecode, it also maintained the integrity of the memory space which is used by the applications running on it. If the bytecode was invalid, JVM simply refused to run the code on the machine. So, or say for example, if the bytecode tried to access a memory location which is outside its bound, so JVM rejected that code. So that way it was JVM made sure that it resulted in a very robust application which was running on the operating system, and it was highly secure in a sense that it cannot be used to spread a virus on the target machine, because the Java code that runs on the machine it does not have a direct access to the operating system's resources. It does through via the JVM. So JVM takes care of all the necessary security for the operating system and stops all such malicious attempts. It has also omitted the pointer arithmetics which was prevalent in C++, and that way also the pointers need not access the unintentional memory spaces. That also made the applications really good, multi-threaded. So again, C++ was one of the multi-threaded programming languages where this multi-threading was enabled. But the approach that Java followed of adding the synchronized keyword and putting the block of code that was acting as like a shared resource, so that made this multi-threaded programming in Java really easy, and that was one of the key attraction at that time. Dynamic. Another important feature which was introduced in Java was its dynamic nature. So we have seen that a Java source program was it always gets compiled into the bytecode. The bytecode gets stored in a class with dot class extension. So a running Java application can load a compile time unknown class file. It understands its defined class, it instantiates it, and then it uses it for their own purpose. So that is the process which is known as introspection and reflection. So it can also create an array of objects of this unknown type at runtime. So that is the dynamic nature which is present in Java. So with that, we are done with the features of Java. Let's move towards the evolution of Java. Okay, the first version of Java JDK, it was released on January 23, 1996. So it's been almost like 20 years from now. Since then, regularly they have been releasing a lot of versions. The names have changed, like the JDK 1.1, after release of JDK 1.1, it was named as J2SE Java 2 Standard Edition 1.2. After like J2SE 5.0, it was renamed to Java SE 6, Java SE 7, and Java SE 8. So these, so the latest release, which is the Java Standard Edition 8, that got released on March 18, 2014. So as you can see, like in last 20 years, almost 8 releases have come.
First of all, we'll be setting up the environment so that you can run your Java application, and then we'll be writing your first Java program. So for setting up the environment, what you need to do is you need to download JDK from Oracle's site. So let me open that site once. Okay. So as of now, the latest version for JDK, that is the Java platform, would be 8U45. So you can download that. Once you download and click on the installation part, you'll be getting a directory JDK 1.8.0_45. Okay. So in that directory, this is your bin label, bin folder, and here your java.exe would be located. So this is once you have installed your Java. Okay. Now, after installing Java, what you need to do is we need to download one of the integrated development environments. Again, that's a free source code, so you can download NetBeans. It'll help us out in doing a lot of things in our course further. So again, NetBeans can be downloaded from the Oracle website. Once you have downloaded the NetBeans, you'll be seeing it getting installed again under program files and NetBeans. So the version that we have downloaded as of now is NetBeans 8.0.2. So once that gets installed, what you need to do is you can open it from your programs menu. So if you click on that, your NetBeans IDE would open up for you. Okay. So you have a couple of other integrated development environments also available for working with Java, like Eclipse, Sun's Java Studio, Sun's Java Studio Creator, Oracle JDeveloper. So all of these are like the free sourcewares. You can just download them and use them. You have some of the paid versions as well, like IBM's WebSphere, BA WebLogic, IntelliJ IDEA. So these are the other IDEs that you can make use of. Now let's begin by writing your first Java program. So I'll open my NetBeans IDE. So once you open that, you have an option of creating a new project. So once I do that, it gives me a couple of options. So this ID can not only be used by developing the Java applications. You have a whole lot of other applications like Node, Maven. Uh, you have Java enterprise applications as well that can be developed as well. So for our current course, I'm selecting the category as Java. I'm selecting the Java application. The Java application would be creating like one of these standard projects for me. It'll give me a main class, it'll give me the ant script for compiling my Java class, for executing that, and for the sake of debugging. So we'll come across those functions as and on we proceed with the course. So for the time you can just select Java application, click on next. Let's say I'll give my project name as my first project, and I'm giving the so here I need to specify my main class. So as you can see, this my first project is this string is coming from the project name that I have specified. This would be the package of my class. I'll be explaining you in some time what package means, but for the time being, assume that whatever information I have given here, it gets copied over as a package. Now I'll change my main class's name. I'll just say that it is my first Java program. Okay. I can also, as I mentioned that, this is like the file that would be getting created in my project. So after doing that, I'll just say finish. So once I'm done with that, you can see that a file with name first java program.java is getting created here. That gets opened in the IDE. The package which was specified just before the main class name, that comes up here. I get a class. The name of the class is same as first java program.java. So this gets its name from there. I get a public static void main function. So let me just add some code here. So what we'll do is we'll run this particular Java file first of all, and then we'll go through each of the different parts which are mentioned in this Java file. So just mention okay. So what I've done here is I have given a line saying that this is my first Java program, and this line would be getting printed. Okay, so let us now compile our project. So for doing that, we need to go to run. We need to say build my project. Okay, so that way all the files that are written inside this project, those would get compiled. Another way, if we just need to compile our file, that is the first Java program, we have an option of doing compile file. The shortcut key of that would be F9. So let's do that. So the program has been compiled. I did not see any of the errors coming here. Okay, so let me now go and run the program. So I'll just right click and say run file. You can see the shortcut key from here, it would be shift plus F6. Okay, so now you can see the output that is coming out of my program. You would see that it is my first Java program, the string that we have given here, and the option says build is successful. Okay, now let's add some string to this argument. Let us say that run the code. So as you can see, whatever string that we have given in the argument of this function, that is system.out.println, that gets printed here. Okay, now having run our first Java program, let us try and see, I mean, what all are the different parts that make up this program. Okay, so the first thing that comes in a Java program is the package. So as you can see, this package is the first line that should be coming in the Java program. For the timing, just ignore these comments here. I'll come to this section in a while. So that should be the first line of my Java file, in case it is present with a caveat. So basically what this particular thing means is that my Java file would be written under this directory. So if you open the files menu from the IDE, you would see that my first project folder is having this first Java program.java file, and after compilation a class file of every Java file gets created. That comes again under the folder my first project. So this is the specific meaning of my first project. Okay, now let us say that if I want to see how this thing works, let me just try and create another file. Okay, so this, I'll just say my file name would be say package demo. Okay, I'm creating that in the same project, but for this the package name, I'll just select another name. I'll just append demo to the package name. Okay, so as you can see, as in when I'm appending this demo string to the package, the source automatically contains another folder which is given by demo. So let me just quickly create this package demo file. So now you can see that the package name has been modified. Now it comes as my first project.demo. The class name that I gave was package demo, and this is the same name as the Java file. And here in the source you can see that under my first project another folder known as demo got created, and that is having this package demo.java file. Once we have created, you can see, I mean, even the demo, the classes folder, the class file for this package demo is getting created in demo. So this is what the significance of the package is. It helps you organize your code under different directory structures. And as we'll be coming in the due duration of our course, it plays a very important role in the access modifiers as well. So we'll come to that in the later part. So next thing is, what are the contents of the Java program is the comment. So as you can see that we have couple of grayed out lines in this file, and as you can see, I mean, these are coming between this backslash and an asterisk, and again it's closed by an asterisk and a backslash. So this is how we write multi-line comments. Now what a comment is, it's like one of the lines in a program which compiler ignores. It's for the sake of the maintenance of the program that you write these comments. it helps the people to understand whatever logic has been followed up in the program. So you need to write a single line comment. The way forward would be write 2 backslash thing and say this is a single line comment. Okay. Similarly, in case you now want to write a comment in a multiple line, you need to start with a backslash, an asterisk, close it again with an asterisk and a backslash, and then you can write. This is a multi-line comment. Again, this is a multi-line comment. So anything which is specified between these characters and basically by 2 backslash or by a backslash asterisk, this is ignored by the compiler. Whatever you want to write, you can write here for the sake of systematic maintenance. Okay, so this is as far as comment go. Now coming to the other part, which are the reserved words. So reserved words are basically, or these are also known as the keywords. These are having a specific meaning to the compiler, and they cannot be used for other purpose in the program. Like say for example, you cannot define a variable name with a reserved word. Some of the examples of the reserved words are class, public, static, package, etc. So let me just quickly show you how these things come up in the IDE. So anything that is coming up in blue here is one of the reserved word. Like a package, my first project. So my first project is the name of the directory, but package is a reserved word, and the way the IDE denotes them is by showing in a different font and color. So as of now, this is showing in a blue color, dark blue color. Okay, so let me just quickly create a variable and show you that how we cannot use this. Let me create an integer variable and let me just give the name of the variable as package, and let me assign some value 10 to it. So as you can see that I'm getting an error from the compiler. This is because I've used a keyword, as in when I replace it, like if I just replace it with some varchar, the error stops coming from here. So one should not be using, as I mentioned, keyword should not be used for any of the variables or any other purpose. A compiler treats them differently, so that we need to make sure.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
Now coming to the next part, the other parts are these statements. So what are statements? They basically represent an action or a sequence of action. Like say for example, when I'm printing in my class as system.out.println with say hello beans, this is one of the actions. So basically whatever string I give in the system.out.println function, it prints that string on the console. Okay, and these statements, they always end with a semicolon. Okay, let us take an example of what a statement is in our program. So this is the line that we have written. This is one of these statement, system.out.println, my first Java program is awesome. So this console output is an action that this function performs. Okay, so that is the reason, I mean, it's called a statement. It's followed by a semicolon. The statement could be like again, this is one of the other statement. So what it does is it declares an integer variable and it assigns a value 10 to it. So it is an assignment statement. Okay, other part of the program is a block. So basically anything which is coming under this pair of braces, this represents a block of code. So let's say for example in this public static void main function that we have written,
The system.out.println hello beans. So anything that is coming under these curly braces, this would be known as a block. So here in this piece of code, if you select the opening curly brace, the closing one would be highlighted in this ID, and anything written in between, this would be a block of code. Okay. Now I can just also write this block of code. So what I can just do here is I can say that int var2 is equals to 10 and system.out.println my first block. So again, this would be considered as a block. Now if we just run this program, so you can see in the output you get my first Java program is awesome and my first block, this gets printed. So again, anything enclosed in between these curly braces, this would be another block. Now the other thing that we see in the Java program is the class. So what is a class? Class basically represents the blueprint of all the objects. So it basically tells you that this should be the skeleton of all the objects that are getting formed. Okay, let us see what is there in the example that we have created. So the class name of this Java program is first Java program. Now whenever you write a Java program, you can have n number of classes inside your Java file, but whatever class has been declared public, that name should be matching with the .java file. So let me just take an example. Let me just say that this first Java program create another file class. So let's say that the class name is class test, another class. This is another class that I've created. So if you see, if I try to compile or run it, everything would be getting compiled properly. Okay, this test another class is also getting created. But if I try to add the public reserved keyword to it, so it'll throw me some issue saying that this class is public and it should be declared in a file named test another class.java. So that is one thing that we need to make sure that in case we are writing a Java file, we can have a number of classes, but only one of them should be declared as public, and the name of the class should be matching with the name of the file in that case. Okay. The other parts of the Java program are the methods. So methods are nothing but the function call for performing some specific operation, and they take some input and they return an output.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So in this example that we have, system.out.println is one of the methods. Okay, so here system.out.println method, it is taking my first block string as an input parameter, and the output is it prints whatever is given in the input parameter onto the console. We have a public static void main method defined. Okay, let me just remove the comments, kind of easier for us to read. Okay, so this main function, it acts as the starting point. If you can see, I mean, when we executed this piece of code, the first thing that was getting printed on the console was my first Java program is awesome. This is because it comes as a part of the main method. So the execution starts from the main method of a particular program. Okay, so let us take an example of whatever we have coded. So here public static void main function, the arguments that this function expects is a string array, and it does not return anything. This is the starting point of any Java program. Okay, so here the execution starts from reading the first line in the main function and proceeding downwards. So first of all, the line that gets executed is int var equal to 10. Then this line, the system.out.println function gets called, and it prints the my first Java program is awesome string onto the console. So here you see this out. So this is as far as the main function goes. So with this we conclude the module. So let us start with what are identifiers. So identifiers are the names that we use for giving a name to a class or a method, interface or a variable. So these are known as the identifiers. Now we have some set rules for defining the names, for creating the names. So all the identifiers must be starting with a letter or a currency character or a connecting character like an underscore. We cannot use a Java keyword as an identifier, and whatever name we give to these variables or methods or interfaces, these are case sensitive. Okay, now let us create and see what all how we can create different identifiers. Let us start with another Java application. Let us give some default name. So here you can see that Java application 6, that is the name of the package, and that is an identifier. Java application 6, that is the name of the class, again that is a class identifier. And void main, this is a method name, again this is an identifier. Now let me just try to create an integer variable. Start with var equal to 10. So as we mentioned that it can start with a connecting character. So this is a valid identifier because compiler is not throwing any issues for that. Another way of declaring would be like string variable. Now you can see that the string variable I created from normal English characters. Again, this is a valid identifier. I can also take an example of creating an identifier that starts with a $ currency sign. Again, that is considered as a valid identifier. As I mentioned that the keywords cannot be used as an identifier. So let us try to use, let us say that we're using static keyword to identify a variable, string variable. So as you can see, the compiler is giving an error here that it is because a keyword cannot be used as an identifier. Okay, so the next thing is what are variables and constants. So let us take a couple of examples. So in this particular thing we'll cover how do we declare the variables, how do we assign the values to those variables, how do we declare and initialize, and what are the constants and how do we create it. So let us go to the Java file that we created for going through these different points. So again I'll declare a variable int var. So this is the way of declaring an integer variable. We can take an example of declaring a string variable here. So this is the way you can declare integer and string variables. Now if you want to assign some values to it, so let's say the integer variable which we created assign some value 10 to it. This is how you assign it. And for the string variable that we created, we assign it with a literal say
hello assign. Okay, now this 10 and this hello assign, these are the literals that we are using here. Okay, so I'm assigning a literal value to my variable in both the cases. I can also create basically I can also declare and assign values to my variable in a single go. So an example of doing that would be, so in this particular line I've just declared and assigned a value to variable var2. Again, if we take an example of a string, after declaring we are just assigning it a value. So this is how you assign, declare and the values to variables. Okay, now coming to constants. So unlike the variables that we just saw here, constants are variables whose values cannot be changed. So say for example the var2 variable that we have declared here, after that assignment what I can do is I can assign a different value to this var2 variable, and that is perfectly feasible. But in case of constants we cannot do that. The Java constants are the variables whose values cannot be changed after being assigned once. So how do we create them? We use the keyword final. So I'll say final integer constant variable is equals to say 20. So in this way I am creating a constant, and after doing that if I try to change its value, I'll get an error saying you cannot assign a value to a final variable. So all the final variables are the constants in Java. Now let us go to the next module, which are the encoding sets. So traditionally all the computers in the English speaking languages, they use the ASCII character code. So ASCII character code stands for the American Standard Code for Information Interchange. So this basically this character set was used to represent the alphanumeric characters, and each character was represented by like 7 bits. So that covered almost like 128 characters in this character set. It was later extended to include the other 128 characters like the German characters and the British currency symbol pound. So and eventually that was extended ASCII, and each character there was represented by 8 bits. Okay, so the problem was some of the other languages like Russian, Portuguese, German and all, these weren't getting covered by the ASCII character code. So for doing that, what the International Standard Organization came up with was the ISO 88591. So this character set again was represented by 8 bits, and it covered all the other characters as well. I mean all the characters that were required for the Western languages. So basically that covered all the characters that were required by the Western languages. After that Unicode came into picture. So Unicode was a character set which was developed by the Unicode consortium, and that covered all the other languages that didn't use Latin letters like Chinese, Korean, Thai. Basically these things, these languages used different character set, and initially the Unicode character was supposed to be represented by like 16 bits, which was enough to cover like 65,000 different characters. But the problem happened was it also tried to add another 16 bits to represent each and every character on whatever different languages we have in world. But the problem there would be like whenever character encoding set would be used in Java in the web applications, transmitting of the Unicode text in that case would not be as efficient. It would be like a big problem. So just to make it more efficient, what they came up with was different encoding schemes. So here in UTF-8 every character is encoded like by 8 bits, and it's suitable for all the text which I have Latin letters. And UTF-16 was used for languages which were like so UTF-16 had commonly used characters, and these were encoded in 2 bytes. The less common characters were encoded as pair of 16-bit code units. For UTF-32, it uses 32 bits for storing a single character, and because of the huge bandwidth requirement, it's not an ideal choice for the internet applications. Okay, so separators we have. The first separator that we have is a period. This is used to refer methods and fields of an object. So let us see an example here. Let me delete these variables. Okay. So here you can see we have a dot. Now system is a class and out is one of its methods. So we are using this dot to signify the method of system class. So this is how a separator is used. Next we have a comma. Okay, so a comma is used for separating the arguments in the method signature. So let us quickly write a method. So let us give the name as void test method. It expects a string variable and an integer variable. So here you can see that we are using comma for separating the arguments in the method signature. Next we have is a semicolon. So semicolon has 2 uses. First, it's used to terminate the statements, and then it's used in the for loops. So you can see the special use of semicolon as the statement terminator. Okay, coming to the next one, we have curly braces. So for this curly braces, they are used to declare arrays and blocks of code. So here you can see these are the curly braces, and this is the block that it's covering. Next comes is parentheses. So parentheses are used to evaluate the conditions. They are used in the method signatures to contain the list of arguments, and they're used for narrowing the conversions. So let's take an example of the method signature. So this is the method signature that we are using, and as you can see in the parentheses we have the list of arguments. Next we have are the brackets. So brackets are basically used to declare the arrays and refer array values. So let's take an example of creating an array. So here I have created an array. This is where I'm using the brackets once while declaring, and this while initializing. Okay, next separator to come here is the angle brackets. These are used to pass the parameters to the parameterized type. So let's quickly take an example of how this is done. So here what I'm doing is I'm trying to create a list of string objects. So how do I specify that this list contains all these string objects? So that is the way of specifying it. And these angle brackets is something that contains the parameter of this parameterized type of list. Okay. The last one is a colon. So a colon is used in the for loops. So let's take an example of the for loop, how it is being used. Okay, let's take an example of how this the colon is used inside a for loop. So I'll say that for string str in m. So what I'm doing is I'm trying to iterate over all these strings available in the list objects, and this is the separator that tells me that I need to iterate over all these strings in M list. Okay, now having done with the separators, let's focus on what are the primitives. So primitives are basically the non-object data types which are present in Java. So let's quickly take an example of what are these. We'll start with byte. So byte, short, int, long, float, double. So all the primitives till here, these primitives are used for storing the numerical values. Character is for the character data type, and boolean again is for storing the values like true and false. So a byte is a numerical data type that is of the width 8 bits. It only stores the integers. Short is used to store all the integers that are that fall within the range of 16 bits. Integer is for all the integer values that fall in the range of 32 bits, and long stores all the big values of integers that fall in the range of 64 bits. For storing all the decimal values, we use float data type. Float uses 32 bits for storing the values, and for larger values of decimals we use double, which uses 64 bits. Okay, let us see quickly the example of the primitive data types here. Okay, so I'm already having a class primitives for the sake of this demo. What I've done is I've created a couple of variables. This byte variable which I've created, byte var, I've given a value 20 to it, and I'm trying to print it out using the system.out.println. Now if I give a value to this byte var which does not fall within 8 bits, what happens is it throws me a compiler error. So because of that, what I need to do is I need to store all the values which are falling within 8 bits, that is like -127 to 127. It stores both the negative and the positive values. Similarly, short, again I've given an example. The keyword here which we use is short. Short, again, if I try to give a value which is greater than something that it can store, again it throws us a compiler issue. So similarly, if we need to store a value like this, like 1,30,000, let us move to integer type of variables. So to create an integer variable, the keyword which we use is int, and again, if the value which falls within the integers range, if we are trying to store in that, it throws us an compilation error, as you can see from here. Long values are stored in case, we are having like, the range is like 2 raised to power minus 63 to 2 raised to power 63. So for those integer values we use long, and the keyword for such type of variables is long. Now one thing to note here is that the value that I used here, that is perfectly valid for a long value. Now if I try, and as you can see directly from here, that this literal, I have appended L to it, which denotes a long value. Now if I remove this long from the literal, what happens is it throws us an error. The reason is that all the integers by default, all the integer literals by default assume the data type to be as integer, and because this particular value falls outside the range of the integer, it throws us an error. So in case we are trying to initialize a long variable, we should always use it suffixed by L. So this particular things works fine in that case. Okay, now so these all were the examples of the integers that we had discussed. Let us take an example of the decimal values. So you can see that for storing these small decimal values, we have float variables. It uses 32 bits for storing that. And as you can see again, if I try to give something which is out of the range of float, it throws an error again. So we've seen that float is used for storing the decimal values, and the range of it uses basically 32 bits for storing the values. Double uses 64 bits. And in case we are trying to, the practice should be that all the double literals should be followed by a D, and all the float literals should follow an F. Coming to the non-numerical data types that we have, first is the Boolean. So all the true and the false values, both the true and the false values are a Boolean data type can be used for capturing these values, which you can see from here, and the keyword is Boolean. Similarly, we have character data type. So characters like A, B, C, and all the other characters like slash and or backslash or return key, and these are captured by the character data type. I can initialize a character with something like this. In single quotes, I have given a character literal here. I can also give a numerical value here, and I have typecasted that with a char, because of which what happens is whatever characters ASCII value is kind of getting matched with this integer values, it prints that. So for this 97 value, it would print as A. Now let me just run this program. Okay, so as you can see that when I used the character as 97, it gave me A because I typecasted an integer value to a character, and for C it directly prints the value C. So this is as far as the primitives go. Now let us come to the primitive conversions. So basically we have two types of conversions available to us. One are the widening conversions. So basically if you're trying to convert a variable with a smaller data type to a bigger data type, that is like a widening conversion. So say for example, if you are trying to convert a byte to a short or an int or long, or say for example I'm trying to convert an integer variable to a long or a float or a double. So these are examples of the widening conversions, because the data type that I'm trying to convert from is smaller as compared to the data type I'm trying to convert to. Similarly, so let us first of all take an example of how these widening conversions work. Okay, so what I've done here is I've taken I've created a class for the sake of this demo. First of all, I'm using this widening conversion demo method. So an example here is I have a float variable. I have given a value 123.67 F to it. I'm creating a double variable, and what I'm trying to do here is I'm trying to typecast this float variable to a double. Now let us see what happens when we try to run this program. So as you can see that initially the float variable's value was 67, and once I've typecasted that to a double variable, what happens is the value changes to 123.66999 and so on. So basically there is no loss in the data here. Let us first of all see what are the narrowing conversions. So when I'm trying to convert a short to a byte, or for that matter an integer to a short value or a byte value, so these are like the narrowing conversions, because the eventual data type that comes up is having the shorter space in memory for storing. So because of that, the data loss happens. So we'll see an example of how that happens. So in the same example, I'll comment out the demo for widening conversion, and I'll switch to the narrowing conversion demo. So what I've done here is I've taken a long variable, which is this. What I'm trying to do here now is I'm trying to typecast a long variable to an integer. So how do we typecast? We typecast in brackets. We give the data type name. So that is how the typecasting happens. So what I'm doing here is I'm trying to typecast a long variable to an integer variable. So let us see what happens when we run this program now. So initially the long variable's value was 2 into 10 raised to power say 20, and eventually after it was typecasted to an integer variable, the value is something like minus 54 crore, something like that. So we have a lot of data loss happening. So whatever we were trying to typecast to, the value has been completely lost here. So these are the examples of narrowing conversion. It could have been perfectly fine if we, let's say for example, if we have a long value, like let us take the same example. Let us use a long var just having value like 20, and let us now convert this long var to an integer. Let us now print the values and see what is happening. I'll run the program again. Now you can see there is no loss of data has happened because 20 is, integer has enough memory for storing a value like 20. So because of that, there is no loss of data. But in the value above, integer cannot hold this particular value, and it is for that reason we see other data loss happening here. So these are the things that we need to take care while doing some narrowing conversions. Okay, so after doing with the primitive conversions, let us move towards the operators. So we have different type of operators like unary operators that operate on a single operand, like increment, decrement, negation. The other operators are like arithmetic operators for doing the mathematical calculations like addition, subtraction. And then we have the relational and conditional operators, that is like comparing greater than equal to, doing the logical and logical or the ternary operator. After that we have the assignment operators, like assigning a particular value after incrementing.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored when we create a string using a new operator? A. Stack. B. String memory. C. Heap memory. D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And then we have logical and shift operators. So these are like, doing a right shift or a left shift. So let us go through an example of how these operators work. Okay. So I've created a class for the sake of doing a demo on the operators. Given the class name as operators. So the first method displays, gives a demo of the unary operators. Let me just comment the other two. Okay. Let me go through what is the method doing here. So here what I'm trying to demo is about the increment and the decrement operators. So what I've done is I've taken an integer variable a, I have assigned a value 10 to it. Okay. So in this line I print what is the current value of a. Then I increment a by doing a plus plus, and then I try to see what is the value. Now this a plus plus, what it does, it first of all returns the current value of a and then increments. So after this line, the value of A would become 11, but it would only print here as 10 because A as 10 would be returned first. So in this line, I would see the value of A coming as 11. Now, if I do a plus plus A instead of doing A plus plus, what happens is it increments the value of A and then returns. So now A, which was coming as 11, its value would be incremented to 12 and that would be returned. So in this line, we'll be getting a value 12. Again, this line would be printing the current value of A, which is 12. The decrement operator, like A minus minus again, would be giving us the value of A as 12. But after doing A minus minus, the value of A becomes 11. So this line would be giving us 11. Again, doing a minus minus A would reduce the value by 1, which would give us 10 again, and it would be returned as 10. So both these lines would be printing as 10. So let us quickly run this program and see what the increment and decrement operators, how these work. So you can see A, after doing A plus plus, it gave us 10, but the value of A was 11. Plus plus A gives us 12. A minus minus gives again 12, but the value of A becomes 11. Minus minus A gives 10, and again the current value of A remains as 10. So this is about the increment and the decrement operators. Let us go to the logical complement operator. So what this operator is basically only applicable for the Boolean values. So what I've taken an example of a Boolean variable is correct. I've assigned a value false to it, and when I try to do a complement of this by adding the exclamation before that, it would return the negated value. So in this case, it would return as true. So I've already run the program, so you can see the output of is correct's value now is true. If I just reverse the value here and run the program, so you can see the value of is correct now becomes false. So that negates this is basically the logical complement operator. Okay, now let's do a demo on the conditional operators. So before doing that, let us see what is the content of this conditional demo. So I've taken two Boolean variables, true var and false var. So whenever we have like an end of two Boolean variables, this would return true. So basically true and true would always return as true. Similarly, if we do the logical AND of two Boolean variables, so if either of them is false, I'll get a false. Next line is doing a logical OR of two true variables. This would give us true. The logical OR of true and false will again give us true. Basically, one of the value is true. The logical OR would always return as a true. In this particular case, since both the operators are false, we'll get a false. So let me just run this program. So you can see AND of true and true is true, AND of true and false is false. Logical OR of true and true is true, logical OR of true and false is true. OR of false and false comes as false. Next in line is the ternary operator. So what is the ternary operator? Ternary operator works like this. It first of all compares the value basically it's the Boolean expression. So it's something like this. Let me just. So it works something like this. The expression 1 has to be a Boolean value. It first of all checks if the expression 1 is true or false. In case expression 1 evaluates to true, it returns expression 2 as the value. In case it returns as false, it returns expression 3 as the value. So you can see that what I am doing here is I have initialized an integer variable I with the value 10. So here I am comparing the value of I with 10. Since this is equal to true, I'm returning I. So this line would give me 10 because the value of I is 10. In the next line, what I'm trying to do is I'm trying to see if I is less than 10. Now this is a false condition, because of which I'm trying to return the expression 3, that is 0 here. So in this line I'll be getting a 0. So let me just run this program. So you can see in the ternary demo 1 I'm seeing the output as 10, and in the ternary demo line number 2 I'm getting the output as 0. So this is as far as the conditional demo goes. Let me just quickly do a demo on the shift operators. So what all are the shift operators? So what I'm doing now is I'm taking an integer I is equals to 31. The data type is byte. So I'm doing a left shift of I by 2 values. So this is the syntax of doing a left shift. So I have a number and I shift it by like s digits. So in this case, what I'm trying to do is I'm trying to shift the bits of I, that is 31, in the left direction by 2 positions. So here what essentially that means is I'm trying to multiply the value by 2 raised to power s. It is like that. So in this particular case 31 is the value I. We are trying to do a left shift on that by 2 characters, by 2 digits. So the output that we should be expecting is 31 into 2 raised to power 2, I think, which is 124. Similarly, we have a right shift operation. So doing a right shift is basically shifting all the bits of my number towards right side. This is the position that is given. This is the position of the bits that need to be shifted. So this essentially means that we are dividing a number. That means is, okay, let me just write it down. So this means doing a left shift means multiplying by 2 raised to power s, and doing a right shift, that means we are dividing by 2 raised to power s. So let me just run this program. So you can see that what this particular thing is done is it is divided, it is multiplied I, that is 31, by 2 raised to power 2, that is 4. So I'm getting 124, and this has divided 31 by 4. So I'm getting the integer output as 7. So this is as far as the demo for operators go. Now, if statement, the syntax of the statement is either of these two. You basically check a Boolean expression followed by the if, and then you have some statements written there. And the other example is that you check for a Boolean expression and then you write a sequence of statements. Everything is then followed by else and these statements, and these are included in the braces. So let's take an example of how do we write the if statement. So I've taken a demo class here. So I'm writing a main method here.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
Alright, so let us take an integer and let's give it a name I. We'll assign some value 10 to it. So one of the ways of writing a if loop is we'll check if I is greater than 5, we'll print a line,
inside if. Okay, so this is a program that we have written, and we are just writing as of now an if loop. We are checking if the value of I is greater than 5. If it is greater than 5, then it'll go inside the loop and it'll print this statement. So let's run this program. So as you can see, the output of the program is commas inside if. Now the other thing is, say for example, if the condition here is not getting satisfied, and we would want to write a default block that handles the other condition. The option of doing that is else statement. So let's take an example of this I variable only. Let's say that if I is supposed to be checked as less than 5, so the control won't go into this block. Now because of writing this if, the control will go into this block. So here is an example. Now the control will go inside else block. Now let's run this program. So you can see the output of the program is inside else. So this is one of the other examples. Now the case could be that I can have an option of testing if the value of I is less than 5. I just want to check that if it is say less than 7. I have a use case of verifying that as well. So let me just say, in that case the option would be I can write another if block which is followed by else, so it becomes an else if, and I can check my condition here, and then everything else could be followed by else block. I can write as many number of else if blocks as possible. So I'm just writing for the sake of demo here. And I'll follow everything with an else block. So I'll just give a value here inside if else. I'll say 1, inside if else 2, and inside else block. Now depending upon the values of I, the control would be going in either of the blocks. We'll start with the case of I is equals to 10. I'll run the program. So you can see the output has gone, the control has gone to the else block. So that is the reason the output is coming as inside else. Now if the value of I is given as let's say 6, so in that case it is greater than 5, it won't go in this block. It is less than 7, so it will go in this block. You can also note that it is also less than 8, but the thing is that I have put this condition after the else block. So if this is not getting executed successfully, only in that case this would be evaluated. So the control would go now inside if else 1 block. So let's run now. So you can see the output is inside if else 1. That is what we were expecting. Now if the value which we said is now, let's say 7, now else if evaluation would be failing and the control would be going here. Because 7 is less than 8, the control would go here. Let's run this program, and the output expected here is inside if else 2. So you can see that is the output that we are getting here. And as we had kept previously, if I is kept as 10, the control would go inside the else block. So let's run that as well. So you can see the inside else is getting printed here. So this is all about writing and implementing the if else if conditions. Okay, now we are done with the if loop. Let's go and discuss what is the other thing, which is the while statement. So the syntax of the while statement is while you check a boolean expression, and this is followed by curly braces, and which has all the statements in it. Now why do we need for a while loop? So we have a couple of use cases, like say for example you have stock taking application, and it basically needs to poll the server every 3 seconds to get the latest updates on the stock. So what you can do is you can just put up a while loop here. You can put the boolean expression as true, and in the statement you can just poll the server and then sleep for like 3 or 4 seconds. So that would what it'll do is it'll kind of always run. It'll poll the server in every 3 seconds. It'll sleep for that time. So that way you don't have to worry about writing that statement again and again. So this is like the usefulness of the while statement. Now let's quickly have a look at how do we write such statements in Java. So let me just clear this. Okay, so now what I've done is I've taken a variable, again integer I. I'm checking a condition here that while I is less than say 15, I would want to say print a statement. Just saying that I'm inside the while loop, and I'll just keep incrementing the value of I by 1. So I'm expecting that this would print the value of inside while 5 times. So as you can see here, that every time it goes inside the loop, it checks the value. So we'll start with I equal to 10. It goes inside the loop, it prints this inside while. It increments the value of I with 1. So now I becomes 11. It again checks, it is less than 15. Yes, it prints again, increments again, it becomes 12, checks again. So in this way it goes on, and till I equal to 15 it goes. Then after incrementing at I equal to 15, the value becomes 16, and that's when the execution of this while loop stops. So this is one of the ways of implementing a while loop. The second way could be that, as I mentioned, that assume that you have a stock taking application, right? So I would want that while loop to be running again and again and again. I mean, without checking for some condition. So for that, what I can do is I can just say that while true. So that becomes this while loop would be executed always. I can just instead of saying get the information from the server, for that I'm just writing that system.out.println inside while, and because it's like a demo here, and for the sake of demo I just want to get out of this loop. So I'll just say break. I'll check if say I becomes say 20. Just break out of this loop. I'll come to the explanation on break in a while, but for the time being assume that as soon as I value of I becomes 20, it will get out of this while loop. So for that reason I'm writing this condition, and I'll increment I by 1 every time. So again, as we had seen earlier, inside while should be printed now 10 times. So let me run the program. So you can see inside while is now coming 10 times. So this is the other way of writing the while loop. Okay, now let's move to the next statement. The next statement after while is the do while statement. So the only difference between a do while statement is that while executing a while statement, what happens is before entering into the loop, we check the boolean expression. Now unlike that, in do while what happens is the execution goes inside the loop at least once. So I'll go inside the loop and then I'll check the condition, the boolean expression inside the while. So that is the only difference between a while and a do while thing. Let us see how do we write that in a program. So I'll do one thing. I'll just make use of this example what I demoed for in the while loop. So I'll just tweak that a little bit. So initially what I had done was I was checking if the value of I was greater than 15, less than 15. It was going inside the loop. I was incrementing it, and that is how it was behaving. Now assume that in a scenario, if I want this condition
to be negated. Okay, and so whenever the while loop would be getting executed, the control will not go inside this while. So let me just show what I'm trying to explain here. So you can see that the control didn't go inside this. The reason was I is equal to 10 and it's not greater than 15. Now assume that I would have a scenario in which this I would desperately want this control to be going inside the loop. So the way to implement that would be implement a do while. So I'll write here do while. So what would happen is the control would now go inside this do while loop once, and then it would fail. After incrementing the value of I'll check, and then it would fail. So let me run that now. So you can see now the statement is giving the values inside do while. So that is the only difference between a while and a do while loop. Alright, so let us go to the next statement now. So the next statement that we have is a for statement. So for is again used for iteration, and the syntax of a for statement is it first of all initializes a condition, then it checks for a particular boolean expression, and then it updates the initializer. This is followed by the block of statements. So let's see how it is written in Java. Okay. As I mentioned that, I'll be initializing something inside a for loop. I'll delete this variable as well. Now I'll say that for integer I is equals to say 0. I'll check that I should be less than say 5. I would want to increment my variable. The condition that I'll write is I'll write inside for loop, and I'll add the value of I, so that we get to know how many times this is the statement is getting executed. So let us run this program. Now you can see what happens is for the first iteration the value of I is equal to 0. It checks if it is less than 5. This becomes true. It then goes inside the loop. It says that inside for loop, and the value is getting printed as 0. It then updates the value of I. Then it again checks if the value of I is less than 5. Now in this iteration the value of I is equal to 1, which is again less than 5. So it again goes inside the loop. It goes on till the value of I becomes 4. It again goes inside the for loop. Then it increments the value of I, which then becomes 5. Now the check I less than 5 fails in this iteration, and because of that it is now not printing that value, and the program gets completed. So that is one of the ways of writing a for loop. Now in this for loop we have these expressions that we have written. As I mentioned that this is the initialization, this is the boolean expression, and this is in the update condition. So each of this is optional here. So by that what I mean is I can declare my variable here. Okay, now it'll just check for the value of I. If it is less than 5, it'll increment the value of I and it'll print the loop. So the output would be same here. For the sake of showing a difference here, let me just put the value as 2 and this value as 4. Let us run this program. So you can see for I equal to 2, it goes inside the loop and prints the value as 2. In the next iteration the value of I becomes 3, which is again less than 4, and it prints inside for loop with the value 3. In the next iteration the value of I becomes 4, which is not less than 4, and hence the program is not printing this statement. So this is, as I mentioned, that this is one of the optional step. Again, I less than 4, the boolean expression check is optional inside this for loop. I can remove this condition here, and what I can do is I can put this condition here and add a break statement. It takes you out of the loop iterations. So in this case, what would happen is I'm checking if the value of I is, let me just say, greater than 4. If value of I becomes greater than 4, the execution of this would stop. Again, for sake of changing this, I'm modifying the value of I here. So let us run the program. So you can see for the first iteration, the control goes inside the for loop. The value is getting printed as 1. In the next iteration, what would happen is the value of I is equals to 2 gets printed here. Similarly, everything goes till iteration 5. Now, for iteration number 5, basically what is happening here is that after printing the value inside for loop and 5, it checks if the value of I is greater than 4. Now, since 5 is greater than 4, the control comes out of this for loop, and hence we are not getting any value which is greater than 5 here. Right? So this is how the removal of the initialization and the boolean condition works. Even the increment condition, the update condition here, that is optional. I can just move everything inside this for loop, and that is exactly the same thing. So now even if I run the program, I'll get the output as a little bit different output is there, because initially what was happening was after the completion of the for loop, the update statement was happening. Now even in this particular case, what happens is this condition, the check for this condition, before that the increment is being done. So when I equal to 4 is proceeding in this loop, the value of I now becomes 5, which is greater than 4, and hence this breaks out of the loop. So that is the difference here between these two programs. But as you can see, all the conditions, every condition is optional here. So that is another way of writing a for loop. So after the loop statements that we have seen, next comes is the break statement. So what is a break statement? It's used for breaking from an enclosing for, while, do and a switch statement. So that is the importance of the break statement. Assume that you're writing a loop. So we just saw some conditions here that there was this condition that we added a true condition inside a while loop that was going on and on forever, and then we just checked if the value of I was greater than 4, and we just wrote a statement like break. So the statement of execution was stopped there, and it comes out of the loop from there. So that is the syntax of writing break. Let us take some other examples of break as well.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Okay, so as you can see that the last example of for loop that we saw here, in which we had not even initialized or incremented or evaluated, we used break to come out of this condition of this for loop. So what we are checking here is that if the value of I becomes 4, if the value of I becomes 4, come out of this for loop. That is what is happening here. That is what the importance of break is. One thing that we need to keep in our mind is that whenever we use a break, it just stops the execution of the loop of the enclosing for loop. There can be a scenario where I can have multiple for loops. So let's say that I'm having a for loop like for int I is equals to say 0, I is less than
phi I plus plus, and having another while loop, for loop inside that, like say for int j say is equals to 0, j is again less than phi, incrementing the value of j plus plus. So before using this break statement, let me show you what is the value of I and j that you'll be getting for loop. Okay, so let's run this program once. For the sake of simplicity, let's put some small values here. All right, so as expected, the output is we're getting like 9 rows out of it. The reason that is that, like, for each iteration of the outer for loop, the inner for loop is getting executed 3 times. That's the reason we are seeing this output. Now if I would want to get out of this this inner for loop, I can write a condition like that, if the value of j is, say, it becomes equal to 1, break out of this loop. Let's see what happens to the output now. Okay, I was supposed to check the condition here. So let's see the output now. So as you can see, what happens is, as soon as the value of j becomes 1, it breaks out of this inner for loop. Okay, this for loop gets broken. Because of that, the value of j equal to 2 is not getting printed here. All right, now as I mentioned that this break would get you out of the iterations from the enclosing for loop. So it is just getting out of this for loop, this one. It's not getting out of this thing. So that's the reason we are seeing, like, for the value of I as 0, 1 and 2. So it's not stopping here. Now what if we want to stop this particular execution? So for doing that, there is an option of providing labels. So label is like providing an alternative for any statement. It's basically used for marking that statement and sending the program control back to that particular line of code. So I can just say that this is like my test line. Okay, so this is how I am kind of labeling my outer for loop. Now I can just say that break test. So let's see what happens now. So now as you can see that in the first iteration of the outer loop, the inner loop is getting executed 2 times. So as soon as the value of the variable j becomes 1, I come out of this for loop. Okay, I'm breaking out of this for loop, which is kind of marked by this label. So that is how we work with the break statement and labels. So this logic can be implemented if we have, like, another for loop outside the outer one. So we can again provide that a label, and the execution of the iterations would stop there. All right. So this is as far as the break statement goes. Now let's continue to the next one. So the next statement is the continue statement. Now it is almost like the break statement, but what happens inside break is the execution of the iterations inside the loop that stops and the control goes out. But in case of continue, what happens is whatever is followed by continue, that doesn't get executed and the next iteration starts. Okay, so this is one of the examples of having a continue. So here what it is checking is that if inside this is the initialization of the for loop, here it checks if the value of I becomes 6, I need to continue, and this system.out.println won't be printed. Let's take this example itself. Alright, let's use a similar example. Now what we saw there. Let me indent it a bit. So this is what is happening. We are running a for loop here. The control is supposed to be running here for like 10 times, and it would print the value of I. Now assume that I'm not having this block of code of continue here, and for the sake of simplicity, again I'll just print it 5 times. So the value of I would be printed from 0 to 4. That is 5 executions are getting printed here. Now if I want one of the numbers not to get printed here, so what I can do is I can say that, say if I is equals to 2, continue. So as soon as I say continue, what would happen is the control would go to this for loop. It would not execute this statement, that is system.out.println. So now if we try to execute the same scenario, we won't be getting the value of I is equals to 2. So as you can see in the output now, the value 2 is missing. So that is the beauty of using a continue statement. Alright, so as I had mentioned that in case of break, there was an option of using label. So the option of label was used to break the execution and break the execution of a particular while or for loop, which is not the exact enclosing one, which is like the parent of the for loop or the while loop, which is having the break statement. So for that reason we used a label. So similar logic is kind of getting applied here as well in case of continue. So here what we do is here again we'll provide a label. So let's kind of extend this example. We'll take a similar example of whatever we had done earlier for the break statement. Okay, let's say that now we are having two for loops. Okay, again we'll just use the value line for int j is equals to 0, j is less than 5, increment j. Okay, so we'll say that if j is equal to 2, continue, and print the value. We'll print the value of I, which is the outer variable here, and we'll print the value of j, that is the inner variable. So we'll say that is the j, and the same statement we'll add here is the value of I. So let's kind of remove this thing first of all. Okay, and instead of putting 5 here, let's put 3. Okay. So let's run this program. Now the expected outcome is we'll be seeing the value of j getting printed 9 times and I getting printed 3 times. So let's run that program. Okay, so you can see the value of j is getting printed 3 times, then the value of I is getting printed, then the value of j is getting printed again 3 times, and similarly like that. So now let's say that if we are putting this continue statement here, so we are checking if the value of j is getting equal to 2, we want to continue, so that this statement which is inside the inner for loop, that will not be getting executed. So let's run this program now. So now as we had guessed, as soon as the value of j becomes equal to 2, the SOP is not getting printed, this statement is not getting printed here, and we are directly seeing the value of I.
the statement which is printing the value of j has kind of reduced by 1. That means the use of continue has taken the iteration here and has skipped this instruction. Okay, now what if we want to get out of this particular loop and we just want the execution to start continuing from the outer one? For that, we'll create a label and we'll just say that the value of j becomes equals to 2, continue to test. Now as soon as we say continue to test, what would happen is even this value will not be getting printed, okay, along with this. So let's execute this. Okay, so as you can see here that because every time inside this for loop that I'm going, every time the value once will be becoming equal to true for every value of I. So as soon as that becomes equal to true, I say continue test. So I never get out of this for loop completely, and hence this statement is not getting printed. So that is the power of using the label even with continue. Okay, so this is as far as the continue statement goes. Right. So next in line is the switch statement. So switch statement is say for example is something like that I can have n number of values which are coming out of my expression. So that expression could the rule is that expression should always be returning an integer or a string. Only in that case I would be able to use that inside a switch statement. So say that I'm expecting some 4 to 5 values out of my variable, okay, and in that case I would want some specific block of code to be getting executed. So for doing that I use a switch statement. So the syntax, as you can see from here, is that in the switch we write a block, and before that block we check for the value of an expression, for the value of the expression. So in case the value comes as say value underscore 1, we execute a piece of code and then we break. So break is mandatory here. In case value comes out as value underscore 2, we execute another set of statement and then break. And after doing these end statements, what I'll check is I'll put up a default value and I'll put my statements for executing those default things. So let us again take an example of the switch statement. Let's say that I have an integer I again into the picture. I'm assigning the value I say is equals to 10. So this is just for the sake of assumption, assume that it is some value which we are getting out of a function, okay, and depending upon the value of I would like my my program to write some number of functions. So I'll do one thing, I'll put that value of I inside a switch block, okay. I'll say that when case the value of I is say 2, okay, say that print system.out.println the value is 2, okay, and after doing that I'll break, okay. Now I can just use this case condition again and again in my logic. So I can just say that, you know, when case the value of I comes as 3, print the value is 3. You can say that if it comes as 5, print as 5. And in the last I'll just say that, you know, if none of the cases are matching, this is what the default condition should be printing. The default should say that, you know, I'm printing a default value. None of the above mentioned. And this is how the execution of switch would be done. So as you've kept the value of I equal to 10, none of the cases here would be followed and the default should be getting printed here. So let's run the program once. So as you can see, the value is the SOP is saying the value is none of the above mentioned. Assume that if the value of I is kept as 2, the output would be the value is 2. So this statement is getting executed. If I'll keep it as 3, the output would be the value is 3, which is corresponding to this case, and none of the other things are getting executed. So if I remove this break statement from here, let's see what would happen if I just remove the break statement, which I mentioned was required. So you can see, because break statement was not there, it goes inside the case 5 as well, which is followed by a break statement, and then it comes out of this loop. So it is very essential to put up a break statement for all the cases except default, because default is mentioned at the last, so it won't print the values after that. Okay, so this is it from the switch statement, and for this, after doing this, we are done with the statements module. So we'll start with what is a Java object. So Java, unlike the procedural programming languages like C, is object oriented. So when I say that it is object oriented, the thing in the procedural languages is that whenever we want to start writing a program, first we think about the logic to achieve some particular goal, and then we come up with the data structures that help us in reaching that goal. So that is how the procedural programming works. But in case of object oriented programming, before starting to write the program, we try to figure out different objects that would be getting involved, and then we think of the logic in which these objects would be interacting with each other. The best part about the object oriented programming is that these objects, they don't overwrite each other's attributes. They just call the methods, each other's methods, and the logic of the program flows accordingly. So this is how we achieve like security in object oriented programming. So these are the objects. So let's take an example of a banking application. Okay, so if you want to start writing a program for that, in Java what we'll do is we will think about different objects that are involved. So we'll say that there should be a customer, there should be like an account object, there should be some employee of the bank, there should be bank itself. So these are the different objects that we can think of before writing the program. Then we'll try to see that how these objects would interact. Like say for example, how would a customer interact with the bank? He would be having some attributes like he'll be having some address, he'll be having a name, he'll be having like a number of accounts that he has already opened in the bank. Similarly, account would be having some account type. It would have the account number, it'll have how much amount it is having. So these are like different attributes that an account object would be having. So the interaction of these two objects would be like a customer goes to a bank and withdraws some amount from the account. So this is how he'll be kind of calling an account's method of withdrawing an amount, and some party, some interface in between would be handling over this amount. So we'll be designing the architecture of the program in this manner. We'll be thinking of different objects involved here, and the flow would then continue. Next thing that comes is then what is a class? So let's take it by an example of the customer. So I can have a number of customers in the bank. Okay, now all the customers would be having some common attributes, like they'll be having a name, they'll be having an address, they'll be having that which account they correspond to, and how much amount is there in the account. So a couple of attributes would be kind of common across different customers. Okay, so the thing is that how do we create those objects that have similar attributes? A class provides us a way of doing that. It acts as a blueprint using which all the objects would be kind of getting created. It's like all the objects would be first of all taken as like a carbon copy of what a class is, and then some values would be fed to them. like name, address, the account and all. So a class basically acts as a blueprint for all the objects. It would define what all attributes those objects should be having. It should define that what should be the behavior of those objects. So the attributes that a class defines, those are known as fields, and the behavior, so those are exposed as methods of the objects. So that is how the concept of class is used for putting all the common attributes across similar objects. Now let's see quickly that how do we create an object. Okay, let's start with NetBean IDE. Let's create a Java class, that is, let's give the name as my first Java class. Okay, let's say finish. Right, so this is how I created a new Java class. Okay, now okay, let's define a couple of fields of this class. Let's say that it is having a string variable name. Okay, let us define a method, some random method that that returns as a string that says get name. It'll just return me the name of this particular class's object, so it just returns me this name. Let me write the main method for starting this program. Let me now, how do we create? So this is how we have defined our class. It'll be having a name attribute and it'll have a method that is get name. Now how do we create an object out of this particular class? So the way forward is that we'll use the class name as the identifier of the variable. So we'll say that it's the first Java class variable. We'll name as some test object. Okay, and we'll create it by using the keyword new. So this is how a new object of first Java class would be created. Now what would happen is whenever the compiler and the JVM they kind of encounter this keyword new, what they do is they instantiate an object. They try to see what is the definition of the first Java class. So they'll allocate that much memory and they'll be storing that. They'll be initializing with some logic, and this is how the object would be getting created. So let us see that if we try and see what is the value of this name method here. We do it by calling test object.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
Dot get name. Okay, so this is how we have created our first object, and this is how we are trying to call one of its method. So let us run this program. The thing to note here is that we haven't initialized the name attribute of first Java class, so we won't be getting any value out of it. We'll just see null coming out of get name method because it has not been initialized by us and we haven't assigned anything as well. So when we run this program, we'll see we are getting null in this particular sysout statement. We can create n number of Java objects using this line. So what we can do is, if in case we want to create another variable, let's say test object 2, that also we can create using new. So n number of objects could be created using the new keyword. Okay, so just now we saw how did we how do we create new objects using the new keyword. Let us take a relevant example which we just discussed some while back. So let's say that you're writing an application, software application for a bank. So the object that we had discussed some time back was an account object. So let us see that if we are trying to create an object out of account, how would it be, and what should be the different fields of that object, what behavior it should exhibit. So let's quickly see that. Okay, so let me just create a Java class for that. Let's say the file name is account. Okay, and let's say finish. Okay, so let's say that what all attributes we can think of the account. We can just say that it would be having some account number. Okay, let's say that it's a string variable. Now it could be the other field could be like the account type. Then we can say that how much amount stored in that account. Okay, so these three attributes would be acting as the kind of identifier for different objects. So I can have a number of accounts, a number of customers can have like a number of accounts for them. So each account would be each account object would be kind of differing from the other using these attributes. The behavior that is exhibited by this account object is, say that whenever someone is trying to withdraw the money from an account. So let's say that there is a method that is withdraw amount. So let's say that it would it would just return me some boolean variable saying that the operation is turned successful or not. So let's write that method withdraw amount. Okay, I'll pass some amount variable into that which I expect to withdraw. Okay, now let's write a basic logic here. So let's write a very basic logic here. So if someone is trying to withdraw some amount from the account, ideally what it should do is it should first of all check if the amount which the account has, the withdrawal amount should not be greater than that. So we'll just quickly check that if the amount is greater than the withdrawal amount is basically greater than the amount that I'm already having in my account, then just return false. It's not possible, sort of thing. Okay, and else what one needs to do is else the amount should now become as amount minus the withdrawal amount, and I should just return true here, saying that the operation is successful. The other method that I can write here is like someone is trying to deposit an amount into the account. So I'll just say that, and again let's see that it's like a boolean variable saying deposit amount. Okay, let's say again if someone is trying to deposit some deposit amount into my account. So again let's add some very basic validation that if someone is passing me say a negative amount, okay, in that case I'll return false. I'll just check that if amount that someone has passed me is a 0, return false. Else what one needs to do is else my amount should become equal to whatever value I was having initially plus the deposit amount, and I'll just return true after that. So that is like a very basic structure that the account class should be having. It should have like 3 attributes here: account number, account type, and amount. It should have like 2 very basic methods: withdraw amount, deposit amount. Now how do we run that program? So let's write the main method here.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator. A. Stack. B. String memory. C. Heap memory. D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's first of all create an account object. Let's say it's test object. Okay, and let me just create it using the new keyword. Okay, now an account object has been created. Let me assign some values to the attributes of this object. Let's say that the account number is SB_101. Okay, it's a savings bank account. I'll say the account type, so I'll use account type. I'll just use a string variable SB that denotes savings bank account. Say the amount in this object initially is, say I'm giving some 100 rupees into that while initializing, say it's some bank offer. Now after doing that, let's see what is the the state of the object. Let's print what all variables are getting into. So I'm using this system sysout method here. Let's say my test objects initial values. Okay, and I'll just print these three things. I'll print the account number. I'll print its account type. I'll print what is the amount it's having. So this is how I've created an object and I've assigned some values to it. Now let's see that what would happen if I write those methods. Let's say that if I'm saying deposit some amount in my test object. Now deposit amount method, let's say that I'm trying to deposit 100 rupees into that. Okay, now let's see what happens to my object state. So it would be my object state after depositing. Okay, so this would tell us what is the state of my object after I make a deposit. Now let's say that if I'm trying to withdraw some amount. So now the method here would be withdraw amount. Okay, and let's say that I'm trying to withdraw 50 rupees out of it. Okay, let's see what happens to the state of the object after I make the withdrawal of 50 rupees. Say first withdrawal. Okay, now let's say that I'm trying now to withdraw say 1000 rupees from my account. I know that the account is not having that much amount. So let's say if I'm trying to withdraw 1000 rupees. Now let's see what happens after the second withdrawal to the state of the object. Okay, so just to iterate over what we have done, we have created a new account object. We have given some account number to it. We have given an account type and we have given some amount into that account. Then what we are trying to do is we are trying to deposit some amount into my account, and then two subsequent withdrawals are happening. So let's see how the program runs here. Okay, now you can see we initialize the account with 100 rupees. Okay, these are the SB101 and SB are the account number and account type of my account. Now these values would be unchanged throughout these SOPs, so we can just happily ignore them. We'll see that this is the initial state of the amount. This is what happens when I deposit. So I have made a deposit of 100 rupees. What I'm doing is I'm adding this amount into 100. So it becomes 200 now. After that, I'm making a withdrawal of 50 rupees. So because of that withdrawal, my amount would now remain as 150 rupees. After the first withdrawal, what I do is I make a second withdrawal of 1000 rupees, which will not be permitted because the amount is very low here. So as you can see, it was returning a false here, and my amount would now remain same as 150. Basically, none of the withdrawal, the second withdrawal didn't happen. So this is how you can try to think of creating a class and writing some of its fields, defining some behaviors, and how do you execute them. So the next topic that we have in mind is what is public static void main method. Now let's just go over it. Okay, so let's discuss on what is the public static void main method that we have defined here. So main basically is like a special method that provides the entry point to the application. Your application can have n number of files, and just one file needs to have the main method. So this method allows the class containing it to be getting invoked. The signature of this method is, as we have seen, public static void main, and the arguments that it expects is a string array. Okay, so these arguments can be passed to this program via the command line argument, or let's see that how do we try to get these parameters here. So let's say that I want to see what is the value of those string variables, string array coming into the program here. Let's say is the string input passed is, let's say I'll pass two parameters to the array of size 2. Okay, so let's say I'll print the value of args0 and args1. Okay, so I'm just printing whatever the value I'm passing into the program. So how do I pass the value in NetBeans? So the way forward to do is that you select the project, right click on that, go to the properties, select run, and you can select your main class from here. So say for example, I'm just removing the main class name. I'm passing two arguments here, hello world and hello 111. Or let's say that I'll pass here is hello Java. Okay, so once I add these arguments here, those would be passed into the main program of the application. So let's run this thing. Let's run the module and ask what is the main class, because it's having like two main classes are present in both the account and the first Java class. So it's asking which main class to pick. So we'll say that pick it from the account class. So you can see here, these are the two values that we had passed, hello world and hello Java. So these directly came into the program here. So this is a way of passing the input parameter into the main program. Now having gone through the fields, methods, and Java objects and classes, the next topic in hand is constructor. So what basically is a constructor? So every class must have at least one constructor. So this method, it basically is like a method, and that gets called whenever you try to create an object. So whenever the JVM encounters the keyword new, it calls the constructor for the corresponding class. So almost like a method, but it should not have a return type. not even void. And the arguments that we can pass to constructor, it's kind of up to us. It can have like one argument, or we need not pass any argument to that. The thing is, we need not even define the constructor. If there is no default constructor defined by the programmer, what the compiler does, it creates a default constructor of its own with blank values. And until unless there is a constructor in the class, no object can be instantiated. So let's try and see how do we create a constructor, what is the use, and can we pass some parameters into that, and do we really need to? How does it work? Okay, so let's take the same example of the account class that we just created. Okay, first thing to notice, it should be the name of the constructor should be same as the class name. Okay, if you want, you can define some body into that. If it's not defined here, it's basically like the default constructor that the JSON creates. So let's try first of all running it and see what happens. So as we had kind of added some arguments to it, it's asking us to run via the module. So let's run via the module. So you can see that nothing important has happened as of now. Let me just remove these arguments from here, and so that it becomes easier for us to run the program. Let me just hide these methods, whatever methods we have added, and let's just keep what is available in the main method. So this constructor would be called whenever this new keyword is encountered. So to prove that, let's put up SS out here. All right, okay, now let's run this program. As you can see, the output of the previous run, because we have removed this particular line, this won't be coming. Initially, the initial values of the objects were getting displayed. So now we have added a line into the constructor, SS out into the constructor. Let's see what happens now. So you can see that this becomes the first line that is called from main. Okay, so automatically the control goes to the constructors method whenever it encounters a new keyword. Now let's take a couple of other examples. So as you can see that this is the logic that we have defined here, that we created an account with some account number, type and amount. So what if I'm creating like hundreds of objects? I'll have to write these 3 lines again for all of them. So Java provides a way of passing this information while object creation. So that happens via the constructor. Now how that happens is, so I can say that I can create a constructor in this manner that expects some arguments. Let's say it expects a string, account type. Okay, let's say that it expects an account number. Okay, it expects an account type, and some amount. Okay, now what it can do is it can directly assign these variables to the input parameters that we are passing. The account type, account number, and the amount. Okay, so this is how we have defined another constructor for our class, and we are passing values like account number
account type and amount. Okay, so now let us run the same program. Okay, now I'll also add a sysout parameter here. I'll say that called first from main, and this is the default constructor, basically, which doesn't have any arguments here. And I'll say that this gets called when it has passed some arguments while creation of the objects. So I'll say constructor with arguments. Okay, now again let us run the program without changing anything in the main method. So you can see as of now I'm not passing any parameter into the test objects constructor. So what happens is the default constructor gets called. Now let us say that I'm trying to create another object. Let's say that I've created another object. The object name is test object 2, and the way that I create this is I'll pass all the values into the constructor. Again, it's a savings bank account, and this guy has around 1000 rupees in his account. Okay, so this is what I'm doing here. Let me just remove the test objects deposit and the withdraw methods. Let us keep it very simple here. So the objects initial, the test objects once initial values would be printed here, and let us print the values of test object 2. We as you can see from here, we haven't assigned anything to test object 2 like we have done for test object. So let us see what happens now. Okay, let's see when we run this program. Now you can see the test constructor, the test object, it calls the default constructor because we haven't passed any argument to it. So this line comes up as soon as the test object gets initialized. This is the line that gets printed here, default constructor one. Now once we have assigned some values to that and we are trying to print, so it gives us the object's initial values, that is SB101, savings bank and 100 rupees. Now this is the account object that we have created, and we have passed couple of values into the constructor like SB102, SB and 1000 rupees. So automatically the constructor gets called here, and this is the constructor that is getting called first from main constructor with args, and here everything is assigned into this test object 2 with whatever we have passed. So you can see similar values are getting printed, SB102, SB and 1000. So that is the use of basically creating a constructor. You can create the object and at the same time you can pass the initialized value into that. So yeah, so that's it from the constructors.
Now let us take a look at what is JavaScript. It is important to understand what JavaScript is and how it can benefit us, mainly because JavaScript's meaning has evolved from time to time. Before the current versions of JavaScript rolled out, JavaScript was only used for web browsers, but now it can be used in different ways. So let us take a look at what it actually means. JavaScript is a high-level, object-oriented scripting language. It was created by Bernard Ike in Netscape in 1995. So JavaScript was originally created in 1995. Now, high-level, object-oriented and scripting language are sometimes considered to be a bit more jargonistic than they need to be. Let us discuss them one by one. First thing is high level. So a high level programming language is basically a programming language that does not deal with the low level memory management stuff that other programs might have to deal with. This is because JavaScript has a runtime environment, and what it does is that it takes a look at the code that you have written, takes a look at the memory that it will need, allocates that memory and continuously at regular intervals of time keeps checking if there is some memory that can be freed up. And if it can be, then it frees up that memory, and all of the variables that were assigned in that memory are going to be completely wiped off. So it will allocate and deallocate memory on its own. That doesn't necessarily mean that you have just no control over how things are happening behind the scenes and how you that you don't need to care about memory management at all. But at smaller level to medium level applications, you don't really have to worry about how applications are being built and how they are going to be used. At a large scale application such as a large scale JavaScript application such as Gmail or Google Drive, you have to worry about how memory is being used and you have to be very efficient about it. There are certain things that you can do in order to affect how the memory management is going to take place and if it's effective or not. So you can talk about this and discuss about this at length, but that's basically what high level means, that at the beginning you don't need to worry about how to allocate and deallocate memory. Whereas in programming languages like C++, you would have to do the memory management stuff on your own. You would have to allocate a chunk of memory to your program. When that program or that piece of program that executes is done, you need to then deallocate that memory. If you do not, then that memory is going to be reserved and is not going to be used by your program or by any other program because the compiler has not freed up the memory. So just keep that in mind. It's also object oriented. Object orientation is basically a paradigm of programming in which you write code so that your code can reflect real world objects and scenarios such as people, person, events, things like that. This is really important because in enterprise level applications, when you're building applications for companies, the common language that you use are going to be to describe these things. In programming, however, these things are not really something that people consider. So you can create your own objects, you can create your own nomenclatures and translate them into code. This is what object-oriented programming allows us to do. And it's a scripting language because it was developed in order to write and to be written and be executed by the browser. Scripting languages are executed by some other programs, not by the operating system itself. So if you are trying to write JavaScript in the browser, then it's a script, not a program. However, it's very important to understand that JavaScript has now evolved and now it can be used to build other kinds of applications as well. So when it started out, JavaScript was a very simple scripting language that was developed in order for the sole purpose of manipulating web pages, adding content, removing content, animating things into the frame, animating things out of the frame, changing the styles and whatever. Nowadays, because JavaScript is so popular and so easy to pick up, many of the programming languages many of the paradigms and platforms support JavaScript. You can build JavaScript. You can use JavaScript to build mobile applications, servers, program web servers. Web applications are already being developed using JavaScript, and there are many other kinds of things as well, such as native Windows applications and all. So you can use JavaScript to build different kinds of applications. It has been supported on multiple platforms and will continue to expand its support. So with that, we have a clear picture of what JavaScript is. Now let us take a look at how you can use JavaScript. In this presentation, we'll be taking a look at how you can use JavaScript in a web browser. There are multiple ways of doing so. However, JavaScript, as we have discussed, can be used to build different kinds of applications, and we won't be discussing it here. With that out of the way, let's take a look at how you can use JavaScript. So there are three ways to use JavaScript, especially in the browser. So in the browser, you are supposed to write the JavaScript code in the HTML file or some other file and embed it. But how do you do that? Let's get started and see how you can do that. The first thing you have to understand is that the reason why there are so many ways of writing JavaScript depends on what kind of code are you writing. And in the hands-on for this topic, we'll discuss what that actually means. So the first thing is that it can be inline. Basically suggests that the code that you're writing is completely embedded in the HTML. So if you have a button, it is right next to the button and it's only regarding that button that the code is going to run. So that's one way of doing it. The reason why inline code was invented was that if you had some small bit of code that only needs to run on a particular time or at a particular time, or when it is associated to a particular HTML element, then you can just write it there. Instead of polluting your HTML with different kinds of things, you can just write it there. Then there's script tag. So a script tag basically means that there, just as in HTML, there's a style tag in which you can write CSS. Script tags allow you to write JavaScript code. when the browser sees the script tag, it will take anything written inside the script tag, which is the opening and closing tag, and consider it to be depending on the version of your browser and what kind of support it provides. So in scenarios like this, earlier we would have to have write some kind of a text that describes what kind of script we are writing inside the tags, such as text slash JavaScript or whatever. Nowadays, it is considered that by default, you're going to be writing JavaScript in the script tag. So you don't have to worry about that at all. Then comes script files. Similarly to script tag, you can write your script inside a file, give it the .js extension, which is the JavaScript file, and you can embed it inside your browser. So you are going to say, okay, after you're done loading the HTML page, load this file as well. This file contains some HTML code, and this file contains some JavaScript code that needs to be embedded in the HTML file. Now, the reasons for the different kinds of script files is something we'll see in the hands-on, but basically it depends on how much of the entire HTML page is going to be affected by the JavaScript. So let's take a look at the hands-on and understand how that works. How you can write the JavaScript code. We'll be printing something on the console. I'll explain what a console is, but first let's see our setup. I have a file, I've called it index.html, and I have opened it in a code editor. I'm using Visual Studio Code. You can use any code editor or text editor that you wish to use. Open that file inside a web browser. My file is located in the E drive and it's called index.html, but you can call it anything that you want to. It's just a convention. Now let's take a look at the different ways that we have discussed using which we can create our JavaScript code and embed it inside our HTML. The first thing we have to do is we have to write some HTML code. Now in Visual Studio Code, I have a snippet that will automatically write most of the HTML that we need in order to get started. So just press this bang symbol and press tab. This will only work in Visual Studio Code. If you're using any other programming environment, this may or may not be available there. So just make sure that you know that it is there. I'll call the title to be JS tutorial. I will save it. And now if I go back to the browser and if I refresh, if you take a look at the title right now, it's index.html. Refresh it. Now it's called JS tutorial. So in case you're not familiar with HTML that much, I would recommend that you first understand HTML because JavaScript builds on top of HTML. So if you don't know HTML, then this is not going to work. Now let's take a look at the different ways through which we can use the JavaScript code. So there are different ways. Firstly, that's the inline code. So how do you write code that executes inline? Well, let's say there's a button. I call it log button. And what I want is when this button is clicked, I want to print something on the console. Now, what is the console? Different programming languages such as JavaScript and C++ have a console. Now, a console is basically just a terminal or a command window which will show the output of the code that you're writing. You can also put the output inside a file or inside some server, but basically this is where the output can be seen. Now, in a web browser, it's a little difficult. So what every web browser has is a JavaScript console. Right click on the web browser and click on the inspect button or press Ctrl-Shift-I. Nowadays, every web browser has this. When this opens, you can see that it has a console button here. I go up to that and I can execute my JavaScript here as well. To print something on the console, you can just execute some JavaScript code here as well. I can write console.log and I'm using Google Chrome, but you can use any web browser such as Firefox or the Edge browser using Microsoft, and it will work just fine. And you can write hello world. Semicolons are not required, but it is a good practice to write them. You press enter and this is what it prints. Hello world. Forget about this undefined right now, that doesn't really matter. Now what I want is I want this to be a little more interactive. To do that, I want to have a button which has the keyword log inside it. So if I refresh this, you can see there's a button, but nothing happens when I click on it. So that's a problem. Now I want to execute the same code that I have written in the console, but I want it to happen when I click on the button. So don't worry about the syntax right now. I'll explain what that means in a moment. Just write this JavaScript, hello world, and I can put the semicolon here as well. I go back. If I click, nothing will happen. This is because our browser has the old version of our index.html. We have to refresh it so that we can fetch the new version. To take a look at the current code, right click on the page and press view page source. As you can see that the button now has console.log because it has refreshed. If I refresh this, now everything will work. If I press log now, it prints hello world onto the code. Now, as I've already discussed, the reason why there are multiple ways of doing this is because I only want to run this code when a person clicks the button. Suppose that there are multiple buttons on my page. It's a huge page. There's like thousands of lines of code. And somewhere down the line, or like 1157 line, I write button and I want the same code here. One thing I can do is copy and paste it here, such as this. But this violates an important principle in programming, which suggests that you should never copy and paste the code. So console.log, console.log. It does work, but there's a problem here that you may or may not see. Suppose that this is like, again, as I've said, it's on 1000 line. Multiple people are working on this because this is such a huge file. Somebody comes along and says, okay, the message that we want to print is hello world, but we want an exclamation mark here as well. I put the exclamation mark, I save it, go back to my HTML page, refresh it so that I can see, press on the log button, and okay, it's showing the exclamation mark. So our code works, but the problem is now that the part where we copied the code, it's showing the old version because we didn't update it there. So now we have to go down again and press this, and this is only for two buttons. Suppose there are millions of buttons on a page. Suppose there are buttons and forms and we want to perform these tasks, multiple tasks, and synchronize them together. This could be really difficult. Right now it's working, but it's going to be really difficult. There are other ways of doing this, of course, and we will take a look at those one by one. But to overcome these issues, let me just close this up. Yeah, so I'll just put an h1 tag, look inside console. Now let me just show you what a script tag looks like. So after this, I can write script tag, and here I can write my JavaScript code and it will work just fine. This time it won't work when I'm pressing a button. That was just for the inline version. Here I can just write some code that will be automatically used. So as you can see, as soon as my browser starts looking at the code, it takes a look at the code, creates the h1 tag, displays it on the screen, then takes a look at the script tag. What it does is that it prints everything that needs to be printed on the screen and then closes the script tag. So everything after this needs to be interpreted as HTML, and that happens. So this is why when we look at this gets printed and then this gets printed in the console. So that's one way of doing this. Another thing to understand is that this isn't the only way that you can do this, but this is a good way to get started. Another way to do this is going to be if you can create a script file. So now script files are basically just files that you can use in order to write your code inside them. So you don't want to mismatch your HTML and JavaScript code. What you can do is you can just use script.js. Now to show you how that works, all I'm going to do is I'm going to open up a script.js file that I have already written. I'll write console.log. I'll print hello world. It's the same code that I have written thus far, but it works. Now I write it here, copy, paste, save. If I remove this now and I'll just keep it here. Now do you think it will work? Not exactly, because our HTML page has no idea that the script tag exists. So inside the script tag, I have to write another attribute called source, and the source file is going to have a name of script.js. Save this, run this again, and now it works. So now what happens is it takes a look at the entire web page, takes a look at the h1 tag, displays it on the screen, takes a look at the script file, opens up the script file, executes the code inside it, comes back, closes the script tag, closes the body, closes the HTML, and is done with it. Now the reason the script files were invented so that because we may have multiple web pages. So it's not that we only use one page. We could have about.html and many different kinds of files, and we want some file to have access to all these pages. So in cases like this, if I have an about.html, I can just copy and paste this script tag, and that code will be available inside that file as well. So when that file is loaded, it will be logged on the console as well. And if it's like 10 different files, all I have to do is just change it here. If I want to make another change like this, and all of this will be reflected in all the files. So that's the reason why we do it this way. Now again, this is not the only way to do it. As we have discussed, three ways you can work them out and understand how to use them. Very much like CSS, in which you have inline styles, uh, file level styles, and then external styles in which you can create your own CSS files. Script tags works the same. In other versions, because script files are could be so heavy, let's say that you have 7 different script files, then it could be possible to just merge them all into a single file. This is called a build step, and you don't need to worry about it right now. But basically, in cases like this, all of the JavaScript code that you write is taken and merged into a single file by a program called a build system that you can configure yourself. And then it creates that single file so that when an HTTP request is sent, only one file is sent over the wire and multiple requests are not done. So you can take a look at that as well. But these are the ways that you can configure a JavaScript file to work with your HTML page. Again, you need to know HTML in order to work with JavaScript, because that's how it was created. So that's how you can get started with it. Alright guys, now let's take a look at what can you build with JavaScript. So we have discussed thus far what are the different ways that you can use JavaScript and what JavaScript is. But now let's take a look at what it can be used to build. So using JavaScript to build different kinds of applications has been the norm. Many different companies use JavaScript for different kinds of applications that they build and use. Let's take a look at what these are. So JavaScript can be used different kinds of applications. These are web applications, web servers, native mobile applications, and hybrid mobile applications. All of these have different ways of being used, and different JavaScript code can be used to use it. So let's take a look at them one by one and demystify how these things work. So the first thing is web application. Using JavaScript to build web applications has been the norm. We have been building web applications using JavaScript since the invention of JavaScript. Now, the reason why it's so popular nowadays is because there are multiple ways of building a web application using JavaScript. The easiest and the most fundamental way is the way that we have discussed thus far, in which you create an HTML page, write the HTML code, embed some JavaScript in it, either using inline JavaScript or script tags or script files, and then that code is going to be used to manipulate the JavaScript, manipulate the HTML page using the JavaScript in some way or the other. Now this manipulation can be of several ways. Either you add some element on the node, remove some element on the node, get some data from a web server, and after getting that data, populate the entire HTML page with some new content that is available, let the user know that some new content is available, and many different kinds of things. Now that is important and very, very useful, but that's not the only way that you can do it. The other way is using something called single page applications, in which there's just one HTML page which is used to just give the basic scaffolding and the shell of a page. Outside that, we have a JavaScript page that takes care of everything else. So if you've heard of frameworks such as Angular, Vue, React, they work on the similar premise. What happens is your HTML code is very minimalistic, and it is a big fat JavaScript file that is transferred over the internet. Once the user's browser has that JavaScript, it tries to execute it. When it's executing it, it's creating multiple HTML nodes using JavaScript, putting it inside the HTML page, and then JavaScript takes care of everything else. Navigation, HTTP calls, manipulation of the DOM, any kind of thing that a web application is supposed to do, JavaScript will take care of it. These applications are really JavaScript rich, and HTML is really used as a skeleton. Not much of HTML is used. CSS is used throughout, and it will be continued to use throughout, but that's the way it works. So because of this fundamental shift in how web applications work, the responsibilities of web servers have changed. So let's take a look at how you can use JavaScript to build web servers. Now, what used to happen before we had platforms like Node.js, which we can use to build web servers, which we'll also cover in this tutorial. But
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
The reason why web servers were a little difficult, especially for front-end developers to understand, is because of the language barrier. So in JavaScript, in the front-end web applications, we'll be using JavaScript all the way. And since that was the only language that we would use to manipulate the web applications and its structure, but in web servers, you can build a web server using different kinds of technologies. JavaScript was not one of them. So the way you would use it would be using technologies such as PHP, which is still by far the most popular server-side scripting language. Then there's Java, which is very popular in the enterprise world. So is C# and the .NET platform. There are other languages such as Ruby and Python that were used, but JavaScript was not really a big player in that regard. So what happened afterwards is that we had the introduction of the Node.js platform that allows us to write JavaScript code so that front-end developers can sort of port their expertise to the backend. Now, it's important to understand that just because you can write JavaScript code on the web server or write the code to create a web server, that doesn't necessarily mean that you can just copy and paste your entire JavaScript file from the web browser to the web server and it will work exactly fine. Mainly because these are two different environments. In the browser, you will have elements such as a button, you will have elements such as a form, list, and whatever. It's a very visual environment. In servers, you don't have that. You have number crunching and different kinds of things such as accessing databases, caching data, serving up data, and whatever. So these are two different environments, although you can use the same JavaScript syntax, for loops, console logging, promises, and all the features. But you can't just port the code from here to there, just copy and paste, and it will work. So that's something to keep in mind. Now, in web servers, we use Node.js. Node.js has come a long way. We have Express.js, which is one of the most popular frameworks out there. Node.js is really popular among enterprise as well. And any kind of application that you want to build using backend development, Node.js is very much likely a good option to do that. Then comes native mobile applications. Now, the reason why we are making a distinction here between native and hybrid mobile application is something that we'll discuss in a moment. But the reason why we are saying that we can build native mobile applications is because before this, if you wanted to build an application that your customers could use, you had multiple platforms that you needed to tackle. Platforms such as Android, iOS, Windows Phone, and some other platforms as well. This was a bit problematic because then that means that if you want your application to be accessed by a large number of users, you need to write code for both Android platform as well as iOS platform. These two platforms have different programming language, different programming structure, different skill sets, and different environments in which you can develop applications. Android is open source, so you can build Android applications in both Mac and Windows. However, Apple doesn't allow you to build iOS applications on a Windows laptop. So you need to have a developer account, you need to have a Macintosh laptop, you need to have developer tools installed, you need to have an iPhone to test your applications. There's just a lot of upfront capital required there. In Android, you have the emulator, you have the open source tools and everything. But still, the languages are different. JavaScript is not really the language that they use, but they use Java in Android. And in iOS, the new language that is being used is Swift. And in Android, the new language that is being used is Kotlin. And the previous language in iOS was Objective-C. None of these languages are easy to pick up. And because JavaScript is so easy to pick up, more people know JavaScript than they know Java or Swift or Kotlin or whatever. Now, this is a problem mainly because the web applications that people build almost exactly mimic the features that we would want in an application, in a native mobile application. Now, there are ways through which you can use your current web application and have it work as sort of a substitute application inside your mobile applications. But the problem is that at the end of the day is using the web browser. So what happens is your web page is loaded into a web browser and it takes care of everything using JavaScript. Your application has no access to all the underlying features such as the camera, the machine learning features that have been developed, the Bluetooth, speakers, OS, internal hardwares, voice recorders. You have no access to them at all. So if you're trying to build a camera application, you can't do it using JavaScript, or you couldn't have done it. Nowadays, there are frameworks such as React Native, NativeScript, and many other kinds of platforms available where you can use your JavaScript skills in order to build native mobile applications. Again, it's not as simple as just copying your JavaScript code from your web application or your server application into a native mobile application. However, it is very similar to not learning a new language, but understanding the ins and outs of a platform and then adding your skill set on top of it. These applications are really native mobile applications, and the great part is that when you write the code, that code will get converted to both an iOS application and the Android application. You would still need to have the developer account, and for testing purposes, you would need to have access to an emulator or a Macintosh OS in iOS's case or whatever. But you can still have an application that will work. So that's the great part here. So this is what native mobile applications do, but still it needs a lot of configuration and understanding of the platform before you can even start building an application for the platform. On the other hand, we have hybrid mobile applications. Now this is a solution that has been available for a long time. What it allows you to do is it allows you to write JavaScript, and that JavaScript will then get converted into native OS calls. But this is a little slower than native mobile applications. If you're building applications that are just there to deliver content, such as an application that is there to tell people about the new concerts that a band is going to have, new conferences available, new videos available on a video store or whatever, then hybrid mobile applications are good. Native mobile applications, on the other hand, if you want to access the native features such as camera, browser features, voice recorder, Bluetooth, gyrometer, sensors, infrared, whatever your application has to, whatever your mobile has to offer. So hybrid mobile applications use platforms such as Apache's Cordova, and many other new platforms are available as well. You can take a look at these platforms and build these applications yourself. It's not very difficult to learn how to build these applications, but these are really helpful for us to use, and they're very easy to use as well. So these are some of the platforms that can be used. You can also build native Windows applications. You can also build native desktop applications using a platform called Electron, which was developed by GitHub. And there are many others as well. It is too much to count. But these are the platforms that are used. As you can see, JavaScript has evolved from a very simple programming or scripting language that was used to manipulate web pages to a full-fledged application programming language in which you can build applications of multiple kinds. Kind of like Python, but a little different. You can also write machine learning and AI code, but that's a whole different topic on its own. So that's how you can build applications. These are the kinds of applications you can build using JavaScript. This is exactly why JavaScript is one of the most popular job positions right nowadays. JavaScript developers are in high demand because they can use their skills or already existing skills and learn some new skills in order to build many kinds of applications. So with that in mind, let's see what else we can learn. Now we'll take a look at the basics of JavaScript. JavaScript as a language has several features that we can learn in order to get started with the basic concepts of programming. If you've never learned how to code, then you can follow along with us. This section is going to be really hands-on focused. So we'll have a lots of hands-on. We'll discuss a lot of caveats that you can learn when trying to learn a programming language. If you have already learned some basics of some programming language such as Python, C++, Java, it's going to be useful for you to follow along with us so that you can understand what are the features and differences between JavaScript and the language that you have learned. So firstly, we need to get comfortable with the JavaScript syntax and language features. So how does JavaScript work? What are the features that a JavaScript program would have, and how you can write programs on your own? The topics mentioned below are the topics that we'll be covering one by one. We'll have a hands-on for each one of those, and we would like for you to follow along with us. You don't need much of setup. All you need is a web browser, a code editor, or a text editor of any sort, such as Notepad if you don't have any, or Visual Studio Code, or you can use other code editors such as Sublime Text, Atom, Brackets, and any other kind of text editor that you prefer. And for that, we'll go through each of the topics one by one, and we'll cover as much ground as we possibly can. So let's get started with this. The first thing is variables. Now, in case you have programmed before, you already know what a variable is, but if you don't know, let me just clarify this for you. A variable is basically a name given to a memory location in which we can hold some data. That's basically all that is. So if you want to get as an input a user's username and password, you can store them inside a variable. That variable is then going to take care of everything that you store inside it. So we have a container. That container has a name. That name is then going to be used to reference to whatever value we put inside it. Think of it like a bucket inside a memory. Think of a memory as this empty room. We have a bucket. We put it with a name on that bucket. We put it inside the room. And in the room, inside the bucket, we put some information, something. Let's say that I want the username. So I create a bucket named username, put it inside the memory, and now whenever I want to use a person's username, I would first ask them, okay, enter a username. That person will enter the username. That username that the user entered will be put inside the bucket. And now whenever I want to access or remember what the username that the user had entered was, we'll take a look at that. So that's how variables work. Variables allow us to store data. Now it's called a variable because the data inside it can change at any time. It's variable depending on what is the last bit of information you put inside it. So that's the way it works. It allows us to store and remember data that we would need in a future computation or a future process. Now, variables store data in computer's memory or your system's memory. That means that they are volatile. So in case your program accidentally closes, anything that was stored inside a variable will be lost. If you don't want to lose it, then there are ways that you can store it inside a file or whatever. We're not going to be covering that, but that's how variables work. The data that you have inside a variable can then be stored inside a file, on a web server, on other data storage platforms as well. But as of now, when you're using a variable, we're talking about data inside a memory that was given a name so that it can be accessed later. The data inside the memory location can change. That's why it's called a variable. All right. So now let's take a look at a hands-on in which we'll be learning variables. So we would very much like you to follow along with us in this hands-on, and we will cover variables in this hands-on. Again, you don't need much. All you need is a code editor. I'll be using Visual Studio Code, and you need a web browser. In the web browser, just any web browser that you use the same setup that we had earlier, in which we had created an index.html file. Open that up in the web browser and in the code editor, so that when you make changes to the code, you can refresh the browser and see the changes being reflected here. Open up the console as well, because this is where we'll be using the web browser. This is what we'll be using inside the web browser as of now. So again, I will just use the script tag so that I can just embed my code here. But the basic understanding here is quite simple. The code that we're writing is JavaScript, and we want some input from the user. Now, I will tell you how you can get input from the user in a moment. Right now, let's take a look at how you can declare a variable. So in a variable, there are multiple ways of doing with things. First thing I'd like to show you is how you can write a comment. Comment is basically something that you write that you want the person who's reading the code to be able to understand, but you don't want your browser to interpret that code. You're basically saying this is something that is not code, that is just something that a person who's reading the code is supposed to get. You don't have to worry about it. Don't interpret it. This is not code. Just move along and skip this line. So there are two ways of writing a comment. One is you can use 2 forward slashes or the division symbol, and that is a single line comment. So single line comment. Let me just change the theme so that it's a little more apparent. Yeah, hopefully this is visible now. So I have a single line comment, and now I can have a multi-line comment as well. This is what happens when you have a divide symbol followed by an asterisk or a multiplication symbol, and this closes when you have a multiplication symbol and a division symbol. So start and the end. So the way you start it is this. You basically just create this symbol, and then you write the code that you want, or write the things that you want to write. So this code is using a variable, and I can write it in a new line. Variables are being used, or whatever you wish to write. This is to explain the code so that the person who's looking at the code can understand what it is doing. Now, a single line comment is good if you just have a single line description. If you have a multi-line description, then you can have a multi-line comment, right? So now let's show you about the 3 things that we need. So there are 3 things that we need to understand. First is declaration, and second is after declaring the variable, we use the variable, or you can also call it initialization, and the third one is using the variable. So the way it works is this. To declare a variable in JavaScript, you are likely to use a keyword called var, var. Var is a keyword that was developed in JavaScript so that you can use variable of any kind. If you come with other programming languages, then you would have to use the keywords such as int, string, or whatever to describe the type of language. Here you just need to use the var. And now I need the name of the variable. Let's say user name. And this is what is called a declaration. I'm saying, okay, I'm going to be using this variable. Now, JavaScript to a certain degree is a very relaxed language. So even if I were to not use the var keyword and say hello and then console dot log the username, it will still work. It might throw an error, but it will still work. So it doesn't even throw an error. Now that is a problem that when you're writing the code, there are certain tricks that you can use. One of these is something called use strict, which will work in a JavaScript file. I don't know if it works here or not, but that way it will be very strict in checking whether or not a variable is there. So it says, okay, the username is not defined and you're using it, and it will return an error. So that's one way. Now, if you want to use the username, just use the var keyword. Now it's defined, and if you want to initialize it immediately, initialization basically means assigning a value to the variable. As soon as you're creating a bucket, you're filling the bucket. So you can do it this way. I have it here. I refresh and it works. Even if I were to instruct the browser that be strict and don't allow any problems in my code, it will still work. So that's one way of doing it. Now that's called initialization. That's the second part. Now declaration is this. You just create a variable and you say, okay, I need this bucket. I'll use it later on in my code. I don't need it anywhere else. I just need it right now. Now, how you can take the input of the user? There are various ways. One way is using prompt. Now, this is only available in web browsers, and this is not used commonly because in web browsers, you're not allowed to take users' input like this, or you don't usually do. But if you want, you can just prompt the user and say, enter username. And whatever username is entered, you can just put it inside username. Save it, and then you can print it. So if I go ahead, refresh this, it says enter username. I call it John, press enter, and this is how I can get a user's input in JavaScript. Now, again, you don't really need to use it, but you can if you wish to. So that's what declaration and initialization is. And then using a variable is, again, the simplest thing that you can do is just print it. Now, printing is not the only thing you can do. There are several operations, which we'll discuss when we're discussing operators. But basically, when you're trying to learn a new language, understanding how variables work is really crucial. I can declare multiple variables as well, such as username, and another would be using password. Now I can declare them on the same line if I wish to, or I can declare them on multiple lines like this, so that I use the var keyword again and again, or I can just put it like this. And again, if I had another variable name, I could do the same thing again. But it doesn't matter how you do it. What matters is you're describing some type. We would always recommend that when you start a JavaScript file, you use the use strict declaration, so that when you are using a variable that is not declared, it doesn't become a headache to understand how it works and where things happen and how things happen. So always use this if possible. If you are new and you don't want the safety and instructions, then you can leave it, but we recommend that you keep it here. Now, again, if you're coming from different programming languages, you would think that you would need to describe the kind of data that is going to be stored inside it, but such as a string, integer, or something like that. But that's not really the case. This is called a loosely typed language or dynamically typed language, in which the type of the data is just something that the language figures out automatically. Data types are still available, and we'll discuss them now, but the reason why they are not available in the same way in other languages is because in JavaScript everything is loosely typed. So if you have data in one language, one type, and you want to convert it to other type, you can do so quite easily. Let's discuss this now. Let me just save this up and let's see what else we get. Alright guys, now let's take a look at data types. So as we discussed, that there is a way for us to get data from the users and put that data inside a variable. That variable is something that we can use later on. So for instance, we took a user's username as some information using the prompt function. Now that's not the only way that you can take data. In fact, in a web browser, you usually don't take data like that. You use a form that the user will submit, and you will then get that data and put it inside your web browser's memory, and that's where you use it. Now, the real issue here is that something we haven't quite touched on thus far, which is data types. So,
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which of the following is not considered as an error in JavaScript? A. Syntax error. B. Missing of semicolons. C. Division of 0. D. missing of brackets? Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
As you can see, that data is of different type. One, the username, that could be a long string of text, long line of characters, one after the other. The other is numeric data. So you're asking for a person's age, their salary, their height. All of this is numeric information. Then there are other kinds of things such as true or false. So if you're asking a person if they are above the age of 18 or not, if they are senior citizens, you can get this information simply by taking a look at their age and determining if it's above certain threshold. But there are certain instances where you don't want that information. You just want to know if they are above the age, if they are senior citizens in their own country. That's another way. And so many different kinds of data. So what does that tell us about the languages that we use? Well, one thing to understand is that different data have different operations available to them. So if I have a number and I say, okay, I have 5, multiply it by 10. That makes perfect sense because multiplication is an operation that can be performed on numbers. Now, if I were to take a look at some other kind of information, such as if I were to say, okay, I have a username, multiply it by 10. You're not going to make any sense of that because it doesn't make sense of multiplying a name by some number. It makes no sense to do that. So your browser is going to complain, your program is going to complain saying, I don't know what you're asking me to do because this is not how this works. Now, how does the browser or the language know what kind of data is stored inside a variable? Is it a number? Is it a long text? Is it some binary information such as true or false or something like that? This is done using data types. Now, data types are of many types. We'll discuss them when we're looking at the hands-on. In JavaScript, there are many kinds of data types, and in many other languages also there are many kinds of data types available as well. So this is the way we use the data types that we have. Data types allow the compiler or the interpreter, when it's interpreting the code, to understand if a particular operation is legal or not. This is the most important aspect when we're learning something. So let's take a look at a hands-on and figure out how this works. Now let's have a hands-on in which we'll discuss the different kinds of data types that are available for us. So for that, all you would have to do is just follow along with us. Open up a web browser, same as before, and open up the text editor. You might also not need the text editor right now because we'll just be writing it in the console, but it's a good practice. So I want to declare a variable x is equals to 1. Now, this is obviously a number, but if you want to take a look at the data type of a number, you can use the type of keyword and type the name of a variable that is available next. So x, it will give you number. So it indicates that it contains a number. Now, even if I would just write the value here, it will work just fine. Even if it was a fraction, this would work. Any other kind of value would work. So that's a number. Numbers are quite self-explanatory. These are just values that you can use. Similarly in mathematics, the same way that works in mathematics, they will work here. Now we also have the username. Let's enter the username of John. Press enter. If I were to now, let's take a look at the value. Its username is John. And now if I were to take a look at the type of the data, it is string. So string is nothing but just data enclosed within quotes. So even if I were to write one inside quotes, it will be a string. So if I were to do it this way, this is a string. So one thing to understand is that it doesn't necessarily have to be double quotes. As you can see here, let me just expand this up. It doesn't have to be double quotes like this. They can also be single quotes like this. And this is also a string. Here you go. Empty double quotes and empty single quotes are string. Anything within a double quote is a string. Anything within a single quotes is a string. So if I want 1, 2, 5, 7, 6, 1, 5, 4, 8, these are numbers, but these are strings. If I were to remove this, then this becomes a number. Now, the other thing to understand is that even if we have strings like this, the important aspect of the strings is that they are just a collection of characters. So that's the way it works. But if you want to add some sort of a text inside it, such as, let me just show you. Now, if I were to write, okay, John said, let me just, John said, and now if I want to quote it, I can't use double quotes, as you can see here. This will give me an incorrect syntax and I'll get an error. So if you have started a string with double quotes, if you want to add more quotes inside it, you can use single quotes. So just this, John said he's not coming. So that's a single quote, or he is not coming. You can write it this way, and this is still work. Now, If I were to do it the other way around, if this was a single quote, then also this would not work. So I would have to create a double quote and this will work. So as you can see, these are how the quotes work. Now this is called a string. What about values where you just have values such as true or false? So if I want to check, well, if a user enters a username, and if I want to check, well, is the username the same as John? So in cases like this, you get the values such as true or false. These are two values that are used inside JavaScript and many other languages, and it's of type Boolean, type of true, and it's Boolean. So as you can see, this is considered to be Boolean. Now there's another type, undefined. This basically means that the value does not exist. Yeah, it's not defined. We don't know what the value is. If I were to now, if I were to create a variable, let's say bad, and if I were to type bad, it has no value assigned to it. So right now it's undefined. If I were to check the type of bad, it's undefined. So I can't perform any operations. Now it comes time for operations, and we'll take a look at more of these operations when we're covering operators. But just to give you a quick overview, for X, we have a variable of 1, right? So I can perform for operations such as X plus 1. 1 plus 1 is equal to 2. So what happens is our compiler or our interpreter will take a look at X, see if it already has a variable named X assigned some value to it. It has a variable named X and the value assigned is 1, so it will substitute it for 1. 1 plus 1 equals 2. That works. Now for username, I have John. If I add username plus 1, I'll get this gibberish value in which it just concatenates the word John and 1. So that works. Now if I were to get the bad variable which has no value and I were to press 1, it gives me another return that says not a number. So depending on the kind of value that you have, you will get different output. That's one way. And if I were to use true plus 1 and get enter, you will get 2 because underneath true is represented as 1 and false is represented as 1 as well. So these are the kinds of values that we have, and this is because we have a simple dynamically typed language in JavaScript. It doesn't really matter what kind of variable it is. JavaScript will try to force one variable into another. But if I were to take username and plus undefined, you can see this is what I'm getting. If I were to get variable and plus true, this is what I'll get. So this is the problem that we'll face. I will think that I have a number, let's say it's 1, but it's a string. I assign it here and I say x plus y, and let's say y is equal to true. If I don't know the type of the data inside it, I expect it to be this and I get this. Or if I would go x plus 12, instead of getting 2, I'll get 112 in string. That's a real problem. That's how we can understand how this works. And this is why data types are important. Our operations, what operations we can perform is going to be shown here. Similarly, if I had username multiplied by 2, I will get not a number because this makes no sense. I don't know what you're doing. So I'm giving you a result that is not a number. If I were to use not a number and take its, this is a really complicated web of how things work. Don't worry about if you don't get it right now. Just understand that there are different kinds of data. Different operations are allowed on different data. So if you have two variables, you're trying to add them, x plus y, but you're getting not a number. That's basically because you have data types of two different types, or you're trying to multiply it and you're getting some other kind of value. Let's say you do this, then you get 0. So this is what happens. If you are finding it a little difficult to wrap your head around, don't worry. Just take a look at the different kinds of data that is available. Now, other kinds of data that is available is arrays and objects, and we'll discuss both of them in a moment. These are containers. They can contain multiple values of different data types, and they can contain the same containers inside them as well. And we'll take a look at that now. So let's take a look at this. Now that we have taken a look at data types and have had a hands-on to understand what different kinds of data types are available, namely string, numbers, boolean, and undefined, let's take a look at what else we can cover. So now we'll cover operators. Operators are basically used to manipulate data available in memory. As we've discussed in the previous hands-on, when you want to add two numbers, you use the plus symbol. That is an operator. Operators are of multiple kinds to perform multiple operations depending on the data type and the data available in them. So we'll take a look at them one by one. But the important bit to understand is that operators need some data. Now you can have operators that are unary, binary and ternary. Unary operators operate on only one variable or one operand. Operators operate on variables, and those variables or data sets are called operands. So if you only have one variable that can be manipulated with an operator, it's called an unary operator. It only needs one variable to work. We'll take a look at the specific examples of these one by one. Then there's binary operators, which take two operands, and you can use these two operands to use these two operands in order to perform some operation using the operators. Finally, there's the ternary operator, in which you use few symbols in order to operate something. We'll take a look at a ternary operator after we have discussed conditionals, and we'll try and explain what that means so that it's a little clearer for you, because these two things are related. But these are the things that an operator is. So we need to understand what an operator is, which is basically just some symbols that we use in order to manipulate some data that we have available in memory, basically variables. Although these values could also be just the literal values that we see and not some data that we get from the user and store inside a variable. However, that depends on how you wish to use it. So now let's take a look at how you can use operators for your benefit. Now let's take a look at a hands-on in which we'll be taking a look at the different kinds of operators that are available and how you can use those operators in order to work with the data that we have available. So open up the web browser and open up the console so we can just write the code and see it work. Now for this you don't really need any kind of different environment, you just need a web browser. Let me just create a variable, call it number, and I'll assign a value of 0. The first kind of operator that we'd like to discuss is a unary operator. This operator allows you to increment the value of a number. So if I have a number and I want to increment its value by 1, what I can do is num plus plus. Right now the value of number is 0. I do this, press num, and now the value is 1. This is called a unary operator because I only need one variable for this to work with this operator. Now it doesn't necessarily mean that I just have to write the plus plus operator right at the end. I can also write it at the beginning, and you'll see a difference here. So earlier the value inside number was 0. I used the plus plus operator. I pressed enter and I got a value of 0 here. Then when I take a look at the numbers, the value inside number, it became 1. Right now the value inside number is 1. I use the increment operator right at the beginning instead of the end, and I press enter. Now I get 2, and now if I take a look at this, I get 2. So what exactly changed here? What happens is if I want to first access the value of a variable and then increment it, so I will use the plus plus operator at the end. This is called the increment operator. So this is called a postfix because I am using the increment operator after the variable name. So if I wanted to print it and then increment it, so let's say I was going to go like this, console.log number is currently 2 plus plus, press enter. So I print 2, but now if I take a look at the value, it's 3. Similarly, if I would have gone plus plus num, right now the current value is 3 and it should print 4. So it increments the value and then prints it, and in this case it prints it here, the current value, and then increments it, which is this. So that's the unary operator. You don't really have to worry about it because it's not just increment, you can also decrement it like this. So now we have number 3 here, but if I were to do this, I have 2, and the same thing, the same logic applies here as well. So now that we understand unary operator, let's take a look at a few binary operators as well. This is what we can do in arithmetic. So if you want to perform arithmetic operations such as addition, multiplication, division, even subtraction, and there's a modulo operator as well, and we'll take a look at them now. So if I have two values, let's say var x is equals to 10 and y is equals to 5, and if I want to check x plus y, I can just use the arithmetic operators. As you can see that this requires two values, one on the left hand side, one on the right hand side. This is why it's called a binary operator. Binary means 2. So I get this. Similarly, if I want to subtract 5 from 10, x minus y is going to work. If I want to multiply these two values, I can do that. If I want to divide them, I can do the same here as well. One thing that you can notice is that if I wanted to take a look at the remainder that we get after we divide x and y, we don't get it here. But if I want to get that, I use the modulo operator, which is the percentage symbol. It means divide x and y, whatever remainder is remaining, print it here. Since 5 is perfectly able to divide 10. That means that you don't get any remainder. But if I were to divide 12 by 5, if I were to do that, 12 divided by 5, I'll get 2.4, which means it doesn't perfectly divide 5 and the remainder is 2. That's the way it works. So that's one way of understanding binary operators. These are the arithmetic operators that have been available to us or for us to use in JavaScript. JavaScript doesn't necessarily have just the arithmetic operators. It also has other operators which we'll take a look at now. But it's important to understand that there are these operators are important, and there's operator precedence as well, such as BODMAS. So you can take a look at that if you wish to as well. Then there's the assignment operator, which we have been using so far. So if I have a variable named Z and I assign it 45, this variable or this is an operator, this symbol, that's the equal to symbol. This is called an assignment operator. Now, if I want to assign a new value, I can just use the assignment operator and this works as well. So that's the assignment operator. Again, it needs two values, so it's a binary operator. And then we have addition and multiplication, which is something we have already taken a look at. Increment and decrement is also something that we have taken a look at. But one thing that we can also take a look at is a shorthand example. So if you are using a variable, let's say x, I will assign a value of 1 here. And what you want to do is you want to increment it by 10. Now x plus plus is only going to increment it by 1. But if you want to add 10 to it, then you have to assign it again. So you have to go, the current value of x should be whatever the value of x is plus 10. So I have 1, which will be substituted here, and plus 10, which is 11. That's one way, but it's a little cumbersome to write x again and again. Now let's say that the name, the value was user's age is 10. So I would have to type the user's age equals to user's age plus 10. It's a little annoying. So another way you can do it is something called a shorthand. You can just use plus equals 10. That says that whatever the value of user is, add 10 to it, and then assign it to user's age variable, and that now the user's age is 20. Had I just written user's age plus 10, I would get the new value, but inside the variable I will still have 20. So because I'm not assigned it, I just calculated it and threw away the variable's new value. So that's the shorthand operators. It works with all the operators that we have taken a look at so far, which is the multiplication, division, addition, subtraction, and modulus operators as well. So that works. Another thing is, if I were to do this, this will raise it to a power. This is called double multiplication. So if I have a value, let's say I have 2 raised to the power 10, it's 1024. So you can take a look at that as well. And this also works in the operators. So with that, now we can also take a look at comparison operators. Comparison operators are really important to understand because this will form the foundation of the next topic that we'll understand, which is conditionals. So let's say that I have a user's age. Let's say I've asked a user to provide their age. They say it's 15. Now I want my application to be used only by people who are above the age of 40. So I want to check something, which is whether the user's age is above the age of 40. Not 40, above the age of 40, which is 41 and anything above 41. So to do this, all I have to do is type in x is greater than 40. Since current age is 15, it's not equal to 40, I get false. This is a value that I can use later on. I'll show you how I will do that in conditionals, but right now you need to understand that this is what's telling us whether or not a particular statement is true or false. User's age is greater than 40, the compiler is telling us no, it's not. The user's age is 15 and it is less than 40. So we get the output as such. Now different kinds of comparisons are available, such as less than, which is this, greater than, which is this, equal to. So if I want to check if user's age is equal to 15, I can just use this. In JavaScript, there's triple equals also available. Since JavaScript is a dynamically typed language, if you want to compare 15 to be equal to 15, you will get true here. Because what JavaScript will try to do is it will either convert string to number or this number to string. and it will check whether or not those two values are the same. But if I use triple equal, that means strict equality. That basically says, okay, whatever the value is, it needs to be of the same data type and the same value as well. Don't juggle the types for me. Just tell me if it's the same. And here it's false. So that's another operator. So we have taken a look at less than, greater than, and equality operators. What about not equals? So I want anyone to be able to enter this application who is not the age of 44. For some reason, I don't want anyone to be of the age of 44 to enter this application. Right now, age is 15. It is not equal to 44. This exclamation point simply means that it's not. So that works. Now, the other operator that is available for us, apart from a equality and not equality, is something called greater than and equal to. So let's say I have the age to be 20. And I want to check if anyone who enters the application is of the age 20 or above. This is true. If I remove the equality symbol, that means that age is not greater than 20, it is equal to 20, so it's not going to be true. This checks both whether or not a person's age is greater than 20 and equal to 20. Similarly, if you want to take a look at less than and equal to 20, this will also work. It's equal to 20, but if it's not less than. And again, if you want to take a look at whether they are equals, that's true as well. So these are the comparison operators that we have available. Now we have logical operators as well. Now logical operators allow us to bunch together the different comparison operators. Let's say that I have the age of a person to be 18 and their monthly income, let's just variable age is 18 and income is equals to 15,000. Let's say I'm trying to create an application where person whose age is 18 and income is 15,000 are allowed to enter. So anything above that can be used. So how can I check two conditions? Basically, is the age equal to 18? That is true. Is the age equal to 15,000? Oh, sorry, not the age, it's the income. That's also true. But how do you check these two things right at the same time? So this is where the AND operator comes. So age is equal to 18 and income is equal to 15. This works. This basically means this statement is only true when both the conditions are true. So this is equal to 18 and this is equal to 15,000 as well. If both of them are true, then it's true. And you can also add other things as well, such as if the age is less than 19, which is going to be true because 18 is less than 19, so it's going to be true. But this is just to show you, and you can add more conditions like this as well. Now, what if you want to check only one of these conditions is true? So either the income is equal to, let's say, the age should be 20, but if the age is not 20, but the income is equal to 15,000, then they can enter. This is where you use the OR operator, which is these two pipe symbols, and that's where you can do that. Doesn't necessarily mean that that's the only way. You can mix and match these operators. You want to check two things and multiple things as well, you can do that here as well. But these are the basic comparison of basic logical operators that you can use. The last logical operator would be not. So if I want to check, okay, is age equal to 50, but I want to check if the age is not equal to 50. So I can just and age is not greater than 40. So if I want to just make sure that.
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
Whatever the answer of this is going to be, I want to just invert it. If it's true, make it false. If it's false, then make it true. Then use the not operator, which is the exclamation point, and this will work. This will flip the result on its head. So these are the three operators that are available for us there. Now we have the bitwise operator, which you can use. Bitwise operators are only useful when you're working with binary data. So let me just show you the binary data that you have. in order to check whether or not the binary data is going to be worthful for you. Binary data is useful because underneath the hood, it will always take a look at the binary representation of the data. We write the code, but it doesn't necessarily mean that the code that we are writing is going to be written in binary. So one way to think about it is this. Let's say that I have a number 5, right? Now that number, if I want to take a look at the binary representation of it, I can just write toString. It will convert it. This is the toString, and so this is basically something that will work if I just type it. Variable x is equals to 5, x dot toString 2, and this is the binary representation. The reason why we have to write 2 here is binary is something that needs 2 as its base. So the normal decimal number system that we use, which has numbers from 0 to 9 being used throughout, in binary you only have 1 and 0. So underneath the hood, your computer can only understand ones and zeros. So that's why binary numbers are so important in computer. Now let's say we have this, and we can perform different kinds of operations here. So x is 101 and 2 dot to string to y is equals to 2, and if you have y, you can take a look at 10. So we have 101 and we have 010. This 0 is just padded at the end so that these 3 variables come in line. So now if I want to perform some binary operation such as AND, or not, in case you're not familiar with this, don't worry about them. But if you're working with some low level techniques, then you can just use x and y. And then what you can do is you can just z equals to x and y. So it returns the value of 0. We check the binary representation of this as well, and we get 0. The reason why is because if you remember, we have 101 and 10. So what happens is it takes a look at the 101 and 010 numbers, and it takes a look at the adjacent pairs. So these are the two numbers that are right next to each other. So if they are both 1, then only the output will have 1 in that place. So 0 and 1 will return 0. 1 and 0 and 0 and 1 is also going to return 0. But in case I had done this, now I have 7. And if I want to check y, I can just switch z. If either of the number is 1, then we're going to get 1. And 111 in binary will convert to 7 in decimal. And there are many other operators available as well, such as 11, 2, shifting the numbers by 2 and something like that. So 11 by 1 is 22. And if I were to shift 11 to the left side by 1, it's also this. So that's the way binary operators work. There are many other binary operators available for you to use as well, but that's one of the ways you can do it. So these are all the operators available for us to use. In many programming languages, multiple operators are available for you to use. If you have already worked with any programming language, these operators may seem familiar. The binary operators are operators that you would not have to use unless you are working with some binary data and you want to manipulate it underneath the hood, which is quite rare. Other than that, you can use any of the operators that we have discussed. All right, let's see what else we can take a look at. All right, guys, now let's take a look at conditional statements. So conditionals or conditional statements are used to make decisions in a program. As we have taken a look into operators, and we determined how we can use conditional or logical operators in order to figure out if something is true or false. Based on these values, we can then define how we want our code to perform. So for instance, if we have some code, and in that code, what happens is you want to get the user's input and then determine whether or not a person's input, the input that the person gave, which is the person's age, is less than 18. If it is less than 18, then they cannot access your website. Let's say that it's a voting portal and above the age of 18 is the person that can vote in your country. So that's the threshold that you have determined. So that's the way it's supposed to happen. Now you can check using the operators that we have discussed, but how do you determine what code to run when a particular condition evaluates to true?
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which event can be fired on a scrollable document element? A. Window. B. Scroll. C. Load. D. Unload. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
This is where conditionals come into play. Now, in conditionals, we have multiple ways of dealing with things. We have if, we have else, we have switch statements, we have if else, nested else if statements, and there are many other kinds of operators that are many other kinds of conditional statements, which we'll take a look at. Also, we'll take a look at ternary statements. Now, ternary operator is an operator that we didn't really take a look into when we are discussing operators, but we did allude to it mainly because the ternary operator is a substitution for a simple if statement. So if you have an if statement that's really simple and don't want to write that much lines of code, you just want to write a single line of code that will explain it all. Ternary operators are really useful in that. It's called ternary operator because we have already discussed unary and binary operators. In a ternary operator, we have three operands. So in unary operator, we had one operand, which was the increment and decrement operator and the variable that whose value we were incrementing or decrementing. Then we had binary operators such as addition, multiplication, and division operators, and other operators as well, such as assignments and all. And now we have ternary operators. So these are the things that we'll discuss in the hands-on. So let's take a look at that next. Now let's take a look at loops. Loops are used to run multiple times until a specific condition is met. So let's say that you have some code that you want to run multiple times until a specific condition gets met. Let's say that you want to print the multiplication table of a number that the user enters. Now, for that, you could write 10 console.log statements, in each of which what you will do is you will increment the number from which you're multiplying that number from. So let's say the user enters 3. So you write 3 multiplied by 1 is equals to 3. 3 multiplied by 2 is equals to 6, and then you keep going on like that. That would be useful. However, since there's a lot of repetition of code and only the variable, only the counter is changing from 1 to 10, we want to automate this process. This is where loops come into play. Now, this is not the only place where you use it. In fact, loops are so fundamental and core to programming that they are used multiple times. So basically what we're doing here is we're saying, okay, we want to execute some bit of code. However, we want it to be executed for n number of times. This comes in handy when you have container objects such as arrays and objects, which we'll discuss after loops. But this is also helpful when you're trying to just go through something for n number of times. In cases like this, loops are really helpful. Loops are of three types: for, while, and do while. We'll cover all of those in the hands-on, which we'll take a look at. Alright guys, so now let's take a look at hands-on using loops. Again, the setup is going to be the same. We have some code. Let me just zoom out a little bit so that it's really easier for you to see. And I have the same code editor. Now let's write some code to make sure that we understand. Let's say that we are getting some number from the user. Let's say for num is equals to pass integer prompt and a number. Now I want to print the multiplication table of a number. Now multiple ways I can do that. One way would be to use this syntax. And now we can just do it again and again for 10 times. Let me just start from the beginning so that you can see. 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 9. So if I were to save this, it would work if I just named about console correctly. Now that that's done, I'll save it, go back, refresh, 5, press enter, and 5 multiplied by 3 is equals to 15. It's just a little, now it's going to be visible intact. I think there's an extra space between multiplication and equals to, so let me just correct that, save this, go back, refresh this, 5, enter, and now the code is correct. So 5 multiplied by 1 is 5, multiplied by 2 is 15. Oh, that's not correct. Again, as you can see, the mistakes that we are making even when we're manually trying to recreate some code. is 5, press enter, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so it's correct. Now the issue is that let's say that the person says, okay, I don't want it just to be there just till 10. I want it to be there till 20. So 5 multiplied by 11, 12, 13, 14, 15, 16, 17, 19, 20 till there. So now again we have to write the same code and we have to make the same changes. This is very tiresome. So in order to overcome this, if we take a look at the code, the only thing that is changing is this number, right? Here and here. So we can change that. And here where loops come into play. So for variable I is equal to 0, I will be the number that we will multiply it for. I is just a common variable name that we use for loops. I is equal to 0, I is less than, let's say, 10, but we want it to start from 1, less than equal to 10, and I plus plus. Now all I need is just one line of code. The rest all can be put aside. So number plus I, save this, go back, refresh, 5, enter. So 5 multiplied by 1, 2, 3, 4, and 8 works. So what just happened is, so this is the piece of code that's different. So let us explain this one by one. So it has 3 parts. The initialization phase, in which we initialize a variable with the initial value. Here we have initialized a variable named I with 1. The condition phase, where we check if the condition is true. If this condition ever evaluates to false, that means we have met the condition we wanted to meet and we want to quit the loop. And this is the change phase in which we increment. So the way it works is our JavaScript interpreter takes a look at the loop, creates a variable, assigns value 1, then checks if 1 is less than or equal to 10. This condition evaluates to true, so this code gets executed, and then we increment 1, so it becomes 2. So we check again, if 2 less than or equal to 10, it is, go back, put number plus, and we create the string where number multiplied by 2, which is the current value of I, is equals to number multiplied by 2. Then we increment, it's 3, and the same way we keep going till we reach 10. We check if number is less than or equal to 10. 10 is equal to 10, not less than. So we execute the code. Incremented by 1, it's 11, and now this condition evaluates to false. So we just come out of the loop. Nothing left to execute, so we just end our code. So that's the way for loops work. For loops are the oldest loops. They are used in many programming languages. Any programming language that you wish to use, you can use. Now, if I were to show you the same problem that we had earlier, let's say that the person says, I want the program to show me the multiplication table till 20. Run this, and it's showing till 20. You can even go further to 30, 40, 50, whatever you want. But now it's just a number changer. So as you can see, it allows us to not repeat ourselves, allows us to not errors, and allows us to write code that doesn't contain any error because most of it is automated by the computer. So that's just one kind of loop. There are many kinds of loop available, and we'll take a look at them one by one. Now, instead of getting the input from the user because it's a little tiresome and a little difficult, I'll just assign it right now. Fine. So this is one kind of loop. Let me just comment it out so that it stays here, but it doesn't get executed. So this is none. Now I'll show you while loop. So this is what it looks like, but here some things are going to be different. So the initialization phase, I is equals to 0, I is less than equal to 10. Then we are going to use the same thing that we had written earlier, and I plus plus. So as you can see, we have the same 3 bits, but their position has changed. Earlier we had them all written in the same place. Here we have I, which is the index variable, and it is at the top. We can declare it anywhere we want. It doesn't necessarily have to be here. Similarly, if we had declared it earlier some places, we can just drop the var keyword and it will work just fine. Now we have I equals to 0. Now we check if the number is less than equal to 10. As long as this condition is evaluating to true, we will continue printing whatever it is inside the code, and we will check again. So we check it, we print, we increment, check, print, increment, check, print, increment, check, and we keep doing it again and again. If I go back, refresh, I get the same thing. However, this time it's starting from 0, and that is because I had my variable set to 0 where it should have been set to 1. Although 0 works, but still it's the way it works. And now we have that. So this was a while loop, and this works as well. Again, let me comment it out so that you can see. And now let me just show you the do while loop. This is what it looks like. So we just need a condition here, and it's going to work exactly the same. variable is equals to this. This is the code that we want to execute, and the while loop is going to be just if the I is less than or equal to 10. And finally, we have to increment it as well. Again, this is going to work exactly the same. So I go back to fresh, it works. But there's a bit of an issue here, or not an issue, but the difference between while loop and do while loop is not just semantics, because they look exactly the same. But what happens here is, let me just remove this. Yeah. So now it's going to print it, then going to print it again. What happens is, if I were to change this variable to be 11, and if I were to change this variable to be 11 as well, what happens is, if I go back and refresh, 5 multiplied by 11 is equals to 55. So what's going on here is, in the do while loop, we have the variable set to be 11. We print whatever we wanted to print, then we increment the value by 1, and then we check the condition. In the while loop, we check the condition and then we print something. So that's the whole difference. It's called the entry controlled versus exit controlled loops. In entry controlled loops, before the loop starts, we take a look at the condition. If it evaluates to false, nothing gets executed. In exit controlled loops, at least once the code gets executed, but if the condition evaluates to true after the execution of the code, then we get this. Even then, we will still print something. So for instance, if this code is printed, that means that this condition, even if it didn't evaluate to true, we will still print it once. Then it increments, so 11 becomes 12, and we check if 12 less than or equal to 10. It's not, it is not equal to or less than 10, it is greater than 10, so the loop exits. So that's loops in a nutshell. That's how loops work in JavaScript and in many other languages. These are the 3 kinds of loops. There are other kinds of loops as well, which we'll discuss once we are done with arrays and objects, because those kinds of loops are used there. So we'll take a look at that in the arrays section. So let's take a look at the arrays now. Arrays. So an array is a container type. A container type is used to store variables or values of different types. So arrays are used to store multiple data points or multiple fragments of data in a single variable. To give you an example, let's say that you want to store the marks of a particular student and you want to store all the marks in one variable. If you were trying to store the marks of a person in English, Hindi, Maths, Science, Geography, these 5 subjects, you can create variables with these names and you can store the data inside them. However, if you want to store them all inside a single variable, then you can use arrays. Arrays have 2 parts to them, indexes and values. Indexes are the, you can think of them as roll numbers. So they start from 0, and then there's the marks of the student. So whatever you insert at the beginning will go at the 0th index, then the first index, then the second index. In JavaScript, arrays are dynamically sized. So you don't have to worry about running out of space, or you don't have to worry about declaring an array of a fixed size, because they size dynamically. So you can store as much information as you want. In other languages such as C++ and Java, you would have to declare an array of a specific size and then use that array only. You can't use multiple arrays. So that's the difference between the arrays in JavaScript and other languages. Also, in strongly typed languages such as C++, Java, you would have an array that can only store value of one type. So if you want to store integer values, you can only store integer values. Only store string values or other kinds of values. On the other hand, here we can store values of multiple types in an array. So we can store a variable that is of type integer, then string, then boolean, then again integer, then again boolean, then again integer, and many different kinds of data in any format that we want, as long as it's supported by the language, they can be stored inside an array. In fact, we can store an array inside another array, and that also works. So that's how this works. Let's take a look at a hands-on and figure out how arrays can be used in JavaScript. So again, to follow along, just as we had done earlier, just need to have an index.html page, open up the console, and open up the code file. So here's what we have. We have used the useString. Now we'll take a look at multiple operations that we can perform on arrays. But first thing we have to understand is how you can create an array. To create an array, it's quite simple. I'll use the var keyword. I want a new array. So I want an array of the marks of a student. I'll call it marks, and I'll assign it to this. This is an empty bracket. I save it, go back, refresh. Now if I take a look at marks, it's an empty array. Also, there's an array constructor as well. So if I just use the new array function, this will return the same thing as well. But we don't need to get ahead of ourselves. This is how we can create an array. Now, creating an array is quite easy. You can just create an array, but how do you initialize it? So this is an empty array. If I want to add some values to it, let's say that the student has 88, 56, 55, 44, 55. These are the 4 marks. Go back, refresh marks, and these are the 4 marks. If I expand this here, we'll take a look at these. This is the index, which is corresponding to the variable. Since this was the variable I inserted at the beginning, or this is the data that I inserted at the beginning, it got the number 0 associated to it. Similarly, 1 was associated to 66, 2 was associated to 44, and 3 was associated to 55. And I have a property length, which tells us the length of the entire array. So basically, if I were to take a look at marks.length, it will show me the number of elements inside an array. That's one way. If I want to access certain values, let's say I want to access the value at the beginning, there you go. So I can just use this 0, 1, 2, 3 to get the values. So 1 would give me 66, 2 would give me 44, and 3 would give me 55. Now what about 4? Well, it will give me undefined, mainly because these indexes don't exist, so they are not available for us to use. So if I go back, this is what it looks like. Now, as we know that we use indexes, and indexes are sequential, so 0, 1, 2, 3. They are assigned on the basis of arrival of the data. Now, if I want to go over these and print all of those one by one, what I can do is I can use a loop for variable I is equal to 0, I is less than, and here's where the marks come into play. Marks.length and I plus plus. So it will go from 0, 1, 2, 3. As soon as I becomes 4, it will exit out of the loop. So we'll only get 0, 1, 2, and 3, which are the valid indexes. And I want to print marks of I. Save this, go back, refresh, and here you get the numbers. Now, this is where a simple for loop works. But another thing we can do is, instead of using this, because it is a lot of values, what I can do is for variable x in marks, and if I print x, go back, refresh, here's where you get 0, 1, 2, and 3. So you get the indexes, and you can do it there as well. And there's a for off loop available as well that you can take a look at. You refresh, and here you get values. So if you want to take a look at the indexes, you can just go for x in, and it will get you that. If you were to go for off, this is how it would work. So this is how these variables work. In other languages, you would have to do something like this, especially in Java, but here it doesn't work like that. So that's the way you can loop over an entire array. But how about you have an empty array and you want to enter some values into it? The easiest way here is, if I go back to my code, I'll just show it to you here. Let's say ARR is equal to a new array. Now if I want to add new data into it, all I have to do is ARR, this is empty right now, dot push. Push is allowing me to insert some values. The F here means I have to put these brackets here. This means it's a function. Don't worry if you don't understand functions right now. I'll explain it to you in a moment. But let's say that I want to enter some item. If I want to enter just one number, I can just enter 15, press enter, and now ARR has 15 values. But if I want to enter more numbers, 16, 17, 18, all of these will be inserted as well. And there you go. It returns the length of the array. So whenever we insert something, it will get back the length. So since we inserted 3 values after 1, we get 4, and this is what's returned. So we have these 4 values. Now that is done. But let's say I want to remove the element. I can just pop, and this will remove things at the end. Now instead of getting 15, 16, 17, 18, I get 15, 16, 17. If you pass in a number in pop, it will remove, it won't make much of a difference. It will still remove the same thing. Similarly, it won't throw an error basically, and you have one value. If I were to pop again and then again, since last value was removed, nothing is here, so you can't have anything. As we discussed, arrays can have values of multiple types. So let's say it's a string 0 true. ARR is equals to this. Now, if I want to find the value, I can find the last index of true. So true was found at the second index. This is easy for me to find things. If I want to find some string but it doesn't exist, it will return me an index of -1. So that's how it works in arrays. Arrays are really complicated in JavaScript. You can have a lot of functions. A few functions that I'd like to show you that are very important. Let's say that I have numbers. This is an array that has 1, 2, 3, 4, and 5. Now suppose I want to create a new array out of this array, and what I want is all of these numbers squared. So 1 multiplied by 1, 2 multiplied by 2, 3 multiplied by 3, 4 multiplied by 4, and 5 multiplied by 5. Simple logic that we have learned so far is use for loops. Go over each value for var x of, and inside it we pass in nums. Let me just show you in the code. So I'll just copy here, paste it here, then var result is equals to an empty array for var x of nums. We get x and result dot push x multiplied by x. Now if I console log the result, save it, go back, refresh, this is what we get. So we get 1, 4, 9, 16, and 16 and 25. This is exactly what we want. Now this works, but as you can see, again, you have to write so much code to get something really simple done. In other way, if you want to do it, I can show it to you right now. Result is going to be equal to, and I take nums, and I'm going to call a method on it called map. This function, it will take another function, and I'll display and show you what that means, but this is called functional programming. We'll discuss more about this when we are discussing functions, but right now just take a look at what happens. I'll just return x multiplied by x, and this is done. I save, go back, refresh, and I get the same output. So as you can see, multiple ways of doing the same thing in JavaScript. Some are more concise, however, it takes a little bit of time to get around those. Some are really easy to use. So we have understood how to declare an array, how to add elements to an array, remove an element from an array, access elements from an array, and loop over the array. These are the basic functionalities. If you want to take a look at the functions available for arrays, just type in nums dot, and you can take a look at all the different kinds of values that are available for you to use. Shift, unshift, slice, reverse, reduce, and many other kinds of functions such as index of and last index of. The difference between the two is that index of will give you the first index that it finds of a number. So let me just display that for a moment. Let's say that array is equal to 1, 1, 2, 2. I want to find the index of 1, I get 0. But if I were to find the last index of, this will give me 1. So if you take a look at this, first time I encounter 1 is at the 0th index, and the last time I do it, it's at 1. If I were to change this variable here and add 1 at the end, now if I were to use index, the value is still the same. But if I were to use the last index of 1, I get 5. So this is the difference between the two. Let's take a look at objects. So objects are the fundamental type in JavaScript. Objects are really important in JavaScript because most of the things that we work with are essentially objects. Objects are container types. Basically, they contain other kinds of data. Objects can contain objects arrays and any kind of data that they want. Similar to arrays, they are also heterogeneous, meaning that they don't need to contain only one kind of data. They can contain different kinds of data. The only difference between arrays and objects is that in basic uses is that objects will use key value pairs. Now, key value pairs are really easy to understand. Basically, just like in arrays, we have numeric indexes that are automatically assigned as you add and remove elements. So as soon you create an empty array, there's no elements in it. You add new item to it, it gets the index 0 assigned to it. Then you add another item, index 1 is assigned. Then you add another item, index 2 is assigned. When that element is removed, index 1 is the highest value of for indexes there. And then when you add another item, index 2 is assigned again. So as you can see, it's sequential, increases and decreases based on the length of the array. Now the difference here is that in objects, you can, instead of assigning 0, 1 and 2, it's up to you what you assign to the values. So basically, if you are trying to create a table like structure in which the name of the person is supposed to be the key and the value is going to be their salary, you can do so. Just put their name as the key, salary as the value, and keep doing it for all of those, and it is an object. Objects are also fundamental in JavaScript because they are very synonymous to other kinds of objects, such as if you've ever worked with say object-oriented programming in other languages, and object-oriented programming is something that we'll discuss. But in object-oriented programming, you have classes and objects. Those are slightly different from what we're covering right now. So don't worry if you don't understand them right away. Basic idea behind this is that objects are containers that can contain key value pairs. They are more similar to hash tables or hash maps than they are, or dictionaries if you are in Python. But they are more similar to those than they are to classes and objects in the traditional sense of object-oriented programming. In case you don't know object-oriented programming and hashes and all of that, don't worry about it. We'll take a look at a hands-on in which we'll understand what this actually means. However, if you are familiar with these topics, then you have a nice ground level understanding of what this is. How to use it, however, is something that we'll cover on a hands-on. Alright guys, now let's take a look at a hands-on involving objects. So for this, firstly, you need a web browser opened. You can open it up in any web browser that you want, as long as it has a JavaScript console. To get into the console, just press Ctrl+Shift+I and then click on console. Expand this a little, and yeah, now it looks. So the way you can create an object is very similar to the way you could create an array. So for arrays, you needed to use either this shorthand, which were two brackets, open and close, or you can create new array, right? And that would also create an object. Now to create an object, however, it's quite easy to do. All you have to do is either just create a new object, which is exactly the same, or if you take a look at the symbols below, you can do this as well, and you have an object here as well. So let me just show you. If you take a look at type of, it's an object. Also, if you take a look at the type of array, it's an object as well. As I said, object is the fundamental type. Every thing that's not a simple primitive type, such as boolean, string, and all of that, that's an object. So you take a look at that. This is a string, but this is an object. So arrays are also kind of an object. So now, if I want to create an object, I can just assign obj is equals to, and here we have it. So if I create obj now, it's an object. Again, if I wanted to do it the other way, all I had to do was create a new object, and this works as well. It's exactly the same thing, as you can see. Now the object is created. Now it comes time to add things to an object. Now, as I said, objects are key value pairs, right? So one way you could have done this is, if you want to create an object here, you can just add things right here. So let's say that I want to create an object in which the key, I'm trying to store the name and address of a person, or let's say name and salary of a person. So all I have to do is type in name, and the name is supposed to be whatever I want it to be. Let's say John. Then let's say salary, 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 and let's say the salary is going to be 50,000. As you can see, that name is string, salary is not string, it's number. So you can do it this way as well if you want to. It doesn't really matter what kind of value you have for the values. Also, if I wanted to remove these, I can do so as well. JavaScript will automatically convert them into strings, so I have this. It doesn't really matter if I want string or not. I can also have numbers mapping to numbers as well. So let's say 2, 4. This works as well. Now if I create an object, I can take a look at the object in the console. This is what it looks like. 2 will map to 4, name will map to John, and salary will map to 5,000. In a similar fashion of array, I can also access these things by indexing into it. So if I type 2, you have 4. That's not the only way you can access things though. If you want to access the name, I can first type object.to. This will give me an unexpected error because 2 is a number. But if I access it using the array syntax, it will work. However, if I were to access obj.name, this will give me John. If I were to access obj.salary, this will give me the salary of a person. So this is how you can get the information from the objects. So this is how you can create an object and add data to it right at the same time. But how about if you want to create an object on its own and then add data later on as the user adds it? So again, you can just create an object which is an empty object, and now if I want to add anything, the same thing I would do anywhere. I would just type in obj, and now I can do it in the same syntax that I had done earlier. So I can type in name to be equal to John. Now if I take a look at obj, this is what it looks like. Also, if I want, I can type in name dot salary, salary is equal to 50,000. And now if I take a look at obj, this is what it looks like. So this is how you can add data to an object. This is how you can create an object, how you can initialize an object, add data to an object. Now let's take a look at how you can remove data from an object.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which of the following is not considered as an error in JavaScript? A. Syntax error. B. Missing of semicolons. C. Division of 0. D. Missing of brackets. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
If I take a look at this, it looks like this. If I were to take a look at name, and now if I delete it and then take a look at obj, it only has salary. So this is how you can delete it. Use the delete keyword in front of the object and the key name that you want to delete it, and it will delete everything. Now you have just one property or one key, salary, and one value. This is 50,000. These are the keys, these are the values. So this is how that works. Again, if you want to loop over an object, you can do so as well. Let me just again, yeah. So now we have obj and we have name and salary. Another thing to notice is that it doesn't really matter how you add things into the object. If I add name first and salary first, it doesn't really matter. It's really fast for lookup. Also, if I try to access an element that's not inside the object, let's say not found, it will return undefined. So just be sure to use this. So if I want to check whether or some key exists inside the object, the quickest way to do it is check if it's equal to undefined. So this is going to be equal to undefined. Name is not going to be equal to undefined because we have name equal to John. Now if I want to loop over the objects and print everything inside it, all I have to do is use a for loop. For variable key in object console.log key plus, and this is string concatenation, and you press enter and everything is working exactly the way it should be. So the salary mapping to the value, name mapping to this value, and this works easily. So this is how you can write code and have it be executed. Now again, another thing I'd like to show you, which I hope I have shown you by now. If I were to remove these curly braces, what do you think will happen? It will still print it. So the difference between the two is, let me just show you. So this is what it should look like without the curly braces, right? If I were to add another line right after this and say next property. So if I press enter, as you can see, first the loop executes this, and then next property. However, I want both of these statements to be executed in the loop. Now for that, I have to open up a curly brace and then close the curly brace. And now if I do this, this is what happens. So what's going on here is if I remove the curly braces, only the first statement gets executed in the loop's body. If I keep the curly braces, then everything inside the curly brace is included in the loop's body. So for instance, if I were to add new code lines to it, they will also get executed. So this is a good trick to remember. So if you have an if statement where you only have one thing to do. So let's say that 1 is equal to 1, then I want to print console.log true and press enter. So it will work. However, if you have multiple statements, then you don't use curly braces. Depends on the code style that you prefer as well. I would recommend that you use curly braces whenever you can, but however, if you take a look at code like this, don't think that it's invalid. It's perfectly valid. So now we have looped over the elements, we have taken a look at everything. Another thing that I can show you is the object function. So functions are not something that we have discussed thus far. We'll discuss them in a moment. But the object is in JavaScript an object itself. So you can take a look at a lot of things that these things have for us. These are the properties and these are the functions that we can use on objects to understand how to use them. You don't have to worry about them right now. This is just to show you that JavaScript has a really great inbuilt support for objects. If you ever want to use object, you want to perform some task with an object, first take a look at the JavaScript documentation on Mozilla Developer Network to see if it's not already developed. If that feature or that function is not already there, then you can implement it on your own. Alright guys, now let's take a look at functions. So functions, as we have already discussed, a function is a named block of code which is used to wrap a few statements that should be executed one after the other and given a name. Think of bits of code that is really important to you. Any bits of code that come one after the other. So for instance, let's say that you want to connect to a database. That needs certain steps to be followed. You need to create the URL, you need to send a connection request, and then you need to handle whether or not the connection is successful or not. This is going to happen every time. These bits of code are going to be executed with each other. This is why we need a named block of code so that we can call it whenever we want to. This is a function. Another thing you can think about is how you can write data to a file. To write data to a file, you need to first open a file. After opening the file, you need to write the data into the file. Then you need to save the file, which is basically closing the file. So these three steps need to be executed one after the other all the time. So this is where functions come into play. You can create a function, call it write data to file, and that will do the same task for you again and again, so that you don't have to do it manually over and over again. This is what functions actually do. Now, when we come to actually understanding what functions are and how to use them, there are several intricacies that we need to be familiarizing ourselves with. Function names, declaration, calling a function, first class functions, which is a special concept in JavaScript, which will take a look at function arguments and returns. So we'll take a look at all of that as we move on to our hands-on. So let's do that now. So again, we would want to have the same setup that we did earlier. Create an index.html, open up the console, open the index.html inside a code editor. I'll be using Visual Studio Code. You can use any code editor you wish to use. And here I have used the use strict declaration so that JavaScript's interpreter doesn't allow for any small mistakes. This will keep our code clean and easier to use. Now, when we're talking about functions, let me just show you what a function is. Suppose I want you to create I want you to greet someone, right? So for instance, to greet someone, firstly, what you need is you need to console log hi, then you need to print hope you are well, and third one would be nice to meet you. Now suppose this is something that you need to use in multiple places in your code. So for instance, this is one thing. Now you want to, let's say your code is spread across multiple files, and now you want to use it in this file as well. This is a separate file. Let me just comment that out. file2.js. This is going to be the file name, and this is file1.js. So this is how it works. Now both of these files will be included and they will get executed. That will work. So if I go back, refresh, and this will be printed 2 times, which is good. Now what happens is someone comes along, takes a look at our code and says, this is fine, but after nice to meet you, put a full stop, just to make it grammatically correct. So after everything, put a full stop. I save this, I go back and I refresh. Now, as you can see that if the person did know that this code was also written by the same person in some other place, if they forget, basically if this code was written this change was made 2 or 3 months after someone had written it and someone else is making the change, they have no way of knowing whether or not the changes are there. So what happens is this code and this code are now out of sync.
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
Nobody knows that this code is also doing exactly the same thing, but this code was doing the same thing and had some changes applied to it, which this code didn't. So again, that's a bug in your system. So how do you come about doing this? Well, the way you do it is, again, the simple way in programming is that you do not repeat things. So let me just close this out, right? And now I can create a function for this. Function will allow me to give a name to this entire block of code, and that name is going to be referenced in other places. Any change I make to this function's definition is going to be changed in other places as well. To create a function is quite simple. Use the function keyword, function, function. Give the function a name. I'll call it greeting. Then use these. These are called parentheses. I'll show you what they are and why they're useful in a moment. And then we define the function body the same way that we had defined the bodies of loops and if statements. And this is where we are. Now, this is the function that we want to use. Let's say that this is in its own file right after use strict. And now if I want to call this, I'll just call greeting here. And I'll call greeting here. Whenever I want to call a function, that basically means, okay, this is a function. Execute the code inside it. These parentheses are going to take a look at the function and execute everything inside it. So whenever you put a parenthesis after it, it basically means that this is a function and I want to execute it. I want to run everything that is inside the body of this function. So I save this, I go back, refresh, we get the same result. But now if I were to make a change that I had earlier done here, here, and here, save this, go back, refresh again. As you can see, the changes are reflected in both places. And this is a trivial example. It's in both places. In real world scenarios, this can be referenced in multiple places. So that's the difference we're trying to avoid. So that's one way. This is how you can create a function. This is called declaring a function or creating a function. Declaration. And this is what's called using a function or calling a function. Call. Now that these two things are done, let's just return and see what else we can do. Suppose you want to perform some complicated mathematical operations, right? Let's say that you want to, I'll just call it calculate, right? A person enters a number to your program, and what you want to do is you want to take that number and square it, then add 2 to it, and then divide it by 2. So for instance, you take, let's say the number is 10, right? So you want to firstly square it, which is basically, you can either do it this way or multiply the number by itself. So number is equals to number multiplied by number. That's the first thing. Then you want to add 2 to it. So number is plus equals 2. And finally, number should be divided by 2. You can either do it number divided by 2, or the same way that we had done with the addition, you can do it this way. So that works. Now, thing is, this will only work with 10. So if I call this function, this will work with 10, calculate everything, but it won't do anything with it. Refresh, nothing happens. So what goes on at the end is that it creates a number in memory, performs these calculations, and then forgets about it because we're not printing it, we're not doing anything about it. So the way to deal with this is, firstly, we want to accept some input into our function. Now, either you can just call a prompt and say, okay, give me the user input. But this creates a problem that whenever you are using the prompt function, you're tying yourself to the browser because, let me just look. Because prompt is only a function that is available in the browser. What if the user was to send the request via an HTTP request, and you are writing this code on a web browser? Instead of writing it here, you're writing it in a web server. That becomes a problem. So I just want access to a number. I don't care how I get it. So this is where parameters come into play. So I want a number, I put it here. So now whatever number user enters, I'm just going to square it, add 2 to it, divide it, and now I want to return the result. This is also quite easy. Returning a result basically means whatever I have calculated, give the result back to the user who called the function. Now I'll call number, save it, and now if I were to console log, and this will take a number. So if I enter 10, so go back, refresh, and this is the output. Let's check. 10 multiplied by 10 will be 100. 100 plus 2 is equals to 102, and 102 divided by 2 is equals to 51. So this is exactly what's happening. Now, it doesn't necessarily matter that I only need to have two parameters. I can have multiple parameters as well. So instead of number, I can also say value. And now, instead of 2, it could be 3, it could be 4, it could be anything, depending on your use cases. So I can here pass in 2, save this, go back, refresh, and it's the same thing. But if I want to make changes, I can just go 11 and save this, go back, refresh, and this is what you get. So as you can see that this works really well. Now, what is a function? It is basically a name given to a block of code. It can accept some parameters, perform some operation on it, and can return the output. These two things are optional. The function body, if it's not there, then it's basically just an empty thing. It's not doing anything. It's just a name for no code at all. So you can do that as well. Another thing that you might want to consider is that functions are first-class citizens in JavaScript. This is quite similar to other kinds of languages. However, most languages don't implement these kinds of things. So what that basically means is that instead of using functions as a high-level concept, it can basically be assigned to a variable. So let me give an example. Let's say I want to create first action is going to be, I can create a function without giving it a name. It accepts some value and returns that value multiplied by itself. That's it. And put a semicolon at it. Right? So this is the first action. Second action is going to be, it takes in a value and returns the value multiplied by 2. So now if I want to create a function, let's say I want function calculate. This will accept some actions and it will accept a value. So now what I want is for, and I can just go over each of the actions. So I just go for variable I is equals to 0, I is less than actions dot length I plus plus. Now all I need is to go to the actions, extract that function, pass in the value that was passed in, and I can just create a result. Result is going to be an array that will be passed in, and I'll show you what that means. Result dot push. Now I just have to return the result. So what's going to happen here is this. Now I'll call the calculate function, pass in the actions, which is going to be an array of first and second, and finally I pass in 2. If I go to console.log this, save this, go back, refresh, as you can see, this is what the output is, 4 and 4. Now again, if I were to change the number, let's say it's 4, so I should get 16 and 8, and this is what I'm getting. This is the output. Now what's happening is, since I can assign functions to variables, I have created 2 operations on my own. Now what I want is the calculate function to accept a number of operations and a number itself, and perform these operations and return the result respectively. So it creates a result array, goes through all the actions, which is basically me trying to square and double it. I can also change the name here. SQ square and double. These are going to be the 2 operations I want to be performed on this number. So I send it to the calculate function. It extracts each of the functions, performs the actions, put the result into the action array, and returns it back. So that's what it means. Now there's another thing that you can take a look at, which is early returns. And this is really where the entire functional calls shine up. So let's say that I get an age. Earlier, what we would have to do is I wanted to check if age is greater than 18, greater than or equal to 18. Then I would have to create another if statement inside it and do the same thing. Here I can do something else. So I can just check if age is less than 18 or income, which is something I need to accept as a parameter. Income is less than 50,000. Then I'll just use the word return. This basically means that, okay, if this is true, if either age is less than 18 or income is less than 50,000, then just return from the function. Don't perform any of the steps that I'm mentioning here. Other than you can just write valid. That's it. So that's what you can do. Now your code is much simpler to read. It's easier to understand. Basically what it's doing is, if this is an invalid input, don't do anything, just return. Don't perform any function. So if I were to go console.log, oh, I don't have to console.log as well. I just have to use the calculate function. Pass in the age. Let's say it's 18 and income is 50,000. Save this. Go back, refresh, it prints valid. Now if either one of those turn out to be true or and other one turns out to be false, it's not going to do anything. It's just going to move on. So this is how you can write code. So this is how functions work. We have taken a look at how to declare a function, how to call a function, how to compose functional callbacks, how you can do all of these things. One other thing that I'd like to show you that I didn't show you when arrays were being used is something called map, filter, and reduce. These are the three functions that are the most important ones in JavaScript when you're using arrays. Suppose you want to use an array. Let's say that I create an array of numbers, right? And I get numbers 1, 2, 3, 4, 5. Now I want to create a new array squared, which will be these numbers squared. So the way to do this would be, in normal terms, I would have to create an array, then I would have to write a for loop in which I'll perform these things. Here, what I can do is just type in the word numbers, and I used a function called map. Map is a function that takes in another function, just as the one we had created when we were creating squared and double functions. This function takes in a number, single number, not all the numbers. And now I want to perform my action and return the output. So I will return the number multiplied by itself. Now if I were to console log squared, this is what I will get. 1, 4, 9, 16, 25. So this is what we are getting. So what's happening is the numbers.map function is going to take this array, and what it's going to do is, in this function, it's going to pass each of these values one by one. So for instance, this, let's say this function is called, this is the function that is called. The first thing they will pass in 1, then it will pass in 2, 3, 4, and 5. And these values, when they are called, they will return. 1 will return 1, 2 will return 4, 3 will return 9, 4 will return 16, and 5 will return 25. So this is how mapping works. Basically, I want to create a new array out of a previous array. This is why functions are so important in JavaScript, and this is why they're called first-class citizens, because you can pass them around in other functions and nest them and do whatever you wish to do with them. This is why functions can be a little challenging when you're trying to work with them. So this was map. This is also part of functional programming. If I forget to return it, then I'm going to get this, which is undefined, because I forgot to return it. So what happens is, I take the number, make the calculation, but I don't return the result that I want to be included in the resulted array. So if I return it, only then would it work. Now you might be wondering, okay, this is a lot of code to write just to perform this task, right? And this is true, but when we move on to ES6 and its features, we'll understand how to overcome this as well. Now this is called mapping. If I wanted to filter it, let's say filtering would be something that we take a look at when we are trying to reduce the number of members. So for instance, if I want to only include even numbers, so I have 1, 2, 3, 4, 5, and I want to only return values. I want to only include values inside this array if the numbers are valid. So I want to check if the number mod 2 is equal to 0. Basically, if I divide this number by 2, if it doesn't leave any remainder, which is basically the definition of an even number, include that number in even. So 1 goes in, 1 mod 2 is 1, so it doesn't get included. 2 mod 2 is 0, this gets included. This doesn't, this does, and this doesn't. So now if I take a look at even, save it, go back, refresh, 2 and 4 are the numbers. So this is how filter works. So these are the kind of things that you would have to do and understand how to perform when you're trying to build a JavaScript application. We'll make heavy use of this when we're trying to build some other kind of application, but it's important to understand what it actually is. Finally, we can have a reduce function as well. Reduce function basically takes in initial and accumulated and return I plus accumulated and print, save it, go back, refresh, and you get 15. So what it does is that it passes in, let me just pass in 0 here as well. Now I refresh this. Yeah. So what it's trying to do is it is taking this array, passing it these values. So it's passing in 0 and 1. So 0 plus 1 will equal 1. Next it will pass 1 and 2. 1 and 2 will equal 3. Next it will pass 3 plus 3 and 3. So 3 plus 3 will equal 6. Then it will pass in 6 plus 6 and 4, which will return 10. And finally it will pass in 10 and 5, which will return 15. Yeah, so this is what it's doing. Basically, we pass in the 0 as the initial value, and we're saying, okay, for each of the numbers, pass them here and create the next result out of those. So if we try to reduce the entire array into 1 by performing some function, this is how we do it. So that's basically it for the functions. Some of the important functions I have already mentioned. There are many functions available on many objects that you can take a look at. Too much for me to cover. I covered these functions that are map, filter, and reduce because these are the most important functions when it comes to writing JavaScript. They greatly simplify your code, and we'll learn in future videos how we can even specify better functional parameters to make it work even better. So let's take a look at what else we can learn. Alright, so now let's take a look at object-oriented programming in JavaScript. Object-oriented programming is a programming paradigm based on the cohesive units of code called objects and the descriptions that are called classes. So a class is basically a blueprint in which we describe the kind of data we want, the kind of functions we want, and what the class's name is what the entity is supposed to be. So to give you an example, if you're trying to build a painting application in which you want the user to be able to draw shapes, the kind of objects that you would have there would be circles, squares, rectangles. The kind of properties that they would have would be the length, width, radius, depending on the kind of shape you're having. And then the kind of functions that it will have would be draw, fill, and things like that. So these are the kinds of functions and data that we're trying to use. Now, why is object-oriented programming important? Object-oriented programming is basically a programming paradigm. It's a way to write code. Other paradigms include functional programming and procedural programming or imperative programming. This is exactly what we've been doing. Procedural or imperative programming basically means you write one code statement after the other and let that execute itself. On the other hand, in object-oriented programming, instead of code being just one statement after the other, we create small groups of code called objects. These objects are belonging to a specific entity and map onto that entity into the real world. So if you're trying to create a employee management system, one of the objects that you will create, one of the classes you will create is employee, then you can create managers and many kinds of things. Now, object-oriented programming is a really complicated topic. It can warrant an entire video on its own. Do mention in the comments if you would like for us to cover object-oriented programming in more detail, and we'll get onto it if you guys want that. On the other hand, here we have the object-oriented programming paradigm for us. JavaScript supports object-oriented programming, functional programming, and imperative programming, all the same. But the way JavaScript supports, or the way that it has historically supported object-oriented programming, is a little different than the way other languages have. So other languages have keywords such as class, which you can use to define the classes. You have constructors and many other kinds of things.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which event can be fired on a scrollable document element? A. Window. B. Scroll. C. Load. D. Unload. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
In object-oriented programming, it's a little different. And in the hands-on, we'll see how it's different and how it works. So let's take a look at that now. So we'll try and create classes and objects. For this, I'll use the text editor. Again, the setup is the same. We just have removed some previous bits of code and brought it to its original state. Now, to use classes, you don't really in JavaScript, you don't really create the word class there. We'll use the function keyword. That keyword will create a new class. Let's say I call it person. Okay, this person accepts two things: the name and age. Now I want this dot name to be equal to name, and I'll explain what this means in a moment. And this dot age equals to age. This is done. Now what I can do now is also, if I want to do something else, is I can just create a function. This dot say name is equals to a function which will console log the name. So you can do it this way, or another way of doing it would be to go here, use the person keyword, person.prototype.say name is going to be equal to a function, and you're going to print the name. Similarly, if you wanted to create an age, let me just do it here. This dot say age function, and type in console.log this dot age. Here it's the same. Instead of using name, I'll use this dot name. So what does the keyword this mean in this scenario? We'll take a look at that in a moment. Now I'll create a person. Let's say John is equals to, and now create a new object using new person. It's the same thing that we have been doing thus far with the new array or new object constructor functions. And I'll pass in the name to be John and the age to be 35. Then I'll use John dot, and here I can use it to say its name or say its age. I can call say age function and then say name. Save this, go back to the code, create, open up and here you have it. So it prints the name, it prints the age. Now again, you can do it either way. Unfortunately, whatever way you prefer is the way that you should use it. I like doing it this way because it separates my my data with my functions or my methods. Method is basically a function that is tagged into a class. So what is going on? This is a constructor function. Constructor function. This is the prototype function or the method that we are assigning. So methods. So what happens is prototype is a property that the class takes a look at. So whenever we create an object, the first thing that happens is it takes a look at all the method names that we're calling. So we say, okay, I'm calling say age. The object will take a look at itself. Do I have a function named say age? No. Then it takes a look at its prototype. Does my prototype have a say age function? If it does, then I'll call that. If not, then I'll throw it. So that's how this works. So these are the two things. Again, it's a little difficult to wrap your head around at first, but it works. Now let's come back to the keyword this. This, what does this mean? Let me just create a new function, person.prototype.print this function, console log this, save this, and now I'll just call it here, print this. And now if I go back, if I refresh, as you can see, this returns the object. So basically this is a keyword that is used to refer to the current object. Similarly, if I were to console log this here, which is outside the class, outside an object, outside a function, I will get window. So the way JavaScript works in the browser, it at the end everything is attached to window. Window is an object that is on the JavaScript browser. It is managed by the browser. You are supposed to add things or remove things. So if I create a variable here, var name is equals to Peter, and save this, and if I go back, refresh, if I type in Peter, okay, maybe I should type in name. So if I type in name, this is what I get. If I type in window.name, this is what I get. So this is what it means. Now, if you take a look at the keyword this, it is used to refer to the current object. So here, when I use the keyword this, it basically transforms this call into john.name. So to avoid confusion, it's called the this keyword or the context. Basically what we're doing here is we're saying, okay, for this object, the current object that I'm trying to create, whatever value I have assigned to the name and the age, print those. So this dot name means John's name, print that. This dot age means John's age, print that. And here this basically means print the entire John object. Don't print individual properties, just print it entirely. So this is what happens. If I go back again and I show you something, refresh, this is what it has. These are the two properties. Open it up. This is the prototype. Open this up, and it has these three functions: print this, say age, say name. And this is the constructor function that takes in the name and the age. So this is how JavaScript works underneath the hood. Now in ES6, there are new ways of creating a class, but this is how it works here. So you can create a class. These are the objects. Now you might be wondering, how is it different from creating a new object? Let's say I call it John, make it equal to this, put name equals to John, age equals to 35, and then I add these two functions. Let's say name function, and the similar thing. Just think about it this way. So how is it different? Well, the main difference here is, let me just go back here. Instead of John, I'll just Johnny. Save this, go back, refresh, GOHNY, and this is here. Now, so the main difference is this is something that you can't reuse. Once you created the variable Johnny, that's it. Now, if I want to create another person with the same structure, here all I have to do with John, I will create Johnny, and his age is 40. So now it has all the properties that a person class has, which is this, which is the name and the age. It also has the name assigned to be Johnny, it has the age assigned to be 40, and it has these functions automatically. So I didn't have to create a new object, copy and paste the code. As we want to reduce the amount of code we write, we do it this way. So use these object literals, these ones that we create like this. You can use them, but use them when you want to create just one-time thing. If you want to create something that needs to be accessed and change the data of multiple times, then these functions are important. This is how you can do it. Also, these data is also called, in case you ever come across this, it's also called properties. And this is how it works. So this is how you can create a class in JavaScript. This is the old school way. There are new ways of doing it, and we'll discuss this when we're discussing ES6. But right now, this is how you can create a class. It will work with all kinds of functions. JavaScript had a difficult start with object-oriented programming. It was earlier not designed to be an object-oriented language. Then object-oriented programming came into being, and now it's like this. So this is how you can do it. This is why functions were repurposed to be classes and objects. So you can do it this way. There are other ways which we'll discuss in later sections, but right now you can understand how you can do this. Right, let's take a look at what next we can do. Finally, take a look at JSON. JSON stands for JavaScript Object Notation. It is a popular data transfer format which uses syntax similar to JavaScript object, which can be serialized and from and deserialized too. So basically what happens is, when you're trying to exchange information between two programs, and these two programs may be of different language, you need to agree upon some common format in which you will be exchanging data, so that when you create that format, put the data in and send it to the user. The user can then take data out of that format and understand what you have written inside it. This is where JSON comes into play. Similar to JSON, there are other alternatives available, such as XML and YAML or YAML as it's called. However, XML is quite old, it's quite verbose. YAML is quite new, but it's not very useful. JSON has turned out to be one of the most popular data exchange formats. It is based strictly on JavaScript object notation, which is basically how you create objects in JavaScript, with a few notable exceptions, although it's quite similar. We don't add functions and all, but we'll discuss those in the hands-on. Basically, JSON allows us to add data to an object, convert that object into a string, send it back to the user, which may be a Python program, which could be an Android application, could be anything. Usually it happens in client-server communication, but other programs do that as well. Once that data is sent, that data will then be parsed and converted into an object that programming language can understand. And once that's done, you can then extract data from that object and use it however you wish to. Basically, JSON allows us to create a stringified version of our objects and parse a string in order to understand how to extract objects out of it. So let's take a look at how that works in the hands-on. So if you open up your browser, open up the console, and now let's take a look at how JSON works. Now again, JSON is like everything else in JavaScript, is a object in JavaScript. So let's just show you. And it contains a lot of functions that we can use for our purposes. In our case, it's parse and stringify. These are important functions, but first let's take a look at the syntax. So whenever you're trying to create an object, let's say that I am trying to make an object, I'll just create variable data equals to, and I'm sending back the information about the user. Let's say the ID of a user is 1, name is John, age is 56. So if I take a look at the data now, it looks like this. Now this is fine, JavaScript can understand this and it can parse it. But if I were to transfer this data to some other language or some other program such as Python, C++, Java over the internet, this will not work. Firstly, it will just be sending over a bunch of bytes that JavaScript can understand but other languages can't. So we have to convert this into a string. Now, to convert this into a string, we can't just wrap it inside this. For instance, we can't just do it this way, because that makes no sense. Because let's say that if I have some double quotes in there and this is a long file, then I have to go through the entire system. So the other way of doing it would be to use JSON.stringify. Inside it, I'll just pass in the data, and as you can see that this has done it for us. It has double quoted the entire property, double quoted these things that we need, the properties that are strings, and it takes care of all of that. So this is what the data is. Now if I want to send it to a user, I can send it. If I'm creating a web server, I can just pass it to the user. They will get this data. Let's say that I am that user, I get the data now. So I'll just get const string is equals to, not const, but variable string is equals to this. So now if I take a look at the stringified data, this is what it looks like. But if I want to parse it, I can just go json.parse the string and we get back the object out of it exactly the way we want. So this is what JSON allows us to do. Now suppose I'm creating a web server, I get the data from a database and I want to send it to the user. So sending it over the internet, I need to convert it into a string, which I do using this. So json.stringify.data, this is what gets sent to the user. Now let's say I'm creating a front-end application, I get the data and I want to convert it into the JavaScript objects that I can use. Just use json.parse on the data that you receive and it will work exactly the way you wish for it to work. So now this is how this works. There are other ways of dealing with data with JSON as well, but they are quite complicated and not very useful because they are really difficult to implement. Basically, you will be re-implementing the stringify and parsing functions yourself. That's not very useful, so we recommend that you do it this way. So with that, now let's take a look at what else we can do. Alright guys, now let's take a look at ES6 features. So JavaScript has been around for a while and new features have been added to JavaScript in its 2015 version. That was a major revamp of the language and it was called ES6. ES stands for ECMAScript. ECMA or ECMA is a standardization committee which takes care of standardizing JavaScript features across the browsers. So in 2015, JavaScript had a major revision called the ECMAScript 6 or ES6. It added new features and new syntax to make our code more concise. So this is basically syntactic tuning. New features were added in order to make our code easier to read, easier to understand, and easier to write. So these are some of the features, some of the most important features we need. So we'll be discussing those now. So let's take a look at them one by one. First thing is declaration. Now for declaration, what we need to do is we need to find out new ways of declaring a variable. We have already understood that there is a way of declaring a variable using the var keyword, var. However, two new keywords were introduced called let and const. And these were variables that were introduced because var had specific drawbacks, which we'll discuss. And then we'll take a look at how to use let and const instead of var. So to understand this, first we have to understand what exactly are the drawbacks. Then we'll move on to how these drawbacks are solved using this keyword. So let and const will take care of the problems that were created using var. Now let's take a look at the hands-on for declarations. So for this, we'll have to use the let and const keywords. So again, we'll go back to the same code. Now this var keyword is what we use to declare a variable, right? So if I create a variable named name, put John inside it, save it. Everything works, and it doesn't really take away from the fact that it's going to work just fine. So if I take name, print it, it's the same thing. However, notice what happens here. So if I create if name is equal to John, then create a, let's say that we create a variable, it's called count, which is equal to 1, and then we print it. Console.log, there are count or there is would be appropriate. So now if I go back, refresh, there is one John. I think I printed 0 here somewhere. Count is 1 and the name is there is now, so there is one John. But if I take a look at the count variable, it's also available outside. So this is a problem. This is one of the problems. So what happens here is this: whenever we declare a new variable here, even if it's inside an if statement, it will be available throughout our code. So it will be available here. I can use it in another if statement as well. If true, console log count, and this will work. This is a real problem. It might not seem as such right now, but the problem here is this. Suppose you're working on multiple files and you try to create a new variable. This variable is now called, you create a new variable, you want to get the username. So you get the name, you ask for a user to enter the name, and what you have essentially done now is you have overwritten the value that might be used someplace else. So now if in some other file someone has already declared a variable name and they will use it when user clicks on a button or something, they'll get the name that you have declared instead of getting the name that they have declared. This causes a lot of issues when you're trying to build applications at scale, when there are multiple files that you need to take care of and how to work with them. So in cases like this, what we can do is we use the let keyword. The let keyword won't let the respects the scope of the variable. So if I go back, finally all I have to do is change var to let, save it, go back, and now if I try to use the word count, it says no variable named count is defined. This process of getting the variable from here, which is what happened with var, and putting it at the global scope, this is what's called hoisting. This is a problem in older versions of JavaScript, and this is why the let keyword was created. Now there's another kind of variable called const. This is what const looks like. And contrary to popular belief, const doesn't mean that you will have a new variable that can't be changed. So for instance, let me show you. Const person is equal to, and let's say I call it a person. Now if I were to change this, I can obviously do so. Person is equal to another, and now I can't change it here. So that's the way const will work. It will not allow you to change a variable. However, if I had, let me declare another one. John is equals to, and John's name will be John. Now, if I were to change John dot name is equals to Jane, this is allowed because I'm not changing the reference of the variable. I'm just changing data inside it. So but if I were to apply this, then it's going to get, because you can't reassign a variable that is declared using const. Had it been declared using let, so let's say let x is equals to x, and now if I want to assign y to it, I can. So this is how const and let work. This is the difference. The problem was variable hoisting. Variable hoisting basically means you get a variable and you assign it in some scope, and you don't want it to be accessible outside it, but it is accessible outside the scope, and that causes a lot of problems. So for instance, if I were to declare a variable here, this will be pulled out here, and then we'll be using it. When the JavaScript runs the code, it takes a look at all the variables, pulls every variable at the top, and now everyone can use this variable. So this would mean that a lot of people will be stepping on each other's toes, and it's going to be really difficult for them to understand what exactly is going wrong, where is this variable declared, and how can I get it to work better. On the other hand, once you're using this, you can use the let keyword, and this will respect the block scoping that we use. And the const keyword is used to declare constant variables. Now, which one should you use when? Basically, the recommendation that many JavaScript developers give is always use let and const. Now, start with using const at the beginning, unless you need to change the variable someplace else. First, use the const keyword, assign some value to it. If you need to change it someplace else, then change the const to let. Basically, don't use var. Never use var, because better options are available, and this could lead to difficult problems. So that's how const and var work. This is what the new ways of declaring a variable is, and you should use them. Most browsers support these new ES6 features since they have been outside for ES 2015. So they have been available for public use since 2015, and most browsers support them. In case you want to convert this code into a code that older browsers can understand as well, there's something called a transpiler. So things like Babel.js, they will take your code written in ES 2015 and convert it into something that older browsers can understand as well. You can take a look at that if you wish to. All right, now let's take a look at what else we can do. Arrow functions. So arrow functions provide a new syntax to create anonymous functions in a very concise way. Since we have already taken a look at functions such as map, filter, and reduce, which take in functions as argument and give back in response the result of those functions, these functions that we pass in are called anonymous functions. They have no names, they are only used once. But it's a little difficult to write the function syntax the same way that we have done earlier. So in order to reduce this, since all we're doing is creating a function that returns some value based on the values passed into it, we can use arrow functions. Arrow functions are available in other languages in the format of a lambda. So if you've ever worked with Python, you can understand that arrow functions are similar to lambdas. Lambdas are also functional expressions that can be passed from one function to another. Similarly, this is what happens here as well.
So guys, I hope this session was helpful and informative for you. So that's it for today, and meet you in another session.
Thanks for watching.